let's say only a few seconds and it should switch back to. So we're live. Can you check? Yep.
Yep. Yeah, there's Ian.
Okay. Cool. Awesome. Well, I'm sorry for a couple of minutes late. Was trying to figure out the Zoom to YouTube connection, and thank God everything is working fine. All right. So let me just start this presentation. So
that's a little delay on the video.
Who was that? Yeah, I know. Okay, well, so thank you very much, everyone, for joining us today. So this is the InfoSec Jupyterthon 2021 edition. It's unbelievable that it's happening again. Last year was technically only my brother and I just trying to figure out what is the best way to start sharing content with the community. And of course, with everything that happened last year, then it kind of makes sense to do it virtual. And we were not expecting too many people, and then all of a sudden we had a kind of like over 400 people, registered. So that was pretty cool to see how many people were interested in, Jupyter applied to InfoSec. One thing that is going to change this with this edition is that now we're actually going to have a couple of workshops, content before all the main talks, so people can start getting familiarized with Jupyter notebooks, and maybe have some of the topics that some of the speakers are going to cover. They're not going to be strange, something new, but at least something that you feel more comfortable with. Okay, so first I'm going to go to the InfoSec Jupyterthon.com. It's pretty much where we're going to have the agenda for today. So if you click on 2021 edition, it's going to tell you every single talk that is going to happen. Starting right now, it's just a welcome to the community. We are in Pacific time zone, so just remember that. And then tomorrow we also have, again, workshops, and then we have the main talks. Okay, so let's start with this welcome to the InfoSec Jupyterthon 2021. And I'm going to start with this notebook right here. There you go. There you go. Okay. So just in case, for those that might not know me, so my name is Roberto Rodriguez. I go by CyberWarDoc in Twitter. And I'm also a principal threat researcher for the Microsoft Threat Intelligence Center, specifically the R&D division. I love open source. I love to also blog about things that I do not want to forget and things that I also want to share with people. So that's so important also to make sure that I can get some feedback, and also potentially, helping somebody else out there. I'm also the founder of the Open Threat Research community, a community that we started to start meeting other security researchers that were passionate about sharing and collaborating, maybe working together in some open source projects, and then at the end, helping the community in general. And if you want to see all the open source projects, right, company agnostic type of initiatives, go to the OTRF public GitHub repository, and you will see everything that we are doing pretty much like every day. And just in case, something non-technical, so there is this site called InfoSec Well Done, and there is actually a GitHub repo behind it. And this is a place where you can just find recipes that I have put together, and then also recipes from other security researchers in the community, and recipes to to cook something, right? Something in a few minutes, especially working from home. It's always good to have something different to do besides cybersecurity in general. Okay, so one of the things that I wanted to share today first is what happened last year. So once again, we had a little bit over 400 people, and of course, not everybody answered this question. That's why maybe it doesn't add up to 400 more people. But it was nice to see the different industries joining, like how much interest they had in Jupyter notebooks. And then starting then in 2021, that was very interesting to see then more people. Oh, let me just make sure that I have the right documents in here. Oh, that's why. Okay, yeah, sorry about that. So let me just move this real quick. There you go, day one. So just maybe to start talking about Jupyter notebooks right away, right? So this whole presentation is being driven by Jupyter notebooks in general. So then what we can do is just use the platform to start showcasing everything that we're putting together, just as if you were writing, code in general, and then just make it interactive. So one of the things that of course is very interesting here is that this needs to be in a different folder. So this is actually good. So we can maybe troubleshoot some of this as well. But if we cannot do that, I can just easily jump to the session in here, and this is going to be the same material. So this is something also that we wanted to do, is to start sharing all the content directly to the website with input, output, images, etc. Okay, so this is what I was trying to show you. So there is a document that we actually collected after everybody registering to the Jupyterthon. And we try to see exactly how many people were going to attend. I ran this 2 days ago, and we were already over, I would say, 600 people or 700 people. And of course, in the last couple of days, then a lot of people just joined. And then now we went over kind of like 1,000 people now until, I guess, a couple hours ago. So that's pretty cool to see, once again, going from 400 people to 1,000, just to see how many people are interested in Jupyter, Jupyter notebooks applied to InfoSec. Last year also, we had a lot of beginners, as you can see, like 320 over the 400 people. And then this year, after getting all the information, once again, we still have a lot of beginners. And that's why we decided to have, workshops at the beginning to make sure that we have everybody more comfortable with Jupyter notebooks in general. Now, another thing that we wanted to do is to understand exactly what it is that you are expecting from this, whole Jupyterthon event. And what we're trying to do is to see exactly what are those, little words that everybody was typing over there. And as you can see, so one of the big ones, right? Team, use cases, automation, workflow, hunting. There is definitely a lot that people were typing through their answers. And it's amazing just to see how, well, first, that team is, one of the biggest ones in there. So one of the words that was used the most. And that's just amazing to see how you can start associating Jupyter notebooks with, with like teamwork and working together, collaborating, etc. Right? A couple of things, housekeeping. So this is going to be, of course, recorded. All the live stream links from YouTube are going to be also be available publicly after this live stream. So feel free to share that with somebody else, and they will be able to watch this all over again. Everything starts, once again, 8:30 Pacific time, all the way to, I would say, 5:30 p.m. again, Pacific time, day one, and a similar day, of course, day two. And then if you want to, so I would say, join the conversations, we are not enabling the chat through YouTube because we want everybody to start collaborating and talking in our Discord channel or Discord server. The invitation is in that link. Once again, this is actually part of the InfoSec Jupyterthon website, so you can just go there and then get all this information. And then social media, we have our Twitter handle, Jupyterthon, and we have also this hashtag that we're going to use also to share a couple of things. For example, I would love to know where everyone is joining us from. So feel free just to tweet about it, and we would love to see exactly where everybody is watching us right now. Also, there's going to be some, of course, interactive talks, especially in the workshop. So interactive means that you will be able to access, let's say, either infrastructure in the cloud or locally by running a Docker container. You will be able to then start maybe going through some of these notebooks. The way how that's going to be done is, as you can see in this specific page in the website, there is a little rocket on the top, and that's called Binder. And then this is the link that you would click on a page where you see the link, and then you will be able to go through the whole presentation. So what I would do, for example, if I were you right now, because this is driven by a Docker image, so the moment you click on it, the Jupyter Notebook server is going to be built in the cloud for free, right? That's just open infrastructure. It has its limitations, and we're going to talk about them in a little bit. But if I were you, I would actually click on it, and that should take you to building a Jupyter Notebook server. So it's going to start building the server for you. And then once it's ready, then it's going to be available for you to start exploring all the workshops and of course, all the material that we have for you today. So I will do that right now because it might take some time to start building the Docker container as I start going through the first session. So any questions so far in the link? Any question? No? Okay, cool. So let's then go to day one. So we're going to switch here a little bit. Let's see, docs, workshop, day one, Jupyter introduction. All right, so how are we doing with time? I think we should be good.
Yeah, we're good. Yeah.
All right, so the workshop, once again, is going to start with a session about Jupyter Notebooks introduction, and go back to the agenda and check exactly what you're going to be going through. Also, one more thing, if you go to the InfoSec Jupyterthon.com again, there is a section called workshops, and these are going to be all the sessions that we're going to be going through for the beginning of the day, today and tomorrow. So if you click, for example, in Jupyter Notebooks introduction, that's going to be the notebook that that I already have running in here, for example. So this is exactly how I would represent it, but you can easily first, just go to the site and you can follow through this whole thing. Now, workshop 1, and I would say at the beginning of workshop 2, section 2, it's more about talking theory. It's more about going through what Jupyter Notebook is, history a little bit. So there is nothing to do interactively yet as a whole. So I would definitely don't worry about trying to see if your binder is being created yet. So just leave it there. One thing that I will tell you to do is actually to use a Docker container, once again, that we prepared for you. So you can easily just download it locally and then start using it. And if you have, please, any issues with that, if you don't know how to do it, there is actually a couple of instructions too. So let me just go to the InfoSec Jupyterthon. There you go. There you go. So this, I would say, this event, of course, is also backed by a GitHub repository. So you can see the same thing that is in the website, also in this GitHub repository. This folder should be updated with everything that also you will see in the website. So for example, right now we are doing day 1, Jupyter introduction. So even if you click on it as well, it should populate, the whole notebook that I'm about to go through right now. So you can easily also git clone this repo, and the Docker file with everything, it's also here if you want to build it yourself, or you can simply just do Docker run, and I'm going to show you this in a little bit. You can actually use Docker run and download an image that is already built for you. So there's a couple options, but once again, the first section is just to talk about Jupyter Notebooks, and then I will tell you exactly when you're going to start downloading the Docker image if you want to download it as well. If you cannot wait, so Jose, if you go to Jupyter Notebooks introduction, there is a section for installation of Jupyter Notebooks. And in that section, there is actually one command that people can run. So that would be the Jupyterthon OTRF Docker image. So if you can please copy that to the Discord channel for those that cannot wait and they just want to start downloading the Docker image. But this is a section from introduction. Okay, so I hope that there is a lot of material out there. If you have, once again, any questions, please let us know. We have 5 people already just waiting for questions, anybody who would like to follow. Okay, so let's go back to the presentation in here. So Jupyter Notebooks introduction. So this is going to be just a little bit of overview. Now, this is my favorite way to start talking about Jupyter Notebooks. I believe that we need to get up to speed, like what's going on with Jupyter Notebooks. And at the same time, for me, it's very important to understand where everything actually started, It's always good to understand exactly where we come from, So it's, to me, this is like the most interesting part in here in the first couple of slides in this presentation. But so let's start all the way from, for example, the idea of interactive computing. trying to make a computer to do something for you, right? And all the way back to the 19th centuries, right, the 1800s. So Ada Lovelace is considered the author of the first computer program, right? And that's amazing because pretty much what she was doing is understanding one of the first computer, which was called the analytics engine, for example. And then instead of just calculating numbers or crunching numbers, she wanted to understand how actually the computer could have an algorithm, or you provide an algorithm and then make the computer do something, right, different, or that algorithm wants you to do, right? So that was pretty cool just to start thinking about that back in the 1800s. Then we have Grace Hopper, 1952, creator of the first compiler, right? Going from high level to low level language, right? So let's say plain English to machine code, right? So, very amazing, amazing women back once again, 1800s, 1950s. 1953, we have Katherine Johnson, right? One of the first NASA human computers, right? And there is actually a movie about this, right? Hidden Figures. And this is, to me, the reason why I mention it also is because part of the idea of Jupyter, or one of the main ideas behind Jupyter Notebooks, or the project Jupyter in general, is of course interactive computing with the human element in the loop, right? And it's amazing to see that, for example, before you had human computers were doing a lot of things manually, but super smart people going through all these problems. Now just imagine if a Jupyter Notebook maybe was available back then and they could use it for some of those calculations, right? Then we have 1991, Guido, right, creating Python. So 0.90 version was released in 1991. And then I believe in the 2000s is when version Python 2 actually came out. Now, then we get to Fernando Perez from Colombia, Medellin. And he releases the first version of IPython. That's in December 10, 2001. And pretty much the idea here was he was so in love with Python, and he was using Python a lot, but he wanted to enhance the interactive, I would say, console of Python, right? So when we are in our computers, we can just type Python, and then we are dropping to this interactive console, but of course, with not too many features. So December 10, 2001 was the first time that IPython gets released, and this is, of course, an enhanced console to interact with Python. In 2011 is also to me, like, that was very interesting. I didn't know about this, but version 0.11 is the first time that we see IPython online version. So what that means is that you could actually start interacting with the basics functionality of IPython through a website. And that's actually part of the IPython news sites as well. So you can see all the stuff, all the versions with all the new features. 2011 December is when the first IPython notebook was released. So when we talk about notebook with IPython, was how can we take all these enhancements to the interactive console, like, for example, some statistical, scientific operations on the top of maybe some visualizations. How can we take that and now start showing it as a browser, for example, as part of a browser? So that was the IPython notebook in December 2011. And then, of course, Fernando Perez and the rest of the team now working on IPython realized that they had an infrastructure that they could actually use with different languages and not just Python. And of course, Jupyter started, or still stands for Julia, Python, and R, for example. So 3 different languages. So trying to make the project a little bit more language agnostic, right? Because they realized that there is some interactive computing kind of like platform that they could use with other languages. Jupyter Hub came out in 2015, and here's when we start actually using Jupyter Notebook servers. So start giving 1 server per user, but that's being managed by a Jupyter Hub, by a proxy that allows you to then redirect your connection to your own Jupyter Notebook server. So this is great when you want to teach with Jupyter Notebooks. This is great when you want to have all these different classes using Jupyter Notebook as well. 2015 May also is when GitHub starts rendering Jupyter Notebooks. And that was also something that it's still not the best, I guess, still, but it's amazing then to start having those features also through GitHub. The Binder project then. So Jupyter Notebook now exists. There is some collaboration. There is some data analysis going on, some scientific research going on. Now we want to share that in an easier, in an easier way with somebody else. So the Binder project started as a way to host infrastructure. Well, first, let's say you have your Jupyter Notebook, you have your research. You can put that, for example, in a GitHub repository, give it a file that would allow you to then interact with the server, like deploy a Jupyter Notebook server, and then make that part of a deployment in the cloud that you can access also through your browser directly. So infrastructure hosted in the cloud, all you have to do is provide your research as a notebook, and then that will be available in the cloud. So similar to what we were doing in here, where we just click a Binder button on the first page of this events website, and that's being built right now in the cloud. So once that's done, then we can start interacting with this Jupyter Notebook server through the browser and of course host it somewhere else. So that was the idea of Binder. Jupyter Lab 2018, that's when now we take the classic Jupyter Notebook interface and now we take it to the next level. And I'm going to show you exactly what that looks like, but it has more features. Now it's considered the default interface to interact with Jupyter Notebooks. So it's amazing now to see that just happening, right, a couple of years ago. And then in 2019, Jupyter Book also, became a thing. So what does that actually mean? So a Jupyter Book is, let's say you have documentation in sites like Read the Docs, right? You have a Markdown file, you have an RST file, and you can just write your Markdown documentation. What if you can actually also have a Jupyter Notebook and is still interact with the notebook in your, let's say, Read the Docs style, right? Like sites that you create to share the documentation of your project. Well, Jupyter Book allows you to have interactive computing through your docs of course, in a website. And then you can also integrate your website with the Binder project. So you can actually execute your interactive documents that you have in your documents, in your docs. And then you can actually have the Jupyter Notebook server being hosted by Binder, and you can pretty much start also executing tasks that you had in your notebooks in the first place. And then 2021, right? So we have now Jupyter Lab in the browser with Jupyter Lite. And this is something also, once again, everything is just built in your browser, right? But that, of course, does not have any external dependencies and does not have, of course, any, Jupyter Notebook servers locally. Now, everything is just pretty much compiled. It uses C Python, and it's compiled with WebAssembly. So then you can actually run a Python environment in your browser, right? And that's just amazing. You can actually install Python libraries in your browser. And this uses PyODie, and the kernel that it uses is PyOLite. So this is also something interesting that kind of like, I didn't think that was before, of course, a couple of years ago possible. So now it's a thing. But it's not an official project of Jupyter, but it is, of course, maintained by developers of the project Jupyter. And the last thing that happened only a couple months ago, Jupyter Lab desktop applications, standalone, self-contained applications, cross-platform, uses Electron, and it can actually be installed in your Windows computer, in your other platforms as well. So this is also another way to make this solution more portable. And this, of course, it's so amazing just to see all the way from people just thinking about interactive computing or simply just trying to tell the machine or anything to execute something for them with a human in the middle, human in the loop, all the way to now make these solutions portable. And this is what the essence, I would say, of Jupyter Notebooks is. Now, so just think about it, 2001, now we're 2021. Now, of course, yes, Jupyter Notebooks or Jupyter in general have been around for a couple of years, but as you can see, all the cool portable features and capabilities to make it easier even to share and collaborate, that just happened a couple of years ago. So we're still in time, right? So we're in the right time to learn about it and start getting more familiarized with all these solutions. Okay, so as I mentioned before, what is interactive computing? It's time. Interactive computer, as I mentioned before, is just a way to, once again, perform an action with a human in the loop, right? And this is something that is the main concept behind Jupyter Notebooks. So this was actually, let me just go down, there you go. Interactive as protocol, this is something that, for example, Fernando, right, the creator, Fernando, the creator of IPython, right, the initial concept of Project Jupyter, took this basic concept, right, something called REPL, where you can just wait for a user input. That input gets processed by a kernel. That's the two-process model, and then right, the results get sent back to the client, the interface that the user is going to use in order to send those requests and retrieve the results. That's the basic concept that started, IPython, as I mentioned before. And once again, back in December 10, 2001. And the amazing thing is that this project was actually part of the projects were already being thought of, designed a little bit. Some of the main parts, I would say, of what Jupyter project is, or some of the ideas, the research behind, was actually being put together by a couple of people. So Fernando reached out to others and they started kind of like sharing some of that research. And it's amazing that the project, even at the beginning, it started just with basic collaboration. And you can see that link at the bottom. You can learn a lot about the history of these, interactions. Okay, so IPython, how did that make it all the way to be Jupyter? And so this is kind of like the idea before moving to Project Jupyter. If anybody was wondering what actually interactive Python meant and how that translated to IPython, so you can see on the top left, you can see the basic interactive Python interface. You can see the initial IPython project, and then on the right, that's the IPython notebook. So how we can take that to a browser, for example. So that's very interesting. Now, the inspiration behind this, of course, it was a lot of once again collaboration, empowering others, provide tools, tools to others that might not have the privilege maybe to have them available for them. And then, of course, community, right? This is something that I like a lot: scientists collaborating and building better tools together. And that, of course, applies in any area of our community, right? InfoSec, there is a lot of areas of research, and that's the message that we should be actually sharing with others, right? So not too much competition, but actually collaboration, right? Okay, so how does the IPython once again move to Jupyter? In this case, so what happened was that the IPython framework or tool or the project itself, as you can see, there was a couple of parts to it. So we have, for example, the clients that are going to be interacting with the IPython server, the documents that are going to be used to then display all these input, output visualizations. But then the IPython team realized that there was a couple of things that were going to be language agnostic. And that's when Project Jupyter actually started, right? Because now they can have a platform that they could still use IPython as their default, for example, kernel, right, for Python, but they can actually have Jupyter. Once again, Julia, Python, and R, that's what Jupyter, right, would stand for. And then they could actually use it with other languages, right? So R, PowerShell maybe, or just any other language that has a kernel, something that you can use to execute tasks. All right, so with all these definitions, what are Jupyter Notebooks? So this is just an open source web application that allows you to, of course, share input. So that could be a code, it could be text, output, the results of the execution of something, visualizations, it's all in one place through a web application. When somebody says a notebook, that's a document of the project Jupyter. And we're going to talk about that a little bit in the architecture, but that's, the project itself is the project Jupyter, and the notebook is part of this architecture. And of course, a lot of the use cases for this is a lot of data cleaning, a lot of data analysis, right? Statistical modeling, visualization, etc., which fits very well with a lot of the things that we do or that we have been doing with other tools in cybersecurity. And of course, the idea is not to replace, the idea is to complement. So what does it look like? And this is pretty much the basic idea. When we talk about interactive computing, right? From the basics, without thinking about the whole background of a Jupyter notebook, is basically just trying to have a input in a cell and then have the output. And my kernel should be open, so maybe we can just change this, and that's the name of my dog. So instead of Hola Roberto, then we have Hola Pedrito, right? So that's, as you can see, even this document is interactive. So that's one of also the beauties of using Jupyter, the project Jupyter in general, with a notebook. So you can even have your presentations being interactive. So one of the things also that we can do is, of course, a couple loops. So you can just use, of course, different languages. We're using Python by default. This is the basic classic Jupyter notebook interface. It's very familiar. To me, it looks similar to a lot of document editors, right? When you can save the document, you can add, for example, a couple of cells, you can add some text, you can run a cell. There is a lot of different options that you can use. You can, for example, stop a kernel. So that means that you stop the engine that is going to be waiting for the request and executing actions for you. So if you type Python, it's going to execute Python. So you can shut down the kernel, start the kernel, change the kernel, for example, to a different language, etc. So you have to get very familiarized with those things. Architecture, once again, so there is a lot to go in the architecture. So I'm just going to mention at a high level. So there's going to be WebSockets communicating between the client and the Jupyter server. The client is what the user is going to be interacting with. In this case, a notebook through a web browser. Jupyter server is going to be hosting the Jupyter notebooks in JSON format. That's the Jupyter notebook, the document. And then we have 0MQ, which allows the distribution of actions and all these messages to the kernel so that it can actually execute something. And once again, language agnostic, not only Python. And we're going to talk about that also in a little bit. Okay, Jupyter notebook deployments, you can do it manually. The classic notebook, once again, that's being, so as far as I know, it's not going to be supported in the future, but it's good to mention it, right? That's just the classic notebook. You can install it with Mamba or Conda or pip. But then we also have the, let me just go back. We also have the Jupyter, we have the Jupyter Lab as well. And at the same time, you can actually then use Docker to then deploy a Jupyter notebook server. And then, so instead of installing things with pip, local manual and everything, you can just run a Docker container. You can download that Docker container and then just execute it, right? So one of the things that definitely will be good to do, and this is a video, which by the way, we're doing YouTube, streaming a notebook, and then playing a YouTube a video inside of the notebook. So this one just talks about how you can use Docker run. You can set a port. By default, usually it is 88888, and then you can point to an image. In this case, for example, these are images, Docker images that are maintained by the Jupyter project, and you can just simply point to those Docker images. It will download the image, and then it will be it would let you actually run the Jupyter notebook server automatically. And all you have to do is copy the link that is at the bottom of this Docker running command, and you can land directly into a local Jupyter Notebook server. And that's what we were planning for you to do today. So if you have already Docker installed, there is already an image that was created for this, for this event. So you can simply do docker run ti rm-p, and this is going to then once again download the image, and then you will be able to run it locally, and you will have all the material from the workshop. So if we go back to the GitHub repo, everything that is in this folder is going to be in the Docker image. So if I were you, that's something that I would do right now, so you can then have it ready for the next next actually sections of the workshop. Then I talked about Jupyter Hub a little bit. So here is where I like to point that three things that are going on in here. So you have a hub, right? So pretty much this is what it's going to manage user accounts. So with a Jupyter Hub, you can have a username and a password so that you can then access your own Jupyter Notebook server. You have a proxy that is going to allow you to interact with one server, and then it will distribute the connection to your own Jupyter Notebook server. And of course, the single user notebook server. So try to remember that as well, right? Single user notebook server. So even though you have a username and a password, and you can interact or have a lot of users interacting with Jupyter Hub, you do have your own Jupyter Notebook server. And then this is just the architecture, right? So we have the browser, the proxy, the hub, and the notebooks interacting with all this information. And of course, the browser, you only see the communication with the Jupyter Hub, and then you can interact with your own notebook. We talked about the Binder project. Once again, it's a project that allows you to use open infrastructure so that you can deploy a Jupyter Notebook. This is being powered by Binder Hub, and Binder Hub is just a combination of different services. Once again, it starts with a cloud service, and then you can use the combination of the deployments that I just mentioned a couple minutes ago. Jupyter Hub, you have your own Jupyter Notebook server, all these being managed in a Kubernetes cluster. And the way that what it looks like is you can have your Jupyter Notebook server as a Docker file, so you can define exactly how you want to build your server. And then you can go to the Binder project website, and then you can just say, hey, can you deploy this server in my GitHub repo? And then it's going to go through the whole process where first it checks if the Docker image exists or not. If it doesn't, it's going to build it. So, and if it does, then it's going to use Jupyter Hub to give you a Jupyter Notebook server that's going to be your own Jupyter Notebook Kubernetes pod, and you can access that through the browser. And the perfect time was that, that our notebook actually got created. So this is the notebook that Jupyter Notebook server that I click at the beginning of this presentation. So mine is already built. I hope that yours is already built. And this, as you can see, is hosted in the cloud. Okay, so let's jump to the next part. This is just last sections in here. And so we already tried it, which makes sense. We talked about Jupyter Notebook flavors, like the Jupyter Notebook Classic. If you're using the Docker container that I say that you can actually use with Jupyterthon, you can run that and that command, and that should give you a Jupyter Notebook server in classic mode. Let me just go back. There you go. Yep. And then you can actually then also use a Jupyter Notebook in Jupyter Lab as well. And the instructions are in here. So if you go back to the GitHub, you can see there is a document to how to actually use the notebook servers. And then we have in here, for example, how you can run your Jupyter Notebook with a variable, and this will enable a Jupyter Lab interface. So that's pretty much it for this introduction of Jupyter Notebooks. We cover a lot. There is definitely a lot going on. And, so if you have any questions and how to use some of this material for your next sections, please let us know. I hope that this was very helpful. Once again, just to understand the history of Jupyter notebooks, all the way to how to deploy one and what are the different options that you have. And we have a break after this of
15 minutes.
15 minutes.
No, sorry,
5 minutes. Yeah, so we have a break for 5 minutes. So then if you want to maybe go through some of these slides, once again, you can go to the website, click on day 1, workshop 1, and you're gonna pretty much go through everything that I did, today. There's a couple sections that you can actually explore on your own. So for example, if you want to run your own notebook once again through Docker, there is a video for that. If you want to, how to install Jupyter via pip, just directly in your browser, in your local computer, there is another video as well. And then something that I didn't touch, but that's because there is a video that is kind of lengthy, but I wanted to have it there as a resource, is how you can also have VS Code, Visual Studio Code, and then install a Jupyter Notebook extension so that you can then simply create a file and you can then start a Jupyter Notebook kernel in your Visual Studio Code. So another flavor of how to interact with Jupyter Notebooks. And that's it. So we have 5 minutes. I have to go and walk my dog for 5 minutes. He was crying a little bit, trying to go out. So we have to go take care of him. If you have any questions, please let us know. We have people in the Discord channel going through the Discord channels as well and trying to answer any questions. All right. So we're going to be back at 12:20 Eastern time, which would be 9:20 Pacific time, which we're going to start the next section, acquiring data. All right, cool. Thank you very much, and I'll see you in a couple minutes. Okay, so apparently there is a couple questions or one question. So let me see if I can answer that before 12:20 my time, 9:20. Okay, so apparently there is a couple questions. Let's see. Okay, so it's Jose, my brother, playing with the live stream. Okay, so one of the questions was, what is the easiest way to deploy a Jupyter notebook? Well, I would say that, so there is a video in this first thing where, well, there's actually a video to install the app. So you can go ahead and then just download the binary, double click on it, and it will, install Jupyter Lab for you. The other one is, if you're a little bit familiarized with Python, there is actually one video that we have in here. So this one, let's see if I can maybe show you the video, but oh yeah, so I know what we can do. Give me 1 second. I'm going to share that video right now.
They're also suggesting binders too.
Yeah, binder for sure. It's one of the easiest way. Now, binder took a little longer than expected because it's a big Docker image. And it's because we have a lot of tools in there installed for the whole workshop. So that's why it took forever, right? Usually it would take 5 minutes, maybe 10 minutes. Yeah, but let me share a video with you right now. So just give me 1 second. Let's see. We're about to start the other section, but before that, I'm going to share this basic video. Playlist. I'm gonna copy paste that and put it in the, oh, here it is. Yes. All right, so I'm gonna copy that right now. All right, and I'm gonna put it in the Discord server. It's gonna be on the Jupyterthon thing there. So let's see, this is the video of installing a Jupyter Notebook server with pip. So that's going to be pretty easy to do it with pip. You can do it with Anaconda as well, or Conda. So this is why in the slides you can see you can do it with Mamba, for example, or with Conda, or with pip. So technically, when you download Python and you start Python, you will be able to run a pip command to just install the Python library locally. And that video shows you how easy it is just to, install the library and then just type Jupyter-lab, and then it will start a browser and show you a basic, I guess, Jupyter notebook setup that you can use right away. So I show you a lot of options, and once again, you can go through these slides and you can start working with them. Before I start the next section, because we're already in the next section, section 2, is that if you have not done this yet and you do not want to use Binder, I would suggest to run this image, and then you can, just have it for your workshop. You'd also have the document of workshop setup instructions, which pretty much at the end, as long as you have Docker installed, and the instructions are very easy in the website. This document is in our GitHub repository. You can actually run this command, right? I would add the tag 2021, and so similar to what I have in here. So here, then you will be able to get that Docker image up and running locally without installing anything. All it's doing is downloading 4 gigs, I think it is, 3 gigs of a Docker image. Very heavy image, but I hope that you can get it and you can follow the whole presentation. Okay, so let's start with section 2. So let me just maybe close this Jupyter notebook. Yep. And
1 hour.
all right, so we have an hour. And by the way, so this is my Binder Jupyter notebook server. And of course, there are limitations, right? Because this is open infrastructure. This is free. This is something that we do not manage. This is something that the Binder team actually manages. So something to keep in mind when you use these resources. Okay, and it's gonna time out after 10, 15 minutes. If it times out, what you can do is go back to the website, InfoSec Jupyterthon, go to the main image introduction, go to the rocket, and then click on Binder. Now, the image was already built, which means that you will actually use the same image because nothing changed or has changed in the Docker, in the GitHub repository where we have this Docker image. So once again, Binder goes to this Docker GitHub repository. It's gonna check where the last commit was, and it's gonna compare that with what they have in the Binder Docker registry. If it aligns, then all it's gonna do is download the Docker image in their own Docker registry and then make it available for you. If something changes in here, if I make a commit to this, when you click again the rocket, it's going to build it again because it's trying to get the latest changes. So we're not going to touch the GitHub repository at all. So you can just play with it. So if you have not done that, once again, click on it. And if you have already done it and it timed out, you can just go ahead, click it again. And for example, mine, I closed it because it might have timed out. As you can see, it's actually now directly launching the Docker image, the server, and now it's taking me directly to my browser. So you see, instead of waiting 15 minutes, it just automatically gives me a server. So you can then use that server and follow the specific sections that we have in here. So if you go to docs, workshops, day 1, then you can see the things that we're going to be talking about today, such as, for example, acquiring data, right? So for me, I'm running this locally because I don't want it to time out. So I'll just move to my local representation of this. So as you can see, it's in 127.00.1. And now I can just go through this notebook. So in here, we're going to talk about first some of the things that we can do. I think that this has some slideshow. Yeah, has some slideshow. All right. So this is also something interesting. So we are a team of 4 doing the workshop. You have actually the names, the beginning of the workshop. So you can see who is actually working in the workshop. The previous one was only myself. But now you can see that Jose and Ian are going to be talking about. So you can also reach out to them through the Discord channel. But what I was going to say is we have different styles of sharing knowledge through Jupyter Notebooks. And that's also the idea. We want to show you how flexible it is. I like to use slideshows through my Jupyter Notebook. Others like to use Visual Studio Code to showcase a notebook. Some like to use Jupyter Notebook Classic interfaces to show you a notebook, and some might want to use a Jupyter Lab, which is this right here. Jupyter Lab is, of course, a more enhanced, I guess, interface with a lot of features, a lot of extensions, for example, that are built just for Jupyter Lab. So there is a lot to do in here. So there is different ways to present, right? So I'm actually going to be using the slideshow presentation.
We only have 35 minutes for that section, so we have more time for the data, for the pandas, just to, you know.
Okay, so we're good. Yeah. All right, cool. So let's start with this. Let's see.
Hey, Roberto,
Yep.
before you start,
Go ahead.
let's say we had this is Ian here. We had a bit of a mix up with the agenda. We've actually, this session is like 35 minutes. We've shortened it to make the following session rather a lot of material longer.
Awesome.
So the published agenda is slightly different.
It's all good, man. It's a lot of free material being built in several and it's great.
Yeah,
but
being built as you watch.
Yes. Yes. So we should finish this one in the next 30 minutes, even less than that, right? I guess. So maybe coordinate with Jose and then he will tell me the time directly here. So yeah, thank you, Ian. So I'm going to then go through some of these sections. So this is going to be just some code that you can use to interact with some of maybe your favorite sims out there, some of the things that you use. So for example, you can actually use a Jupyter Notebook and interact with an ELK stack. And in order to do that, first in this classic Jupyter Notebook, there is a kernel. So we're using Python on the top right. And then we're using Python libraries to interact with Elasticsearch, right? Because we want to directly query Elasticsearch. This is going to use the Elasticsearch, I would say, initializing the connections. And then we're going to use the search class as well to define what is the index that I want to query. And then we can simply run a query string. And this is just a basic, right, query string, event ID 1. Now, something that I want you to remember is that if you're using Jupyter Notebooks to simply run one query, that you can run also, let's say, in Kibana, that might not be ideal scenario, right? Because you're simply just replicating the same. Now, if you want to process the data after doing that, yes, then it makes sense. If you want to join that with another data set from a different sim or from a different location, then it makes sense to query Elasticsearch and then process that and maybe enrich it with something else. And maybe do some queries that might not be possible maybe with Elasticsearch or, right? Who knows? So the idea is to complement what you already have. And this is actually the query at the end. So you can see this, what it will look like in my Jupyter Classic Notebook. Just by running 5 cells, I can import the libraries and then simply query my Elasticsearch database. There is also a blog post that you can go through, and it goes through a whole process of how to even do it with Sigma rules, etc. Splunk, another one, right? So if you are in Splunk shop, you can actually use David Bianco's HuntLib library. Super, super useful. Thank you, David, for putting this together. And this is now part of the target research team. So you can actually use that and import the Splunk DF class, which allows you to query Splunk and then bring the data as a data frame. A data frame, think of a spreadsheet where every row is an event. And then, of course, the column names are the names of the fields, right, of your event itself. So pretty straightforward, nothing crazy to do here. Just point to your Splunk instance, and then you can start searching for some data. SQLite. Also, you can start interacting with your SQL, for example, databases, right? And there is already a Python, a library for that. How do you know it's Python? Well, it says Python, but you're also installing it with the Python index, right? Like library to install Python packages, right? And then you can actually point to the database. This could be a DB file and directly start using something that also Jupyter Notebooks is good with, is to start using these magic commands where you can start interacting with some additional capabilities in the cell itself. The place where you type Python code, maybe you can switch it and type some markdown. You can use things such as SQL magics and then simply start typing SQL commands, right? And of course, this is part of the IPython SQL library. So you need to install that in order to start using these magics, right? So now if you want to run, this is something that I didn't mention, but I thought that I had said it before, but if you want to run a cell, you can simply select it and hit run, right? Run cell selected below, or you can simply do Shift Enter and it would run your cell. All of these already run for you because a lot of these things will connect to a database and we don't have all the database available, but you can start interacting this with your own Elks, Splunks, SQL database, etc. Another thing that you can do is actually interact with, for example, Azure Log Analytics workspaces. And in this, you can just use plain request Python libraries, for example. And then first, you need to have an Azure AD application with the right permissions. In this case, I'm pointing them in here so you can take a look at them. It's going to be the data.read app role. This is from a Log Analytics API service. All that information is also in this link, so you can learn more about it. And then before you interact with the Log Analytics workspace, you need to add your Azure AD application or give access to your Log Analytics workspace and just give it a Log Analytics reader role. So that way your application can actually interact with the workspace. This code will get you an access token. So the application now has permissions to interact with the workspace. Now you need to get an access token with that application so that then you can use the token and start running some code. This, of course, there is a couple of variables that you will need to fill out, but the idea here is to show you some of the code that I've used, for example, to query a workspace. And then, of course, after that, I can process the data. Same concept is going to be the same for the M365 Advanced Hunting API. So if you like Microsoft Defender for endpoint, identity, cloud application, etc., you need an application, once again, from Azure AD. Once again, all the instructions, there is actually, it's right here. So if you go to this site, it's going to explain to you exactly how to create an Azure AD application. This workshop is not to build Azure AD applications, but I have all the instructions in there for you to use. Permissions is going to be these two. And then this is the, I would say, resource that you're going to be interacting with using the similar code as how it was for the workspace. It uses the same concept. Okay, so I'm going to then now pass it to Ian. So now that you know how to interact with a couple sims, then you can start using, for example, the Mystic Pi library for additional things, interacting with other sources of data. Ian?
Yeah, can you enable screen sharing? Seems to have
Yes.
dropped off.
Let's see. I thought I had done that, but let's see. Okay, let's do it again. Multiple. All right, go ahead. And I will stop sharing. There you go. All right.
Okay, hello everyone. So my name's Ian Helen. Got a brief mention from Roberto earlier on. I'm a developer in Mystic, the Microsoft Threat Intelligence Center. Work with Roberto quite often. I just want to talk briefly about Mystic Pi. So Mystic Pi is a library that we wrote to try and automate, or like just make it easier to interact with a lot of things that InfoSec analysts want to do. And one of those is querying data. So although you can do kind of interact with the raw APIs, for example, with Microsoft Defender or Log Analytics, Microsoft Sentinel, we built a lot of that, the kind of code to hide some of that gnarly stuff. So one of the things, we've got a whole session about Mystic Pi at the end of these workshops, late tomorrow morning, but we'll talk about it in a bit more detail. But we wanted to do a bit of a plug for this. So it's an open source library that we wrote a while ago, gets kind of regularly updated. So I just wanted to talk about Mystic Pi query providers, which are things that kind of wrap these access to data. So it currently supports a few providers. I said Microsoft Defender, Microsoft Graph, Azure Resource Graph, also Splunk, Sumo Logic, and we're open to kind of building new ones. We're trying to build them as much as people kind of demand them. So the typical usage is you import the query provider class, you tell it which provider you want to use through a kind of string parameter. You connect, and then you're able to run a whole set of parameterized queries. So let's have a look at that code. So this is importing the query provider. Now, normally when you run Mystic Pi, we have this function called init notebook, which does a lot of this import, including it imports the query provider. So here I'm going to create two query providers. Since we wrote the code, Azure Sentinel has been renamed to Microsoft Sentinel, but we still call it Azure Sentinel internally. We'll update this, I guess, sometime soon. So I'm creating one that's for like Microsoft Sentinel and another one for local data. So this just reads either CSVs or pickled data frames from a local data path, which is useful for demonstrations and experimentation. So that should be done. That's all there was to it. You would normally see like a loaded or something like that. And once we have a provider, then we should be able to see queries that are available for it in autocomplete. And Roberto was saying earlier on that different people are going to be presenting in different environments. We thought it'd be good to kind of get you used to, it's all Jupyter under the covers, but you can have lots of different clients. So what I'm showing you is in Visual Studio Code. And all of the queries that are available for Azure Sentinel, these are kind of predefined queries. We'll talk about more about this on tomorrow morning, are available just as functions, as methods of this class. You can browse the queries available. So this is one particularly for Microsoft Sentinel. I keep trying to call it Azure Sentinel. It's going to take me a while to get used to that. Which gives you the parameters that it requires, and also this is a particularly complex one, and also what query it's going to run once these parameters are kind of substituted into it. An example of how one of those things would run is you just run it as a query. I'm just having head on the end there because this is potentially quite a long list. It returns a data frame with the populated results of the query. This is a quick example of how you would connect. We actually have a simpler way of doing this for Microsoft Sentinel, but all the providers have this kind of connect thing apart from the local data, and they will handle the authentication things. So you might provide a connection string, or you might provide a some kind of username, password, like sort of key pair values. Okay, and with that, I'll hand back to either Roberto or Jose. I'll be back in a moment.
All right, cool. So Jose is gonna be joining us in here, so I'll just give it to him. Okay.
Can I start the video?
Yep. Videos right here.
I guess the point about the last section is that even though you can write a lot of the code yourself, the main reason we wrote Mystic Pi was to make that a lot simpler. Anyway, I'll shut up now.
All right. So what do you go to the side maybe? Oh, that's the same notebook. Yeah, that's a notebook.
That's a notebook, right? Okay, everyone. My name is Jose. Hope you guys are doing well. Thank you for joining us for this acquiring data workshop. I'm talking about data, right? Roberto mentioned it about how can you access like different type of databases. And in the section that I'm going to talk about right now is how can you access data that is in a specific type of format. In this case, I will talk about security data sets, which is another project that we have in in OTR, that provides you with pre-recorded data sets in JSON format, which are basically data that we collect after simulating different type of behaviors. So what I'm going to do now is show you, you can run all this code in only one cell of a Jupyter notebook, but I would like to share with you is like the story, which is one of the features of using Jupyter notebooks, right? How can you tell the story behind what you do with your code, so you can share that with other people from your organization or people that you are learning more about Jupyter notebooks. Here. Okay, so the security datasets project, if you click on, you have the link here for the GitHub repo of the project where you have access to all the information there. So basically the steps that you need to follow in order to get the datasets is we will make an HTTP request to the GitHub repo. We will download the zip file. We will extract the JSON file that is compressed in this zip file, this zip folder. And then we will use pandas to read that JSON file. Okay, so first step always we need to import our libraries, right? We are using requests for the HTTP request. We are using zip file to manipulate the zip file object. We are using bytes.io to manipulate the data, the content of the data that we are getting from our request. And then finally, we are using pandas to read the JSON file that we are extracting. We have in our next section will be we will review more options to read data, different formats like pickle and also CSV files, which are formats that are also used in security operations. So what we are doing here is we are using the raw data link for a data set. This link will take you to the zip file that we have in the security datasets project in GitHub. So what we are going to do is we are using the get method, right, to get the content of this zip file. And the content that we are getting from this request, so the content that we are getting from this request is the format, right? If we use the type function, it's a built-in function in Python, to check the type of data that we are getting from this HTTP request, as you can see, the type of content that we are getting is bytes, okay? So what we're going to do is we are going to use the bytes.io function to manipulate this content so we can create our zip file object, right? Remember, all the pre-recorded data sets offered by the security datasets project is compressed in a zip file. So once we have this zip file object here, right, what we're going to do is, as you know, like any type of zip file or zip folder, right, can contain different or more than one file, right? So the zip file object that we are getting from this HTTP request could contain more than one file. So in this case, most of our data sets only contains one file, but I just wanted to show here that when we create this zip file object, right, what we get is a list, right, with all the files that are within this object. In this case, if we check the list of values, we only have one file, which is this JSON file. And then what we're going to do is extract this JSON file from this zip file object. So that's why we are using the extract method here. Now, when you extract the file, right, if you don't add any other parameter to this method, Python will extract the file, right, into your current directory. But in this case, I'm using this parameter path where you can specify in which directory you want to download the file. And what is interesting about this method extract is that you will actually this is when you actually download the file, right? Because previously all the methods that we were using, we were working in memory. So here's when you actually download the file, and the output that you get is the path to this file. Okay, so as you can see here, I'm printing the content of the dataset JSON path variable, and here you can see the path to the folder. And we are using this path, right, to read the file and get all the information from this pre-recorded data set. And in order to do that, we are going to use the read JSON method, right, from pandas, from the pandas input and output module. And something interesting that I would like to share here is the lines parameter, right? As you know, like when you create a JSON file, like every record of your data could be stored in multiple lines or only one line. In this case, the format that we use for the pre-recorded data sets from our project is one record per line. Okay, so you need to specify, or you need to set the parameter lines to true in order to read the JSON file. We will share more details about this in the next section. And that's it. And the output of this method, this read JSON method, is going to be a data frame, which is an object, a pandas object, to represent our data in an organized way. We will share more details about what a data frame is in the next section. And as you can see, I'm using the type function to validate that the object that we are getting is actually a data frame. And then just to start exploding the data set, you can use different methods, such as, for example, head, right? When you can start getting some values, some rows of the data that we just downloaded. So this is how you can access pre-recorded data sets from our security data sets project in GitHub. And now I can pass to Ian.
Yep. Thanks, Jose. So I feel like a bit like a slick kind of salesman coming in and saying, well, you could do it all like by hand code like that. And it really is good to understand how it works. But I kind of want to like to use things. I often want to get the information quickly. So we use the Mordor datasets quite a lot because they provide kind of great examples. Mordor, that's the Open Threat Research security datasets, used to be called Mordor. We still call it Mordor in Mystic Pi, but they're both the same thing. So we wrote a kind of provider to be able to do all the things that Jose just described, to be able to get that kind of a bit more slickly, although you don't really see what's going on behind the scenes. So I wanted to just show you quickly that in the last sort of 5 minutes. So we have another query provider. This time we call it with a Mordor parameter. I don't know whether we'll change this to OTRF or OTRF security datasets, but for the moment it's Mordor. We just instantiate it like that, no big drama. The connect is a bit more involved. There are no parameters, but what this does is retrieve some kind of metadata from particularly the MITRE data, because all of the Mordor data is categorized by the MITRE techniques and tactics. So once we've done that, then we should have a list of kind of queries available. And I'm just showing you the first 10 here. So each of these queries, well, this looks like a very long dotted string. This follows the path of how the Mordor data sets are stored. And each one of these is a function. So calling one of these, there are many, many of these. So browsing through them is a little bit, by hand is a little bit overwhelming, but calling them just return, oh, let me pick a whole one. Yeah, calling anything in a path higher up will give you whatever is below that. So let's call one of them here, and we can get the data set back. There are lots of different events in here, and it's quite a long data set. So let's just show you the top chunk of it. We also have a search function, so you can search within the data sets, and this goes through the metadata as well as the file path. So anything that has both empire and local group. You can also do queries based on MITRE tactics, techniques, awesome. from the command line. And as I showed you an example before, you could just pick one of those, query it, you get all of the data back. So not content with command line slickness, I kind of like, oh yeah, I wanted to show, so, and now this data is kind of available to be able to use with some of our other, and we'll talk about some of these in the Mystic Pi session, but just to show you that it kind of works like real data. We have to make sure that timestamps in there are date times that have been converted from coded JSON. But this is just to kind of show you a timeline of the different event types. So that kind of works well. So anyway, as I was saying, not content with having command line slickness. I like widgets. We'll talk about widgets in some of the later Jupyter sessions. It's a really nice, gives you a kind of, it enables you to build more helpful UI in your Jupyter notebooks, so that people don't necessarily have to remember parameters to things, where to find things. So we built one called the Mordor browser. And that kind of looks like this. Whoop. I can't fit it all on the screen because I kind of zoomed in quite a lot. But as you go through the different things, you can select them, and it gives you, tells you who sourced it, friend of ours. You can click on and download the data sets. You can also filter by either things like privilege or something like, let's do our favorite empire. So having got one of those things, we can also look at the techniques, tactics that are applicable to this. So this is just me displaying it. All of the hard work here is like Roberto and Jose doing the metadata mapping and stuff like that. We download it and we get a display of a, oh, also there's references to the, if there is a reference to a notebook or something in the open research kind of InfoSec, I've forgotten its name, anyway.
Oh, you mean the 300 playbook?
300 playbook, yeah.
There you go.
It will give you a reference.
We're doing InfoSec Jupyterthon, it's just a lot of acronyms.
There's a lot of, so this shows you a kind of a snippet of the data frame that's downloaded for that current set. Now that's only kind of appears in a UI, but you can get to it like current data set. So this is the browser we created early on. This is the current data set. And as you browse through and download more, it does cache them. It doesn't cache them between sessions, but it'll cache them in a single session. And anything you have there will be kept in. So as you go to download new data ones, the current data set will always reflect the last one you downloaded, but this data sets thing will keep everything you've done in a session, so you can kind of collect them. And it also it will leave the downloaded data files locally, so you can kind of get them by hand later on, or if you run this again, it will refer to the cached versions rather than having to download them again. Okay, so I think that's the end of this session. I did want to say we have had a bit of a mess up with not publishing an updated agenda, so we decided to shorten this session because as we were going through the pandas, introduction to pandas, when we found there was a lot of content there, we wanted to give that a bit more time. So we've split that into 2 sessions. So I can at least verbally, I'm not sure what, I think by the time we actually update it on the website, it may be already past the time that the sessions have happened. But but the next session is due to start at 10:05. That's the basics of data analysis with pandas. And we split it into 2 parts. So we're going to have a 45-minute thing, then a 5-minute break. Then at 10:55, we're going to do part 2 of that. That'll be 40 minutes, and then we'll have a short break, and we'll kick off the main thing with a keynote from John Lambert. So if you can remember that, 10:05 Pacific time, 10:55 for part 2, and then 11:40 for the keynote. That should get us back onto the schedule that's published.
Yes, so it's only this next section, and and then after that it's just all the same. We didn't want to update GitHub repo last minute. Then everybody needs to rebuild their binder. that would be painful. But awesome, man. Well, thank you very much. So we start at 10:05, right? Okay. So that would be my time, 1:05 p.m., which is great. Just making sure for those that maybe might be Eastern time, Pacific time. I'm really bad at time zones. So I'm always reminding myself, wait, that's my time is 1 p.m. or 5, right? So, because I'm Eastern, right, Pacific time and all that. Any questions, I guess? So any questions about this section so far? If anybody, I don't know, want to take a break or maybe just ask some questions now that we stopped talking a little bit, please let us know. I don't know if there's any.
One thing that might be worth talking about, I don't know how many people have joined Discord, but we're doing all the Q&A on the Open Threat Research Discord. So if you haven't joined that yet,
yes,
then do join it. So you won't see all of the things that I can see here, but you should see in OTRF conferences, there's a Jupyterthon section, and in there are workshop threads where you can ask questions. We may not be able to get to them immediately, so obviously the speaker's speaking at the time, but we will try to get to them at some point as quickly as possible. And there are other people kind of hanging around who may be able to answer the questions as well. So if you haven't done that already, please do that.
Yeah, so far, I think, so far we've talked about deployment, some of the flavors of Jupyter, some of the options to deploy something right away. Then we talked about how to acquire data. So directly from your sim, or maybe directly from a project that already shares data sets, right? Like pre-recorded data sets. And now we talk about also using Mystic Pi. There's gonna be a full section, right, Ian, of Mystic Pi tomorrow. So if you want to dive deep into that library, that will be tomorrow.
And we smuggled Mystic Pi because a few of us on the organizers of the conference are kind of involved in maintaining and authoring Mystic Pi, so we snuck it in various places. I feel like we're not making any money out of it, so it's a free open source project. So we're trying to get a bit of free advertising, but I think it was something we originally built because I started working with notebooks a while ago, and I was surprised that there were lots of like offensive, like things to like reverse engineer code and do attacks and stuff like that. There was very little out there that was helpful for defenders. So we ended up kind of writing things like we want to display some kind of a process tree or a timeline. How do we do that? There aren't things out there to do that. So maybe we'll have to write them ourselves. And how do we get to data? Well, we can do this through the raw APIs, but this is kind of tedious to do that every time you want to query an API. So maybe we can make it something we can have saved queries and stuff like that, just to speed up the process of, because Jupyter Notebooks is already, if you come from a non-programming background, there's already a bit of a hump to get there. So to try and make it do what pandas did for data analysis, you know, the more tools and things like that that we can have for making its use in InfoSec easier, I think the better.
Yeah, definitely. Definitely. I think that there is, so one of the first Python libraries that I saw, I guess, as a wrapper for other libraries that I talked about today, for like Elasticsearch and Splunk, is, you know, David Bianco. And that was one of the first, I guess, libraries that I was seeing out there for InfoSec. So that was amazing. And then I know that David, right, got super busy as well as everybody else, right, got super busy. And now, you know, he keeps contributing, as far as I know, to some of those libraries. You know, but then, you know, of course, there is so many different use cases to cover, not just querying a sim. So there is definitely room for a lot of other tools. So hopefully, you know, there is more development for different areas. So yeah, I think we have a few more minutes. And if anybody has a question, please let us know. So anyone else having permission denied to files within the container? I don't think we do.
Block has a comment that says just
what?
Block has a comment about just remembering people that to click on the threads in the Discord channel so they can. You know.
Oh yeah, if you have a question about a specific section, you can click on the threads under the Jupyterthon channel. So you can do that. Now the container, permissions denied. Let's see. Well, let's give it a try. We have a couple minutes, so let me see if I can try mine. Hopefully, let's see. 1 second. Yeah, no, I'm not sharing yet. I'm just trying to do a quick testing here. Let's see. So. Third cell in the Mystic Pi the section we're running in bind. All right, so let's try that one. We have 2 minutes, so I'll see if I can replicate that issue that you guys are having. I think, yeah. So let's see.
Yeah, that's hard because I tried it yesterday. Yeah, maybe we should share the link to the Discord channel. Somebody just, yeah, I tried it yesterday with and ran through several notebooks.
Yeah.
They all seem to work. I mean, that example is just reading from a local CSV file, I can't remember, which is in the data folder.
Yeah, I just tested a few of them from the container and it looks fine. So I'm gonna try to see if I can replicate that.
Can we also share a link to the Discord?
Yeah. So yeah, so let's see, Twitter. No, that, yeah. Oh, your community. Can you guys see the? Oh, let's see. Doesn't like me sharing, maybe. Yeah, so I'm gonna put it here. I don't know why this is quit unexpectedly soon. That's weird. Anyway, so this is the link. All right, we should be good. Can you guys hear? Can you hear me, Ian?
Yep.
Okay, something weird just happened. It's just maybe a connection issue. With. All right, can you see my screen? Just making sure that we're good in this side.
Yep.
Okay, cool. So yeah, this is the live stream. I'm going to put this, I guess, in Twitter. Right, I guess. Yeah. All right. So I'll tweet live. Yeah, the conversation. Join the InfoSec Jupyterthon conversations here. And there you go. Emojis are a must. So rocket and beer. All right, cool. So that should be good to go, I guess. And anyway, so that's a link for the Discord. So it's in Twitter as well, in case you can find it. But then it's also part of the Open Thread Research Twitter account. So hopefully that clarifies things a little bit. Anyways, okay, so we can jump to the next section. I will be going over on the side some of the questions in Discord. So I'm going to stop sharing and then we can.
No, I will start a section.
You want to start your section here? Yeah. So let's start with Jose. So, all right, Jose, take it away.
Please, do you have open the? Okay, hello again, guys.
Share.
Oh, let me share my screen. That one, right?
Sure.
Okay, so I'm here with my friend Ian. We are gonna go through this first part of the. Oh, sorry.
Basic.
This one, right?
Mm-hmm.
And now I can slow down because in the previous one I was speaking too fast. I was trying to finish on time that small section. Okay, so let's start with the last part of the first part of the last workshop of the day. Where we will be sharing about the basics of data analysis using pandas, right? In the first part, I will talk about how to just import the pandas library. What are data frame, which is the pandas structure that we will be using a lot during the tomorrow, right, in the second group of workshops. And then Ian will be explaining about how can you start interacting with data frames to perform some actions such as selection, filtering, and different methods, right, that you can use with pandas. And then in the second part, after a quick break, we will be sharing some basic analysis techniques that you can perform with pandas, such as selection, filtering, grouping, making some basic simple joins, right? And then we will finish this workshop sharing the basics of statistics using pandas, right? Pandas is a really good library or tool that you can use not only to manipulate the data, but also it has some methods that allows you to calculate specific metrics, right? Statistical metrics that you can use when analyzing your data. So Ian, do you have any, please introduce yourself to our friends, and then share some maybe ideas before we start with the workshop.
Yeah, sure. I guess I don't want the workshop content to appear too overwhelming. So we're going to be talking about a lot of stuff in here, and probably going to go through it too quickly for you to kind of come out at the end knowing all of these techniques. This may be common to several of the workshops, like the visualization. So what we're doing is showing you things here. They'll be available as like a reference in the notebook later on. So at least to be able to have seen how you do grouping, how you do filtering, how you do some statistics functions in pandas, then you can go back and kind of practice them yourself. Because it's a steep learning curve, but pandas is a really important library. It's kind of like what Excel is to accountants, pandas is to data analysts, data scientists working in Python and Jupyter. So it's kind of fundamental. I mean, most of the stuff we do, like pandas is the lingua franca. So everything outputs a data frame, inputs a data frame. You'll see this one very commonly. So it's a bit intimidating at first, but as you dabble a bit more, you become more and more kind of comfortable with some of the techniques, and even though it looks kind of very different from if you're used to like a query language like SQL, it looks very different to that, or somewhat different. You'll start to see conceptually how it's somewhat similar even to Excel. I mean, I like to think of pandas as like a programmable version of a spreadsheet. Anyway, I'll be quiet now and let Jose kick off.
No, that's actually true. I think it's a really good first step, right? When you are entering this data analysis world. And there, of course, there are some limitations, right? And I think there are a couple of presentations that we have, I'm not sure if it is today or tomorrow, where they address this issue, right? These limitations of pandas, and how can you tackle these limitations? How can you start like analyzing big data, right?
Yep.
Awesome. So let's start with of course, the first step, right? All this workshop will be about pandas. So a very good step will be to, okay. So a very good first step will be to import the library, right? And if you haven't installed pandas yet, what you can do is use a magic command, like the percentage, and you can use pip to install pandas, right? We will share more details about what are magic commands and how can you use them tomorrow in one section of the workshop. Since I already installed pandas, I can use the import method to get pandas ready. And I'm just storing pandas as a local variable using PD. I think that's what most people do. So instead of writing pandas, you can just write PD and it should be good. Okay, now before we mentioned that the main type of object that we will be working with during these 2 days of workshops is going to be a data frame, right? Specifically a pandas data frame. So let's try to understand this structure, and then in order to do that, we should start understanding what a pandas series is, okay? Because a data frame works on top of this concept. A pandas series is basically just a one-dimensional array-like object, right? It's like, just imagine one column, right? Where you have a variable and then you have all the elements for that describe that variable, okay? And you can create a pandas series from different type of Python objects, such as a list or dictionaries, right? So if you're creating a pandas series from a list, I think that what you can do is just define a list, right? And then what we can do is use the series method, like pd.series, and then one of the parameters should be the data, the object, in this case, the list that we are creating. As you can see, we're creating a list with 3 basic elements, item 1, item 2, item 3. And then we are setting the index by default. If you don't add the index parameter, right, it will assign an index to this object. But if you want to modify that parameter, you can do that and specify a different index. In this case, we have another example here. If you delete the here, how can I interact with this? Okay, so if you delete this and if you run this line of code, the index, instead of using 1, 2, and 3, it will use A, B, and C as index, right? You can also create a Panda series from a dictionary, right? In this case, a dictionary is a Python object with a structure that considers keys and values. So if you use a dictionary when you are creating a Panda series, it will take the keys of your dictionary and use them as the index for your series, right? You can see here I have keys A, B, and C, and Pandas is using those keys as index here on the left, right? And then you have the values. Now, you can also add or update the metadata of a Panda series. For example, you can add a name, right, to identify this object. And what you can do is there is a parameter called name, right, where you can specify the name of your series. In this case, we are using dictionary series as the name, right? So if you want to access this metadata of your series, you can use the .name method, and you will be able to access that name for your series, right? This is really good when you probably are working with other type of objects, or you are and you want to make reference to this specific series. You can use the name of the series instead of typing like the whole PD series and, you know, like the whole list or dictionary that you might be using to create this object. If you want to learn more about Panda series, like different methods or different ways that you can create a Panda series, you can go to this link that we are sharing here in the next cell. Okay. Now, so that's the basics of a Panda series. Again, a one-dimensional array-like object, right? When you can describe probably only one variable, right? But what if we put, let's say, or if we want to analyze more variables, right, at the same time? That's when the concept of a data frame comes into place, right? A Pandas data frame is going to be a two-dimensional data structure. That means that we will have rows similar to a series, but now we also have columns. We can add more variables, right? More information when we are analyzing data. So, yeah, as I mentioned, it is now you have a data frame. You can think of a data frame as a table, right? Again, you have rows and you have columns, and each row or each column can be represented as a Panda series, right? How can you create, similar to a Panda series, a Pandas data frame can be created using different type of objects as a reference. Again, it could be a list, it could be a dictionary, but we have more options here. It could be tuples, it could be arrays. Yes, so here is, as I mentioned before, we have is a two-dimensional object. So we have, so now we not only have index for the rows, now we have indexes for the columns. So that's how you can identify each type of element. And that's what Ian will be sharing with us later on how can you start accessing a specific column of a data frame or a specific row, depending on the type of analysis you want to perform. So if you, for example, are creating a data frame, right? Well, the method that you need to use is the data frame method here, right? And again, we are, for example, in this case, we're creating a data frame from a dictionary. So we are storing our dictionary in this variable data, and we are using that variable as one of the parameters. And then we are setting the index here, right? Again, if you don't add any type of index for the rows, Pandas will automatically consider just a sequence of numbers starting at 0. But if you add this parameter, you can change those values for your index. You can also create your, as I mentioned it before, it's like each column or each row can be represented as a series. So if you have multiple series, you can put them together and also create a data frame, as you can see in this example here. We are using two series, data and data 2, which are based on dictionaries, right? And we can still create our data frame with that. And then what else? What else can we do here? Oh, yeah, that one. As I mentioned it before, you can use the index parameter, right, to define or change the default index that Pandas uses when it creates a data frame. But you can also use one of the columns as your as the index for your Pandas data frame, right? That's when you can use the set underscore index method, right? So in this case, for example, I'm using the column A, right? As you can see in the previous data frame, A is one of the columns of my of this object. Now I want to use this column as the index for my data frame. So you can do that. This type of technique is usually helpful when you are working with time data, right? For example, you want to create like a time series, you want to start up a time series analysis. You can use, usually when you're collecting data or security data, you will always have a column that is specifying, for example, the time when an event was created or something related to time, right? The creation of the event or time related to the specific action that the event log is representing. So you can use that column, that time column as your index, and then you can continue performing your time series analysis, right? If you want to do the opposite, okay, let's say you have an object where a column is describing the index of your data frame, you can reset the index and move that index again as a column of your data frame. So there are two ways to do this, okay? Now, if you want to learn more about Pandas data frames, what are all the methods or functions available for this type of object using Pandas, you can go to this link, right? The official website for Pandas. And so far, we will just sharing about, okay, how can we start creating a Pandas data frame based on a dictionary, based on a list, based on series, right? But of course, when we are working, when we start talking about security data, right, we are not creating our data manually, right? So somehow we are storing this information in different type of formats, such as JSON or CSV files or SQL databases or Pickle. So what we are going to do now is we learn how to create a data frame from scratch using built-in Python objects. But now let's say you are collecting data and you're storing that data in a specific file format. So I will show you, Pandas has different read methods, like for example, read JSON, read CSV, read Pickle, that allows you to read that specific file format and create the output of this method is a Pandas data frame. So you can just read the data and start performing your data analysis techniques with this new object, this data frame, right? So let's start with the first example that we would like to share with you is JSON files, right? That's actually what I mentioned in the previous workshop about how can we start acquiring data from the security data sets projects. That project, for example, used JSON, right, as file format. So I will just share a couple of more details about this. How can you start reading JSON files? Even though we already imported the JSON, the Pandas library, to read JSON files, I would suggest to import this specific module, the JSON module, that is part of the Pandas IO or Pandas input-output module, which will help you to read this type of format. And then what we're going to do is basically, if you want to just use this method, the read JSON method, a basic parameter that you need is just the path, right, to the JSON file that you want to read. And I'm using this as an example, the techniques to events mapping JSON. And once you execute this line of code, right, the output of this method, I'm storing the output on the JSON df variable or object. If we use the type function, you will see that this is actually a Pandas data frame. So you didn't need to create the data frame from scratch from raw data. Now Pandas is reading the file for you and created the data frame for you. So you already have your table where each column represents a variable and each row represents a record for this data. And I'm just using the head method to read the information, right? You can see we are just visualizing here the first row of data. So we have this data is part of the OSEM project, which is another project of OTR where we start mapping techniques to security data, security event logs. So this is just one example. Now, something important that I already mentioned in the previous workshop, so I will go just to share some more details about this. I talk about the lines parameter, right? This file, this technique to events mapping JSON file, each record is stored in multiple lines of my JSON file. So I didn't need to add any other parameter, just the path to the file. But what if the JSON file is stored in only like all the records for all the information for one record of your JSON file is stored in only one line. So you need to tell Pandas that it needs to read the file line by line, like each series, right? Each line of your table or your data frame is stored in only one line of the file. So that's when you need to add the lines parameter, right? That's what we use in our previous workshop, okay? And that's it. That's how you will be able to read JSON files that contains records per line, okay? Now, something important as most of the data that we collect in security operations is the timestamp, right? Or time data will be always there, or well, in most of the file. I would say that's always data that is provided with most of the event logs that we collect, right? So there is a parameter that helps you to parse that type of data. For example, using this JSON data frame that we just collected, right? If I go to the column where I have the timestamp for the creation of the event, if I check the type of variable or value that I have, it's just a string, right? Because it has like characters and numbers and everything. So Pandas by default understand this as a string. But you know that column contains time information, time data, right? So if you are using the read JSON method, right, from Pandas to access this information, you can tell Pandas, please consider or convert this column, or consider this column not as a string, as time data, right? So what you are going to do is you can add another parameter, and this time the parameter is called convert dates, right? So what I'm telling here to Pandas is please consider the column that is called timestamp as time data. So now if I check the type of data again, right, of the values for that column, you can see now instead of a string, Pandas understand these values or understand the format of this value as timestamp, okay? So that's awesome. I think that this is really helpful again when you're trying to perform different time series analysis with your data. It's important. It's going to be easier to define the format of your column values as time data. Okay. Okay. So that was for JSON file. Now we can do the same type of analysis for CSV files, right? And in this case, the method is going to be read CSV. Okay, and again, the basic parameter that you need to, or that you need to use is going to be the path to the CSV file. Okay, that's what I'm doing here, just using the path to the file, and I'm using the head method to visualize the first line of this data. Okay, as you can see, the output of the read CSV method is also a Pandas data frame, and similar to the read JSON method, right? Read CSV also has a parameter that helps you to parse the time data, right? So in this case, that parameter is going to be parse dates, okay? As you can see, let's say if we check the type of value that we have in that column, time generated, you will see that without considering any other parameter, the pandas understand that this column contains strings. But if you add the parse dates parameter, right, now pandas will understand that it has timestamp values in that column, which is again really helpful. Some additional notes on CSV files. There are other parameters that can help you to manipulate the data you are or you want to analyze. Like, for example, if your CSV file already has an index and you want to use that index instead of the default index used by pandas, you can set that parameter with 0. Or by default, when pandas reads a CSV file, it will consider the first line as the headers, right, for or the name of the column for your data frame. But if you want to change that, right, if you want to define another row to be the header or the names for the column of your data frame, you can define that using the header parameter. And in case sometimes when pandas is reading all the file, it will have some type of errors, right, or failures. So if you want to define what is the behavior of pandas when finding these errors, you can use the on bad lines parameter, right? What to do, just a warning to stop the process, etc. And finally, pickle files, which is a type of file that helps you to serialize other type of objects. Serialization is basically a process where you take one file and you convert it in a different format, right? And then you can recover the original format of your file. So it's basically just, let's say, to transfer your data when you're trying to parse that information. Similar to read JSON and read CSV, we have read pickle, right? Same idea for the analysis. And finally, I would like to share something about importing remote files. If you have a URL, right, that points you to the content of a file, in this case, I'm using the attack events mapping CSV file that is within the GitHub repo, right? I'm using the raw data link for this specific CSV file. You can also use that as a path when using the read CSV method, okay? So remember when I was accessing the raw data from security datasets, I was using request, I was using BIOs, zip file object to extract the data, and JSON file to read the information. I needed to use that because the file was stored in a compressed zip file. But if you have the link directly to the file, you can use that URL also as a path in your pandas methods. As you can see here, I'm using that URL and getting a data frame with the information. Okay. If you want to read more about the input and output methods within pandas, you can go to this link. I don't know how I'm going with the time. I'm okay. Okay, so now
yeah, we're running behind a bit. So yeah.
Oh, sorry. Okay, so now I'll pass to Ian so he can explain the other part of the workshop.
Okay, thanks, Jose. So just to review the agenda, we've kind of covered data frame. We're on interacting with data frames. Let me move to that section. So, I mean, Jose covered like creating data frames from scratch. I think I've been using pandas for a long time before I created a data frame from scratch. And normally you inherit data frames from, you know, a query or you know, a file that's kind of like ready built. So most of the time we just like, how do we get the data out of there is the big question. Like, tell me stuff about this data frame. How am I going to work with it? So we're going to import a couple of pickled files that Jose mentioned just to work with in this section. One of the basics of interaction with the data frame is like, how big is it? So the shape is your helper here, and it gives you like number of rows by number of columns. Often we just want to know how long, how many rows the thing is. So The built-in pandas len function will also tell you that. So as I think we saw from kind of building up a data frame, like a single row of a data frame is a pandas series. And there's this iloc. It's not really a function, it's a kind of a specific kind of indexer. So that lets you get to a specific numbered row in a data frame. And we can verify kind of what it is by running this. So we're just going to get the first physical row in the data frame. And we can see it's a type series, and this is the content we find in it, at least an abbreviated section. So going in reverse from what Jose showed you, like the intersection of a row and column is a simple type. So here we're using the iloc again to get the very first row, and we're selecting a specific column from that. And there are, this is what it is, this is the type, and we can see the value at that point. So if you need to get a specific value from a specific point, that's a good way of doing it. Now, selecting columns, often you just want to look at a subset or maybe just a single column. You can do this from your data frame. Just dot column gives you the values inside it. Now, more general syntax is this. So you use the kind of indexer, and this is saying to pandas, give me the series with this name. And certainly you need to use this format rather than this format if you have any Python illegal characters, things like dot and hyphen are not legal as pandas, as Python identifiers. So if you have anything like that, then or columns beginning with a number, use this kind of format, but this is otherwise identical. So to get multiple columns at a time, you need to, rather than specify a single column here, you specify a list of things. And here we just created a list of 2 items, and we get, rather than a pandas series, we get a data frame, but it's now just a data frame of just the 2 columns we specified. Now you can do these in line, you don't have to create a list beforehand. So this is using kind of a literal, but notice that you need this, which often catches me out, you need this kind of double thing. So you need a square brackets for, to say that to pandas, this is an indexer, and then you need the square brackets to say this is the list. And to find out what columns are in there, the columns property for any data frame will tell you which things. If this is a very large number, you'll have it will maybe not print out them all, it will print out the beginning ones and the end ones and a dot, dot, dot in between. So as I did explain indexes, now an index is the kind of the label for both the rows and the columns, and this is used a little bit kind of ambiguously. So an index for a data frame typically is the row number. Technically, the column labels are also an index, but when you use the index, so this tells you, we have a data frame with these different numbers that identify the rows. And I already introduced iloc, so that's like the get me the row at this physical location. But there's also a pandas lock, which is get me the index value at this location. So you can see here we have different values. These are not like numbered, well, they're numbered sequentially, but they're not like 1 or like 0 to 20. So to get the row at the index value, we do that. But to get it at the physical row, this looks like a similar record, but you can see from the timestamps are different. This is a different record. So this is the physical row versus the index label. And it's a bit kind of confusing because I've got like an integer index here, but if you set the index to be something else, which we'll see in a moment, then this makes a bit more sense. like what the difference between lock and ilock. So here we can use set index, as I spoke about before. And here you can see with the default index, with this kind of numeric index that Pandas creates by default, but we've set here to the account column being the index. And here we can see account is like bolded, and now rather than a number on that side, we've got the account, the name of the account. So one thing about that, you can set as you can see in this case, this index doesn't have to be unique. So you should bear that in mind. And I kind of like, apart from like timestamps, I rarely set things other than the default index to be the index. Because usually you want to be able to get to a very specific record. So this is an example. So we've got our indexed data frame that's now indexed by account. When we display using lock and we actually identify the account, we don't just get a single record, but we get a whole bunch of them. And that may be helpful, may not be, but it's good to understand. And you can see, even though we've re-indexed this thing, our physical records haven't changed. So if we use ilock to get to a physical row position, that's exactly the same record independently of what we've set the index. So it hasn't physically reordered the stuff inside. So accessing individual cell values, I told you before about the intersection of a row and a column, and this was like confusing to me at the beginning, partly because there are many ways of doing it, and you'll find this in Pandas over and over. There are many ways of like doing often a single operation. So you can specify it using the physical row number plus a column name. You can use the @ indexer, which is like the index expression. So this is like the index value. So if it was a count, it would be the name of the account. If it was a number, it would be the number of the index. And IAT, which is a purely numeric index. And we can see the value of the result is the same. Same thing for each item. IAT, it's a bit kind of weird. That's a very kind of NumPy, like you're using a numeric. You need to remember it's the 5th row and the 8th column. Certainly not something I kind of use. So so that's getting a value from a particular cell. Getting a value from a series is a little bit different. The values is probably again, there's multiple ways of doing this, but the values attribute of a series returns you an array, which looks a lot like a Python list. It's not exactly the same thing. You can convert it to a list by surrounding the whole thing with a list. So it's often, if you want to get all of the account names or all of the timestamps or all of the logon sessions, whatever, and you want to then be able to use that in Python code. This is probably the way to do it. So we did cover some IO functions already. I would say that CSV is kind of a comma separated variable. It's kind of a universal, but it's a bit nasty, really. And it's very inefficient to both read and write. Pickle is good, but Pickle, which is like a native Python way of like compressing and storing arbitrary data. This is good, but you do need to be aware that the version changes occasionally with Python versions. So if you have a very new Python version and you save it by default as a pickle, you may not be able to read it in all the versions. So some other good options that are universal, more kind of universal, like Parquet, HDF, and Feather. I'm not going to talk through all of the input-output functions, but to give you an example, like this is just me iterating through pandas and looking for all things that have reads. These are all of the input functions. You can see there's some we've looked at already, like read JSON, read CSV, but there's also things like read Excel. And similarly with the output functions, there's a whole bunch of things that we don't have time to cover, but you're very free to browse the very detailed pandas documentation if you have a particular requirement. So one thing I wanted to show you is one of these things. So export into Excel. Now, you don't really need Excel anymore when you have pandas, but it still might be a useful kind of thing. So this first line just takes the data frame we've been looking at and exports it as an Excel file. And to do that, you probably need OpenPyXL installed. And if you don't have that, you'll get an import error. Pandas doesn't really warn you other than just throwing an error. And then I'm going to start, if it works, I'm going to export it and then start up Excel. Oh, and there it is. Okay, demo 1 worked. Okay, let's close that down again. We already talked about reading JSON, and this is what Jose meant by a kind of a record format. So things in an individual kind of line inside a list. You could just read that kind of that format in very easily and create a data frame. One thing I wanted to mention was like JSON normalize, which is a very useful function where you have a structure like this, where you've got individual records that then have sub-records inside them, so nested records. And this is very common when you read stuff from APIs, you make this arbitrarily deeply nested data structure returned. To use that, you need JSON normalize. Now, the odd thing about JSON normalize is it doesn't take JSON as an input, it takes a dictionary. So if you try to read, we're going to try to read here and try and catch the exception. It doesn't like that. But if you load the text and you use JSON, the built-in Python JSON to load at that, and that essentially converts it to a dictionary, then you can send that to Python JSON normalize. And we get this structure where top-level items are captured as is, and sub-items, it creates a column with a dot as the parent plus the subfield, and it will do that kind of arbitrarily deeply. One nice thing, one nice I/O function Pandas has is the ability to read web pages directly, and if there are, so it will read tables from a web page, and it will return these as a list of the raw format's not kind of terribly useful. So you can see this is a data frame inside a list, but if we select the first item from the list, we'll get our MITRE tactics inside a data frame. And this is, useful for lots of things where you try to like scrape data from the web. Okay, and the last section before we break is selecting searching. So we've looked at like physical, being able to get things by physical row and account. Sorry, physical row and column. You can also use the same thing to get ranges. So I'm getting like a subset here from row 3 up to, but not including row 6. And as I said before, you can also go kind of full NumPy and do IAT or ILOC with both a row and a column designator. That's helpful up to a point, but really we want to normally be searching by and filtering by content of the item rather than a physical index. So introducing Boolean indexing, which is a kind of a fancy name for filtering. So there's a few basic operators available to you. There's the equals, identity, not equal, greater than, less than, like all the usual kind of suspects. And this is the basic format of a Boolean indexing expression. So we're saying that the account column for our data frame is equal to this value. And what do we get? So we get this odd thing. We get a pandas series where we have the index intact, and some of these items are false, some of them are true. And the true items are where this expression is evaluates to true, and the false ones are where it evaluates to false. So that's kind of interesting, but you may be thinking that's not very useful. However, we can take that expression and put it inside of Panda's data frame indexer, our Boolean expression. And this is kind of equivalent to dataframe.lock. So the second example there, they're interchangeable. So if we take our expression that we created before, then we actually get our filtered results of our data frame according to this Boolean expression. So Pandas is saying everywhere that this evaluates to true, I'm going to show the record. Everywhere it's not true, I'm going to skip the record. So we have some basic operators like equals, not equals. Often you want to do something a bit more sophisticated. If we look at the types of the different columns, particularly with strings, we often want to do something like find a partial string. We can't really do that with equals or greater than. I guess potentially we could do it a greater than, but it's a bit more complicated. So we know that Pandas supports a bunch of string functions. Or maybe you didn't know that, but you do now. So things like ends with, contains, matches, like a regex match. We could try that, but we get an attribute error. So this is really what we want. We want, like, you know, I don't want to be able to have to specify the full name. I only remember part of it, but I know it ends in mystic admin. We can't do that, and it's saying that this is not Pandas series has no attribute ends with. If we look at what this thing, as we know, this is a series, it's not a string, so we can't just, it doesn't have an ends with function. So we need to tell Pandas to apply this particular string operation that we want as a sort of vector function. So to tell Pandas that rather than try to apply this thing to the series, apply it individually to each of the rows. And there is functions called accessors. So string accessors, there are datetime accessors that allow you to do specific operations on these types. So if we try the same thing again, but introducing this stirrer, we now have access to these specific functions. At least we didn't get an error. So we've got our same kind of index, you know, our same Pandas series as a Boolean index. So now we can plug that into our query, and we get what we wanted. So things that end with our substring. We can use multiple conditions. I'll come back to accessors in a little bit. We'll carry on using this for the moment. So you can use multiple conditions, and you can use these binary kind of logical operators to combine multiple conditions. A warning about this, though, is that you need to use parentheses, and I'll explain. It's parentheses around each individual expression, and I'll explain that in a second. So logons df, we've got, this is exactly the same thing we had before. We're just looking for this where the substring ends in mystic admin. But we want to add a couple of time expressions. We want to build a more sophisticated filter. So we've got our two date timestamps that allow us to do that. We want to introduce. So we take our original expression, we surround it in parentheses, and in this case we want these logically ANDed. So we're using AND on our first time generated greater than T1 and time generated less than or equal to T2. We should get some results. Yes, I know we're getting very similar results each time, but just for the purposes of illustration. So the problem is if you miss out the parentheses, that these operators, I'm not even sure what that's called. Yeah, ampersand, pipe, not. They have a higher precedence than these operators. So when you try to run something like this, and you'll probably do this, I did this all the time, and then I go, oh no, I forgot to do the parentheses. What it's trying to do is take this and do a bitwise AND with, so it's trying to evaluate this part of the expression first. And it's saying, oh, I cannot do that. And then it's trying to evaluate this expression, or it's trying to do a bitwise and between a series and a timestamp. So if we put our parentheses in, and this is a slightly different query using a different operator, then it should all work again. That's great. So because our Boolean indexes are pandas series, it means that you can save and reuse these. They're not just, you don't have to like write them in line each time, particularly if you're reusing an expression like a time, time boundary or something like that. You want to use in multiple kinds of queries. So here we're doing that. We've got 3 different logical expressions, roughly based on the stuff we did earlier. We can save those to pandas series, and then we can use them in an expression. And no, we don't need to use the parentheses this time because we've already evaluated those logical expressions, and we can use them like that. A quick mention for the is-in operator. This is kind of nice. You can check for the value of something that's within a list or a, I think that's my timer telling me I've kind of over time. So just to finish this query, yeah, in a list or any other kind of Python iterable. And we're kind of more or less at the end of this section. Just wanted to talk about the pandas query function. For any of you that like SQL or other kind of query background, you may be thinking this is a really clunky way to query anything. And it kind of is, although you do get used to it and you start to see the kind of benefits of some of the complexity later on. There is this alternative query function, and this allows you to express a query of a data frame in a much more kind of human readable format. There are limitations in the type of operators you can use. One of the advantages, or one of the things you can do as well to make it a little bit more flexible is you can include Python variables inside the expression by prefixing them with an @ sign or an aruba. Now the results of a query expression are just themselves a data frame. So you can easily combine this with other kinds of things. So here we've got a Boolean index expression and this odd kind of format. I'll talk about that a little bit more at some other point, but yeah, as long as you surround stuff with parentheses, it allows you to split what could be very long pandas expressions over multiple lines. Sometimes it makes it easier to see kind of what's going on. So we've got our Boolean indexing and our query expression, and they just glom together as you'd expect. So you get the results of the kind of the logical end of both of them. And you can also combine these with any other kinds of pandas expressions. So here we're filtering on the rows in the first expression, and then we're just producing a subset of the columns to get like a truncated view of our filtered by both column and row. And at that point, I think we're going to take a short break, and then we'll come back to talk about sorting the moving duplicates and a bunch of other things. So I think we have a 5-minute break. I'm just going to check in the time. Oh, I think we've already run past our 5-minute break, haven't we?
Well, it's all good. I guess we can stretch for like a minute.
Okay, well, let's make it a 30-second break while I kind of stretch.
Yeah. That's good. That's good. That's only a little bit of time extra, but yeah, that's good.
Yeah, we don't have a lot of time to play with on the agenda, so it's very tight, and we have a hard stop because we have John Lambert at 11:40, so we have to try and rattle through this.
Yep. So what are the next topics for basics of data analysis with pandas, just to kind of prepare, I guess?
Yeah, sure. Let me reshare my screen.
Yep. Have an idea of the next step. Yeah, there you go. Sorting our movie. Nice. Yep.
Yeah, we can go back to our So we've just got to the end of part 2, selection and filtering. In part 1. In part 2, we're going to be doing sorting and removing duplicates, grouping, adding and removing columns, and simple joins. We've got more keyed joins, like more like SQL-like joins, is going to be covered in the session tomorrow. But just kind of merging 2 data frames together, we're covering, and then statistics 101. So I'll try to get through the first chunk of this. I know the Jose's section on statistics is kind of quite detailed, so I'll try and get through the first part as quickly as possible, especially given we are already behind time.
Yeah, just a little bit.
Okay. Yeah, but all these little bits add up.
Okay, do we start then with Jose, right?
No, with me.
Oh, that's you? Yeah.
Unless there's some kind of coup d'etat happened.
No, it's okay.
Yeah.
All good, brother.
I will just check in the Discord channel in case we have any questions.
Yep.
There are some questions. How do you ignore?
Oh yeah, somebody answered that already. Yeah.
Oh yeah, about the str contains and the str match. So we should be good there.
Awesome.
Okay.
All right.
Okay, well, let's try and kick back off with sorting and removing duplicates. These are kind of not quite the same thing, but sort values after Boolean indexing, sorting is a relatively simple thing. So it's just a sort values thing, and you need to specify a column or one or more columns, and it will, if you specify a list of columns, it will sort in order of, yeah, it will take the first column, obviously, and then the second column, and it will keep sorting within those things. And you can specify ascending or descending. Ascending equals false, sorry, or ascending equals true to specify the sort order. It's very simple. Drop duplicates is somewhat related. So I can't remember how many rows we had. I think like maybe 20 rows in this thing. But we can, here we're just taking a subset, just the account and the logon type, dropping the duplicates and combining it with the sort. So we're, and rather than 20 rows here, we've got, what's that, 6 rows. Because many of these things are kind of duplicated. So very light topics, slightly heavier topic is kind of grouping, which a thing, like if you're familiar with SQL, then it's the kind of thing you do by second nature. And the idea is like grouping by a certain value and then doing some operation on the subgroups of your data. So when I first came across this, it really kind of puzzled me. So I found the group by thing fairly easily in the pandas documentation, and you do group by and you go, oh, group by object. So unlike a data frame, it doesn't show you anything, it shows you this object. So that's not very useful. What do I do with that? And a bit more reading, and it turns out that you need to do something, you need to apply something or use that group as an iterator in order to see any results from it. So an example of an aggregator function, which is one of the things you can do with a group, is count. There are a bunch of others like sum and mean. Oh, sorry, my Alexa is talking to me. We can just do a count, and this does, the reason the yuck is in there is like if really what you wanted to do is get a count of the individual rows by a count, you probably don't want to end up with something like this. So it's just counted the values in each of the columns. You can tidy that up a little bit by, first of all, just sending the columns you're interested in. So we obviously need the columns that we're going to group by. We need something to count. In this case, I've chosen time generated, but it's arbitrary. We could have chosen any of the other columns. We're doing our group by, doing the count, our aggregator, and just for cosmetic reasons, we're going to rename time generating to actually the thing that is a bit more meaningful. So it's returned us a data frame, and it's actually set the index to be the account, and it's given us a logon count. So you can use a Python for loop. I said that you can process these as iterables. So Python iterable, a list is an example of an iterable, like a sequence of values that you say next and it returns the next one. So use them in a for loop. And when you use it as an iterable, you get these two values returned. You get the name of the group, which in this case is the value of the account, and a data frame, which is the subset of our original data frame grouped by that account. So if we run this little bit of code, you can see we've got, for each of our accounts, we've got the data frame, and here we're just printing out the size, like the number of rows for each of them. So if you wanted to use the thing programmatically in more Python code, this might be a useful thing. We can also use this similar thing, and if you're familiar with like dictionary comprehensions. So this is a way of doing a for loop in a single line. So you can recognize that bit of code looks very similar to this, but instead of iterating in code, we're assigning it to a key value pair, and then we're creating a dictionary from it. And this is showing you the keys, and it's showing you what we're getting one value here. So we've saved each of the data frames keyed by the account name. Okay, so often you'd want to group by multiple aggregation functions, maybe something more useful than just a count. And the basic syntax for that is to supply a dictionary to the ag function, ag obviously for aggregator. And the syntax there is a dictionary where the key is the column name and the value is the aggregation function that you want to apply. It can be a string, or it can be a NumPy. It can be an actual method, like a NumPy method, for example, or a built-in pandas method. But most of the usual things are available. So here we have the same thing we had before, group by account, three columns, and we're going to apply max to get the latest time generated, and we're going to count the number of unique logon types, which gives us that. You can group by multiple columns. In this case, we're doing account and logon type. We're still going to get the time generated, the max of the time generated, and we're going to arbitrarily just count the event IDs. It's just a kind of illustrative example, perhaps not a very practical one. So here you notice you get a sort of interesting, slightly different output. We haven't just got account as our index for our output data frame. We've got also logon type as a secondary, and this is an example of a pandas multi-index. So you can set index to a specific column, but you can also, here we get the grouper effect as set account as the primary index and logon type as a sub-index. So within each account, you've got different logon types as the secondary index. I don't think we've got examples of working with secondary indexes, but you can also, if you don't want that secondary index, you can also, if you just want it as a standard data frame, you can reset index and you get a thing without any of that indexing. Makes it sometimes easier to work with. So sometimes we want to group by things that are not whole values of a column, by some operation on the column, and PD grouper is your friend here. It sounds like some kind of private detective or something, PD grouper, but it's actually a pandas function, and it allows you to do various things. I'm only going to show one thing here, which is kind of useful. It's to be able to group by taking the column time generated and group on frequency of 1 day, but that could be like 1 hour, 5 hours, but otherwise the thing is the same as the previous example. And And you can see rather than it's grouped on 1 hour, 1 day intervals. Anyway, there you go, you get the idea. Quickly on adding and removing columns. So the general format for adding and removing columns, you just assign an expression to a column name in the data frame. Now, if the column name already exists, it will overwrite the contents. If it doesn't exist, pandas will create a new column. And there are different ways you can do this. You can assign a static value to a new column or existing column. You can do some operation, and there is an example of a string operation using an accessor on an existing column. So we're assigning, here we're splitting the account name into domain and account, and we're only taking the domain part of it. Here's an example with a date time accessor. Just getting the day name, and you can do things like mathematical operations or is like date time arithmetic. So if we run all of those things, we'll show you both the old input stuff. This is what we had in the input, and our new things. Our static value is just like a simple string. We've got the split up split out the domain from the account field, and so on. Big event ID is just like multiplied by 1,000,000 or whatever it is. Now, a more formal way of doing this is using the assign function. And this doesn't write stuff back into the data frame. What it does is assign new values on the output. So in this expression, we're using assign, and we're using a very similar kind of syntax. So assign takes a series of parameters that kind of look like this. First is the name of the column, what we want to generate, and then whatever the expression is. And this could be a string, it could be a mathematical calculation. In this case, we're generating 2 new columns. This is like 1 week, or same time last week. We're subtracting a time delta of 1 week, and we're building a kind of little phrase by concatenating strings. Now, so this hasn't changed our underlying data frame, but it has added these new columns to the output stream. So, if we wanted to save that, we could like do, df is equal to this, and it would save that as a new data frame. Unlike the operations earlier where we had we actually changed the data frame. So you can see the things we generated here, as you would expect. So adding columns, we might also want to drop columns, and drop columns again there are two versions of this. There's drop columns, there's the version that I like, and there's the evil version. There are a whole bunch of pandas operations that have this in place equals true option. And I generally don't like this. It's sometimes like useful as a shortcut, but that modifies your data frame in place. I prefer, if you want to do that, to not do that, not use the in place equals true, but like new df. If I wanted to change it, I would just assign this again to like new df. Or ideally to something else in a different data frame. Because once you change the stuff with the in place equals true, then you might have to go back many, many steps to like reread your data. And so I try not to use the in place equals true. However, you can do it. And this is a very similar kind of effect to the direct assignment of columns we saw in the previous section. So not doing this, we're just going to drop the NT domain from our NT domain column. And this could be like multiple columns that we drop here. Some other interesting ways of filtering out columns that I use, and there's a quick recap on which columns we have. This is really nice. Filter allows you to like specify, there's a few different options here, but one of them is like regex. So you can specify a regular expression for like which columns you want to view. And these, sometimes when you get very, very large data frames, this is useful just to see a quick subset as long as your regular expression skills are up to it. So here it's just returning all of the columns that begin with the substring target. Another different but kind of complementary thing is to select D types. This allows you to select a subset of the columns based on the type. This one is date time, but you can also do it number and object. Object, you might have seen a few times. Object is usually a string, not always, but certainly strings are stored as pandas objects. So whenever you see object in pandas, that is usually a string, or it could be some other complex Python object. Right, just what I think in this, before I hand over to Jose on simple joins, and we talk more about relational joins tomorrow. So to prepare for this, I'm going to take my logons data frame and split it into two little bits, one that's like 10 rows long and one that's 20 rows long. And then I'm going to join them back together. So here are two candidate data frames. So to join them back together, use PD concat, and you supply a list of the data frames you want to rejoin. And this gives us an output that now has 30 frames from our input of like 10 and 20 frames. And the default is just to append them as rows, append them as new rows. So they all have the same columns. And if we look at the index, this is the index from the first part of our first data frame. This is the index from the second part. And sometimes you don't want that. Sometimes you want, particularly if you're generating data frames in code, you might want to ignore the source index entirely. So you can do the same operation with the ignore index equals true. And this will renumber the thing, so it'll ignore where it came from. And if we look at the index this time, I mean, pandas it's not even printing out the individual values. It's just saying, well, this is a range that starts at 30 and it stops at 29 actually. But so we can also join columns, join data frames horizontally. So appending column, like appending additional columns in the horizontal direction. And here I'm going to take, again, a similar thing like a subset of the rows and subset of the rows, and also use the filter expression that we saw a little bit earlier to get subject and target subsets. So this is what our two input data frames look like. Notice here that they have what looks like a common index. And this is important because when you use PD concat, pandas tries to align the index. So in the example earlier, even though I didn't say it, when it's appending rows, it's aligning the columns. And actually, we'll see in this example kind of what I mean. So if we concatenate using the axis equals columns, so this is telling pandas to not join rows, but to join horizontally. We get this as our output. One thing you can see down the bottom is we've got a bunch of nans. What's happened there? Well, if we scroll back to where I created the input data frames, you can see one is slightly longer than the other. So when pandas try to join them both together, it tries to align these numbers. So 0 here and 0 here will be matched up and joined together. Because we have two more rows in one data frame than the other, it hasn't been able to align the index 10, index 11. So it's essentially done a write how to join. So it's just put like nulls in those values. And the same thing would be true if we joined like row-wise. If there were columns missing from one data frame that were in another, it would create nans for the missing column values. Okay, so
yep.
Basics of pandas done, and over to Jose for statistics.
Thank you, Ian. That was awesome. I really like using join operations with pandas, especially when we are collecting different event logs. Each logs represent an action, right? And then when we are trying to understand the behavior, that's when we start like trying to join or relay the data that we have in different events, right? That's really helpful.
Yeah, sure. I was just checking whether we're still a little bit behind time, but I think we're.
Yeah. Okay, so just give me 1 second. Oh, no, this is not the.
Okay.
Where is the?
I'm going to switch myself off so I can relax.
I'm sharing the screen in the stream.
Let's see.
Yeah, right.
1 second. Not yet. No, go ahead, man.
Okay, so we don't have too much time. How much time do you have? 50 minutes?
I think we have 20 minutes.
Okay. That's not counting the break, right? Okay, so just give me 1 second. I don't like how this. Yeah, here we go. Okay, so again, as I said, that was also different operations that you can do with your data, different operations that you can do with your data frames, right? You can start like identifying and filtering the specific information that you want to analyze, right? And there were some basic like statistics there, like Ian was like using count as the, and I think count is probably like most of the default operations, right? When you are grouping data and when you're trying to aggregate some type of metric with the data that you're analyzing. And now in this last part of the workshop, I would like to share just basic concepts that will help you to identify, okay, which type of operations can I do with the data that I have, right? There are different operations, counting, addition, subtraction, other metrics such as standard deviation, for example, but when can I apply, right? When can we apply this type of metrics or calculations? So this workshop will start, or the data that I'm going to use for this workshop is a part of the security, the compound data sets of the security data sets project, right? I'm using the combined SIG logs for one of the simulations we did for the APT29. So this is the code that you can use to collect that data, read that data from a log file. Before we jump into the different type of operations that you can do or different type of metrics that you can calculate, I would say that it is very important to identify or recognize the type of data that you are collecting, right? And I would like to start with numerical data, right? Which is basically data that is probably the result of counting or measuring operations, right? And most of the time, I would say, yeah, most of the time, like these type of values, the numerical data, they are represented using numbers, right? And this is important because the arithmetic, what I mean is operations such as sum, addition, or subtraction, right, will give you more context of the data that you are analyzing. Like, for example, you have a number of packets that were transferred at this moment, this amount of packets that were transferred over your network in this other moment. If you add those, trying to aggregate everything, right, now you have like the addition of these two numbers, of these two amounts of packets, like the addition makes sense, right? Like 15 plus 20, okay, I have 35. I know it sounds probably kind of really, really basic, but it is important to understand that to identify numerical data is the mathematics behind these values make sense and help you to create new information, right? Trying to aggregate the data. And one example of numerical data would be network packets, right? And this is, we have a sensor, we start like counting the packets that are being transferred over our network. This type of data, when you are counting the elements, is known as discrete values. Other type of numerical variable would be, for example, the network connection duration, right? Of when you are accessing other resources from an endpoint. This type of variable is the result when you're measuring, right? Like, for example, it could be 0.005 seconds or milliseconds or whatever the unit is your tool using to collect this data. when the result of, when a variable is the result of a measure, right, of something, that type of numerical data is known as continuous, right? Usually you will see more like decimal format type of data there. And the other important type of data will be categorical data. And this type of data describes categories or qualities of the object that you are trying to describe, right? For example, let's say if we're talking about a process, we have, let's say, the GUID or the integrity level, etc. And these type of data is usually described using characters or strings of characters, but you can also use numbers to describe a categorical data. For example, let's say one example of this could be the type of logon, right? When a user accesses or logons into a system or computer or device, the type of logon, you can represent those type of logon with numbers like 1, 2, 3. Like for example, 3 represents, let's say, logons over the network or remote logons. But how can you differentiate between this categorical data that is using a number with numerical data? When you have categorical data represented using numbers, when you do some type of calculation with these numbers, this calculation doesn't make sense or doesn't give you extra context about the situation that you are analyzing, right? So that's how you can differentiate between categorical and numerical data that are represented using numbers. One example would be the network protocol, right? I'm using some of the methods and techniques that Ian presented before, like for example, trying to filter only these 3 columns of my data frame. And then you can see here the protocol is the type of categorical variable, right? When the categorical value that you're collecting just helps you to identify a category, but it's not giving you any other, let's say, context, right? Just to, like, let's say we are tagging these categories, right? Just giving names. This type of categorical data is known as nominal data, right? And the other type of categorical data would be the ordinal data, right? This is let's say, similar to nominal data, but the difference is that when you're working with ordinal data, this type of data helps you to organize or order the data. For example, if we're talking about the integrity level of a process, right? You have low, medium, high system, and each level, this integrity level represents the level of access of each process, right? Related to other processes. Okay, so this was the basics of type of data, numerical and categorical, and identify the type of data. As I mentioned it before, it is important to understand the type of operation that you can perform on this data. So for example, let's start with, oh, yeah, sorry, I didn't mention this before, but when you are doing statistical analysis, there are two main type of analysis, which is descriptive and inferential type of analysis. In this workshop, what we are going to share today is just the descriptive type of statistical analysis, right? The inferential will be, hopefully, in the next Jupyterthon, we will cover it. We will cover that type of analysis with more examples. So let's start with the descriptive analysis for categorical data. With pandas, it is when you're working with categorical data, most of the time you will have a strings, right, type of data. So pandas will understand that as a categorical, let's say, data from. But if you want, there is a type of data that pandas uses, which is called category, right? So it will be helpful if you identify categorical data in the columns of your data frame. You can set the type of value as category, and in order to do that, you can use the asType method, right? And you can put a dictionary with the keys, where the keys are the name of the columns that you want to use as a category. So you can see here we were checking the type of values for the protocol and the service of our network connections. We will get an object, which is just like a general description that considers multiple type of objects for that column, but we are setting that as category. So Panda understand that is categorical data. Now, there is one method that Panda has that is called describe, and describe will give you some basic statistical metrics that you can use with categorical data, such as, for example, counting. You can identify how many unique values you have in your columns. You can have, if you're, with the counting, you can also identify the what is the top, right, like the most frequent value, and also it will give you the frequency of that common value. In this case, SSL, which is a service, and we have 378 records there. What else can we do with categorical data? Using some of the methods that Ian already explained, like group by, we can also add another ones such as size and sort values. You can start creating or you can start calculating the frequency of the values. In this case, we are trying to calculate how many records or connections we have based on the service, right, of the connection. We can see here that we have SSL as the most common type of service used in this data. And this is kind of the same result that we got with the describe method, but now we have more context with the other type of services and the count for each one. Now, one value, so now that we have, for categorical data, another type of operation that we can do is central tendency. Central tendency metrics are basically metrics that will help you to identify or try to represent a group of values with only one, okay? So in this case, with categorical data, probably the most basic metric that you can calculate with categorical data is just the mode, which is the frequency, which one is the most frequent value, right, in your data set. As we mentioned before, using other methods, we already knew that the SSL is the most common service used for this data. You can also find the median when you are working with categorical data, but this will work only with ordinal data, because the median considers what is the element. You need to order your data, and the median will be the element that is in the middle. So in order to be able to order your categorical data, you will need to use ordinal data. Correlation, you can correlate categorical values. Yes, if you use the crosstab method from Pandas, you can create a two-way table with two different variables, one that will split the rows and the other one will split the columns, and you can start identifying which elements belongs to both values or categories for each group. Now, for numerical data, most of the time we have the same operation. We can perform the same operations as categorical, but we have some extra ones. With numerical data, we don't have a specific type of variable as category, but we can use integer or float, for example, as numerical data. That's what Pandas understand as numerical data, right? Again, you can change, for example, usually you will see float type of data for continuous data, and you can define integer as the type of data for discrete values, right? That I mentioned it before. Similar to categorical, you can use the describe method, right? And of course, this one will give you more details, right? Because with numerical data, you can perform arithmetic operations, and this will give you the count. This will give you the mean. This will give you the standard deviation, the minimum value, the maximum, and also these percentages here that represent the percentiles. And or in this case, they are giving you quartiles. Quartiles is, think of a quartile as a concept that allows you to split your data in 4 big groups, right? Each group is a quartile, like 25, 25, 25, 25, 4 groups. So 25% will be like the first quartile of your data, 50% will be like the second quartile, and 75 the third one. Very important metrics when you are trying to describe your data, right? Similar to categorical, you can calculate the frequency of values, but when you're working with numerical data, sometimes you need to define some type of bins or intervals, right? So you can start counting. You can start counting the elements that belongs to that interval. You can represent this frequency using a histogram visualization using pandas, right? You have the what is the yeah, you can use the his method to represent that frequency, but instead of having a table, just a visualization. Central tendency with numerical data, we have more, we can easily calculate different metrics such as the mean, the median, and the standard, the mode, the mean and the median, right? Again, these type of variables, they try to represent the whole group of value. And then we have shape, just to finish here. Yeah, we have some metrics for the shape of the distribution, right? Remember this table, if you see this histogram, right? We can see the histogram represents the frequency, and we can see that most of our values are on the left side. So smaller values of duration, right? They are close to 0. We have a lot of values to the left. So you can see that how can we represent the shape, right? How can we know if our values will be more to the left or more to the right, or they are centered, if they are symmetric or not? These values, the shape, this type of metrics, kurtosis and skewness, that will help you to identify without looking at the numbers, right? Just calculating these metrics will help you to have an idea of the shape of the distribution of frequencies without even graphing. For example, if we find kurtosis, your reference will be the number 3, right? Any value greater than 3, it might indicate the presence of outliers in your data, for example. For skewness, you have if the value of the skewness is negative, for example, that will help you to understand that your distribution is left skewed. It's like most of the values would be on the right, right? So you will have potential outliers with shorter values on the left. And if your skewness is positive, for example, you will have this will be right skewness. That will mean like most of your values will be on the left side of your distribution, and you will have potential outliers on the right. This will help you a lot. There is one presentation tomorrow about detecting beaconing using statistical analysis, and you will see a real application of these metrics. But I just wanted to show that Panda you can calculate these metrics with pandas. I think we were good with the time. Yeah. So I'll list these to Ian, so he can introduce John Lambert for the. Well, Ian, are you there?
I am. Yeah, sorry, just unmuting myself. So now we're into the kind of the main session. We're standing kind of like between you, and depending on what time zone you're in, could be lunch, could be afternoon tea, could be evening dinner. But it's yeah, well worth sticking around. I've known John for a while, like quite a few years. In fact, he hired me from the UK into Microsoft US, and was actually, in fact, the first person to introduce me to notebooks. And I thought, wow, this is like black magic. I don't understand what's going on here. And I thought John is completely crazy, because I just can't see how this works at all. But several years later on, here am I. Most of my life is like devoted to notebooks. So John is distinguished engineer in Microsoft. He runs Mystic, the group that I work in, the Microsoft Threat Intelligence Center. It's well worth following him on Twitter if you're interested in hiking, mathematical puzzles, and something else he tweets about, threat intelligence, maybe. Great source of stuff. So without further ado, I'll introduce John for our keynote session.
All right, Ian, can you hear me?
I can.
Give me a thumbs up, and then let me know when you can see the slides here. Give me a thumbs up when you see them.
I can see the slides.
Okay. All right, I'm really glad to be here today. You know, in a lot of ways, for reasons you'll hear later, like the notion that we would be putting on a day, 2 days devoted to Jupyter and InfoSec, that's like a dream. So I'm very thankful to Roberto and Ian and everybody else that's helping out with this and the other speakers. I don't know if Roberto was like, how hard could it be to put on a conference? But I think, for the people in the audience, just know this is a labor of love by the folks putting it on and all the people spending time here today. So again, just my thanks to them and to the other speakers, and then for you all for your commitment to learn about this awesome stuff that is Jupyter. So what I was going to talk about today is I wanted to present some thoughts and concepts on how I think we can speed this journey that we all are undertaking in InfoSec. It's very much an experience-driven field. You gotta work IRs, you gotta dig in data to do it, and we need more people doing it. And we need us, all of us to get better faster. And I want to talk about some things that I think will help that, and then really focus today on the Jupyter piece of that. And I'll tell you kind of what my personal journey has been on it, and sort of hopefully encourage some of you who haven't used it yet to go try. And so, I often feel like in this world of InfoSec that we all hear about attacks at the same time, but we have to then go and defend alone. And if there was any profession that could benefit from some acceleration to, like, how do you get that 10 years of experience in 5 years or 3 years? How do you compress that? InfoSec is one that needs it. And I think there's a lot of stuff that's out there that is really community driven that are going to be those steroids there. So let me kind of talk about some of them and then tell you why I think these particular things stack together very well to help get us there. So there's this proverb that I use and really admire about this, which is, if you want to go fast, go alone, but if you want to go far, go together. And it really speaks to the power of community. And there certainly are times where, you need to just go do something by yourself, and that's the fastest way to get it done. No dependencies, just striking out. But when you harness the collective power of people all over the globe in their organizations, seeing threats from their perspective, them able to contribute their expertise, collectively, and others able to take that energy and build off of it, the power that you get from that as a community is impressive. The one thing attackers take advantage of is the fact that defenders are disorganized and victims, are disorganized. Yet there are places where we do work together very well, and there's a lot of strength that comes from that. And I think there's a lot more that we can do. So today I'll really talk about these different topics of, how we as defenders help organize knowledge and how that's important. And then knowledge is one thing, but it doesn't do anything by itself, and how we make that executable. And then really focus basically the second half of my talk on this area of analysis and how Jupyter plays a very critical role there. So let me go ahead and dive in. So knowledge, in a way, this whole InfoSec space starts with knowledge. I'm going to talk about MITRE ATT&CK. Everybody knows about MITRE ATT&CK, hopefully, that's watching this, but it used to be, before MITRE ATT&CK existed, it was a lot harder to find out what was all the techniques you needed to know about or worry about as a defender. You had to go read 5, 10, 1,000 blogs to keep up on, which ones were coming and which ones were important and all of that. And, before this, we had the cyber kill chain, which was a seminal sort of model in how to think about defending and mitigating. And this has really enhanced that world. And I think the folks at MITRE have done a very impressive job at really curating what would otherwise be an incomprehensible space. And many of these elements are contributed by folks in the community and organizations as they see attacks. And so this alone just helps create fewer places for defenders to look to know about the kinds of attacks they need to know. And if I look over like what's happened in the world of MITRE ATT&CK over the last year or so, one, it's been adapted from just this enterprise network attack model to other domains of attack, industrial control systems and operations technology, containers, cloud. There started to be techniques contributed to it by Microsoft and others about what does it look like for Office 365 or Azure or AWS, and the power of that is, you have one model defenders already know about, that vendors understand, and then we can go reflect the new techniques that are needed that that InfoSec is of course full of as research advances. and just reflect them in a common model people can work on, and that's great. And even if you go back to SolarWinds with, we call the actor Nobelium, and FireEye calls them UNC 2452. The folks at MITRE were identifying, these were the techniques seen by that actor, highlighting those in a blog, and then crucially adding new sub techniques to account for the new things. And that was part of why the SolarWinds incident was, took so much time and energy to respond to, because they were new techniques that were seen that weren't even, documented in MITRE attack that defenders had to know about. And so I think this knowledge and way of curating it is especially important for defenders. And then knowledge is great, but knowledge doesn't detect anything in the real world by itself. For that, you need detection, you need hunting, you need alerts, something to go find that. And for that, I really like to highlight the Sigma project. And if you don't know about what Sigma is, it's essentially like most of the way things get detected are, you look in logs or packets or files for things, and you have some way that you express a detection. For files, that might be a Yara rule. For logs, it could be some, ArcSight query or Splunk query or whatnot. And for every data source, especially for logs, you basically need to write a query in the language of the query tool on the data model that's of the data. So it's very, very fractured in that way. And wouldn't it be nice if you want to detect an attack that we know about, and I'll use the sticky keys attack as an example. That's a certain attack that abuses accessibility apps in Windows. There's ways to detect it. If certain registry keys are done, or set in a particular way, or certain files are overwritten, a sticky keys attack is happening. And wouldn't it be nice to write that detection generically once, and then be able to run that over all kinds of different log sources, whether you use Splunk or Sentinel or ArcSight or CrowdStrike or whatever. And Sigma is that sort of write it in this generic language to capture that. And now a generic language by itself would not be super useful if they did not have, ways to translate it into all these backends that people use. So Sigma also has like 15 or 20 providers that translate that generic syntax into all of the different query and answer tools, Elastic, et cetera, that people are using today. So that's really the two-hit punch that it has. And this there's a rule repository largely maintained by Florian, Sigma rules across all different layers of the attack. These are examples of these YAML files that are these rules. These work on, sysmon logs. And then this is an example of what a detection looks like. This is one that's designed to detect the sticky keys backdoor, where you're seeing, it launch any of these, accessibility applets or overwrite these registry keys that tell you that this attack may be underway. So this is like, in a way, it takes what was before just an element of the MITRE attack matrix that talked about this kind of thing. And now you have concrete detection that you can translate to run, in your detection tool. And these are all the example backends that have, translators for these different things, and of course the idea is to have translators for all the different popular products out there. So now if you come up with a new MITRE attack, like a new technique, Nobelium or otherwise, and you can build a generic Sigma detection for it, everybody that uses these tools have a way to get started with getting actual alerts and detection hits in the real world. So that's great, because now we've gone from knowledge to making that knowledge executable in concrete ways that work with a wide variety of defenders in a way that's entirely open source. So that's great. And then in the world of Sigma, you've seen quite a bit of adoption in the last year of Sigma rules. So Joe Sandbox has a way to run Sigma rules with it and has some by default. The SOC Prime team has built a bunch of Sigma rules and has a way to work with the community to get more developed. And then VirusTotal will run crowdsourced Sigma rules that are backed by a GitHub repo on detonations they're doing of files in a sandbox that get uploaded to VirusTotal, and you get those matches on VT, and then you can go query for those. So you see this open source tech go from a project to being incorporated in a lot of the tools that defenders are using today. So that's great. And then this is the part I really wanted to spend the majority of my time on here at Jupyterthon, which is Now, once you have detection and alerts, now begins the process of hunting and analysis. And for a long time, the world of analysis was something like, an analyst sat in front of the keyboard, spent a lot of time in Excel or some other tool, and then poof, an answer came out. And then they wrote that in an email or added that to a ticket. And that's sort of how it happened. And you kind of go, what did they do? How did they do it? How does a junior SOC person know how that experienced SOC person got to that answer? And then if you need to be able to investigate that kind of thing over and over again, how do you repeat that? How do you make it repeatable and reduce the friction of that? And so that's really where Jupyter comes in. Obviously, you've probably heard a lot about it today, and you'll hear a lot about it later. So I will sort of save some amount of proselytizing from you on it. But, it's got a super vibrant ecosystem that exists way beyond InfoSec. And that's actually a very powerful thing about it. Like when InfoSec people are sleeping, which, does happen from time to time, people in this community, data science, machine learning, they are making this tech better every single day, which is great to be able to stand on their shoulders. They have yearly conferences. If you've never looked at a Jupyter notebook, there's 11 million of them on GitHub. That's how widespread this stuff is. It's vendor agnostic. You can work on it if you use Google Cloud, use Amazon Web Services. If you use Azure, you can use it. If you don't want to use any cloud, just use it on premises on your local machine. You can do all of those things with it. So it's very flexible that way. The crucial thing about it, where I think it helps on making analysis repeatable, which is super important for scale and teaching, is you have a way to do your analysis in this notebook. And then the notebook is basically a file. And then with that file, you can give it to other people and share it with them and say, here's how I analyzed this attack that was doing this strange PowerShell command line or whatever. And then they can rerun it on their data and maybe find the same attack, decode it in the same way. And then it's very extensible because it stands on the shoulders of a very open source ecosystem, especially the Python ecosystem. And so, I'm sure you've seen notebooks already if you're tuning in, but if you're just tuning in for this talk, it has this model where you have a way to, command it, run a query, for example, get output back, and then render it, visualize it, and so on. So I'll walk through a couple of easy use cases, and then I'll spend some time on what I think the journey is that we have with Jupyter. So this was a notebook that I had created with it was called Defender ATP at the time, but it's Microsoft Defender for Endpoint, where let's start by getting some alerts, and you have ways to go connect it to your systems that have your alerts, and then you can bring it in. And then this is a pandas data frame that is being rendered here. I know you've heard about pandas already today, but it's a way to go, fetch the data you need first of all, and then get it in the notebook where you can start to interact with it. And you may, today, some analysts may go, look, I know the portals that I use today or the tools I use to go use this data. I like those tools. But if you ever want to go beyond those tools and what they can do and enrich it with ways that those tools can't do, and you don't want to be locked into what the vendor or the maker of the tool did, the notebook is basically the sky's limit of what you can do. Because if you can bring it into the notebook, you can do a lot of things. And then this is just showing how you can use a pandas data frame and pandas syntax. This doesn't even feel like writing code here, and you're selecting columns and slicing through the data set here. And then of course you can do pivots, summarize things, do aggregations, plot things, and all this kind of stuff. And this is again just using all of the open source ecosystem here and just showing some examples. And then commonly as analysts, Intel analysts, we need to go hunt, enrich, and visualize. And those things are all possible where you can develop ways to go write your hunting queries in whatever your query tool is, go get those records, and then start processing them, refining them. And this is just showing, let's go take some set of hashes or files or URLs, and let's see what VirusTotal knows about these things. Or you could think some other Intel data source that you need to know, or maybe your own historical set of events and say, have we seen this before? And then you can go and query those things and bring that in and enrich it and then continue to refine it. And then of course, visualize it. All tools have some visualization. I often find security security use cases need to get beyond, bar charts and line charts and pie charts to more interesting visualizations. This is a chord visualization. And the idea here is to render kind of like who's talking to whom, which machines over here are talking to what net blocks. And this could be useful if you want to know, like, hey, this block of machines should be pretty much communicating identically to a common set of target infrastructure. And then, are there any outliers? This would be a quick way to visualize, hey, there's a bunch of machines talking to a consistent set of things, but suddenly this one machine is talking to some net block that's different. So this is kind of a versatile visualization that you get access to through Jupyter, through Bokeh, but you can apply it to any data that you want to snap into it. And then these are some screenshots that Ian gave me that show more of the visualizations that security professionals do. Like, we often need to show hierarchies, like parent-child process trees, for example, and zoom and slice those. Or look at anomalies. This is kind of showing like data points over time. Like, clearly there's a work week involved, or a Monday through Friday effect, and then maybe outliers on the weekend and what's going on with that, or just a work day. And then who's communicating to whom, to see, again, if maybe you can find command and control or some other illicit communication through these things, and just opening up your data to the richness of the ecosystem that's out there. And then as you would spend time developing kind of, the ways you need to interact with data, what you find is it's better if the tools know about security data, that it knows about IP addresses and domains and hosts and hashes. Those are not, like, Python's going to know about, ints and scalar types and doubles and floats and all that stuff and strings. But, the data types of defenders are these other ones. And so Mystic Pi is this open source library that Ian and others have contributed to that make it easy to know about the data types of an analyst, and then do operations on them, like take an account or a DNS name or a host, and then pivot, with operations that are contextually sensible to those in a way you can extend. And then notebooks are great, and you can run them by yourself, but some powerful technology that is out there is, once you have it in a notebook, you can schedule it. And so Papermill is another open source tech that allows you to take notebooks and automate them. And so imagine you write a hunting query, it goes and fetches the data, and then it removes false positives, enriches it with other things. Then you set some threshold and you're like, aha, now this is the stuff. This is really where I want to start my hunting. Not that first step of the raw query, but 7 steps later after the thing's been enriched. If you embody that in a notebook, you can start on step 7. And then with Papermill, you can schedule it so it runs every day for you. Or it runs every time an alert comes in of a specific kind. So you can always start on step 7 every day. And I feel like this is a very powerful concept, because forever, it feels like in the world of a SOC, if you're an analyst and you know how to analyze, but then you want to automate, you often have to swivel chair to some other engineering team to say, can you automate the thing that I did and make it happen regularly? And with notebooks, because you can schedule and run them, the unit of your automation is now the same unit that you did your analysis in. It's the same tool. And that's a really powerful place where now a SOC analyst can really be in control of their own ability to automate and be productive by using the same technology across both of those spheres. So I'll switch gears here just a little bit and talk about the journey. I'll talk about my journey with Jupyter. So for me, it started with a visit to Lockheed Martin. In 2014, I went and met with Eric Hutchins. And, I was really fortunate that he took the time to meet with me. And it was a bit of a show and tell of, here's what we're doing on threat intelligence and stuff, and what are you doing? And he introduced me to Jupyter Notebooks. I had not heard of it at all at the time. And this was a sample notebook of his that's on his GitHub from, using, I think, some forensics use case or whatnot from 2013. And so if you're just hearing about this now, Eric was doing this in 2013. Like, some defenders, they are that far ahead of other defenders. And how powerful would it be to be able to leverage those insights, share them, and have everybody, benefit from all of that knowledge. And so I'm really thankful to Eric for showing this stuff to me, because honestly, I don't know if we would have all of the researchers that we've hired and the progress that we've made sort of without some of the sparks from Eric back then. And then I spent some time, over the intervening period trying to learn it and install it and just thread that in with my day job. And then finally got, some wieldiness with it. And you see here, 2016, I'm socializing this at Microsoft. This was this email I used to send around to the team, and I'm showing off the ability to visualize stuff in it. I learned about Jupyter Magics and how that allow you to really, this is a Jupyter Magic that allows you just to paste in, for example, just text. You can see some unstructured stuff of Dooku hashes and then some MD5s. And can we regex through that, get those MD5s. And then the next steps would be look it up on VirusTotal or Windows Defender. What do we know about these hashes and so on? So this is me socializing it. And then Netflix in 2018 did a bunch of blogs around how crucial and how much they standardize on Jupyter at Netflix. And even though you don't think of Netflix as somebody in the InfoSec world, these were really meaningful to me at the time, where they said, we think, you think of Netflix as, that website you go to or app you go to watch the next movie or show, but so much of their business is predicting what you want and what you want to watch next. So there's a huge data science component to what they do and big data approach. And Jupyter is a technology they found that really works well across all these different roles and skill sets to go explore the data. And I thought, boy, that is powerful and that is cool. And then Papermill, that's a project that they worked on to automate the thing that they saw. So now you have a lot of others outside of InfoSec making key contributions. And then I wanted to apply this to the security products at Microsoft. So I built this notebook for Defender ATP. They've just released some APIs. And so this was the first blog post we did that used and called their APIs and showed how you could do it from Python and use a notebook for it. And then I was asked by the folks at MITRE to do a talk at the first AttackCon conference. And I talked about a lot of these concepts there about MITRE ATT&CK and Sigma and notebooks and so on. And then Sentinel. And so Ian sort of mentioned this in his introduction to me, which is at some point we were developing Sentinel and I was like, Cloud Scene from Microsoft, this is going to be great. And I was like, whatever we do in the product, the real power is the data that's in there. And you got to give people powerful ways to go access that data, and analysts will do cool things with it. So we got to have a notebook way to do this. So I was sort of evangelizing this, right? And at a certain point, I was kind of running out of time to do the ground game of well, use notebooks how and to do what and how should they connect and all of. And I was like, all right, the opportunity is going to pass us by unless we can actually go spend the time to dig in. Ian, go learn about this Jupyter thing. And Ian was kind of like, John, how'd you get my email address? And then secondly, what is this Jupyter thing? And then he went off and spent time with it. And the reason, that we have these notebooks in Sentinel today is one, because of Ian's work with it. And then that would never have happened without Eric showing me these things such a long time ago. So that's a bit of the journey that I've had with it. But I also find, of all the topics I've talked about today, think of MITRE ATT&CK, very widely adopted by InfoSec and the vendor community and the industry at large. Sigma, I'd say less well known, but you see adoption out there. You see people know about it. You see new pull requests happening to it. And I would say Jupyter is the third. It's if you go look in every SOC, you're not necessarily going to find it. Maybe some people coming out of school have more experience with it than us grizzled InfoSec veterans have with it. And so it's also got more friction to the cost to use it. So I find that this journey exists with Jupyter where, at first you find people, they're not even on the trail or the trailhead. They're still in the parking lot and they're stuck. They're like, look, this sounds interesting, but I'm not a programmer. I don't know Python. I don't have the time to learn all these things. If my boss isn't going to support it, there's no point, where do I even start? And getting, I think, all those problems are worth overcoming for reasons I'll mention later, but getting folks off, out of the parking lot and onto the trail and on the journey, I think is crucial for us to do as a community. And then once you're doing it, you end up in this part that I call the chasm, where you're like, I know how to do my job today and I feel productive with my tools. This tool doesn't feel as productive for me. I don't get it. I'm on Stack Overflow 10 times a day trying to figure out how to make it do the thing I want it to do. And you're less productive for a while. And then if you stick with it, you'll get on the other side of that curve where suddenly you're like, oh, wow, this is great. I actually feel like I can get things done with it. And then you get to the plateau where it's like, I now have some basic wieldiness with it, but like not everything that I am using it for supports it. And I need to go improve that and have it talk to my Splunk or Sentinel or whatever you, Elastic, whatever you use. And then you go through this dip a number of times, and then you can end up on the ridge. The ridge is where like, you've had your religious moment with this tool and you're like, you're never taking this tool away from me. I'm never going back to how I used to work before. And almost, can you even relate to the people that are in the parking lot or in the chasm? And so I put all these here because I feel like Jupyter has this journey. And I think as a community, we want to know if you feel stuck in any one of these, that's okay. That is normal. And I feel like as a community, we need to make sure we figure out how to ways to make this curve more linear, shorten the time in these chasms and plateaus and get people further along in it. I think, I'll kind of end here, but this is where I feel like these are the 4 areas that as a community, I think things like Jupyterthon can help with, but will not really make progress without all of you all helping, which is every org needs some pioneer. I call it a leader, but it's really just somebody willing to commit to learning, feeling dumb for a while doing it, and willing to share what they did and having like that empathy and approachability to just say, I'm going to go slog through this for a bit, and then I will tell you what I've learned, and just stick to it, stick with it. And then as a community of professionals with Jupyter, we need to make it easier to like, how do you get started? What's the step-by-step journey? What are the tools? If you want to spend time, the most efficient way to spend that time, and then build these connectors so that Jupyter talks to everything that we need it to talk to, and defenders don't get themselves stuck right away on some integration plateau. And then have more events like Jupyterthon where we come together with a diverse array of speakers that are coming from every level of experience, not just super experts, but also people early on in the journey. So I feel like if we could really stack these concepts together across MITRE ATT&CK, Sigma detections, notebooks, and you think, boy, wouldn't it be great to have a world where there's a MITRE technique for every attacker TTP, there is a Sigma rule for every MITRE technique, and then there are Jupyter notebooks already made to investigate every kind of Sigma alert. That would be a much better world that I feel like would accelerate the experience gap needed for people to be successful in InfoSec. And so with that, I'll end here. I thank Roberto, Ian, the attendees for the time today. Thank you very much.
Hey, thanks very much, John. That was, unfortunately, we haven't got any way of getting applause, but I thought it was a great talk and really great kind of motivation for like sticking with the gnarly bits of Jupyter and getting to the kind of benefits that are on the fast end of the trail. So I think, unless Roberto's got any other things, we're going to break now for an extended period and resume back at 1 o'clock PST, 4 o'clock Eastern time. And
yep. Something, so we can break for lunch too. So I just had one comment or maybe just one question for John is, so something that I believe was taking a lot of, had a lot of momentum, and I believe it still has in the data science community, was the project binder to be able to share infrastructure. So for example, a lot of the questions that we had today was, what is the easiest way to interact with the Jupyter Notebook, right? And today we share a lot of ways, right, to do it. And it seems that something like Binder, where cloud providers provide their infrastructure, like, provide credits to the Binder project, is that something that you see maybe also happening, like the InfoSec community having its own cluster where notebooks could be shared, I guess. Easier.
I think projects like Binder, I mentioned it here on this call to action, which is like, if you want to start with Jupyter, it needs to be go to this URL and play with it. And that's it. Like, that's the threshold. It's not pip install 35 things and then, 17 steps later, recompile your kernel and then you're good. Like, it needs to be, you go to a web page and you can play with it. There are some places where that is the case, and they're more like guided tutorials, and it's powerful when it's like that, but it needs to be like that to get started. And Binder is one of these other great projects that helps make that possible. So yeah, I mean, if we can think of like community, like how do we harness this community and make it easy for them to try and get started with this stuff, I would definitely be all ears on what we can do.
Yeah, we should have because I know that there is ways, right, to deploy the same cluster, the same Binder cluster for specific use cases, and then have and point it to a repository, whatever it is, GitHub or anything where data exists, where you can have multiple use cases, so people can just play on their own. I think that would be amazing, having like open infrastructure. Of course, for definitely with limitations, like Binder has like 15 minutes of kind of like the idle notebook, and then just have data available, something that we can share with our community. I think that would be amazing, so people can use it.
All right, let's get it done. Ian, that's your next project. So
yeah, definitely we should.
Yeah, fund Binder. That's like, yeah, okay. Check my wallet.
Sounds good. Hey, thank you very much, John. Thank you, man.
Yeah, thanks very
thank you
much.
all.
This is fabulous.
Appreciate it. All right, so I guess 45 minutes, right, Ian? So we go back 3:50, right?
Yeah, that's right. Yeah,
My time.
Well,
Yeah, so 12:50.
12:50 Pacific time, 3:50 Eastern.
Yeah, so 12:50 Pacific, 3:50 East time. All right, sounds good. Well, then I'll see you all, and we are going to start with our first presentation after the keynote. So I'll see you all in 45 minutes, 40 minutes.
Okay.
All right, thank you. All right. So let's see. We have Elizabeth already joining us. But first, we're going to. Hey, Elizabeth. Here we have you. Let's see. Let's give you a couple seconds. Hi, Elizabeth.
Hey,
How are you?
I'm doing well. How are you?
Good, good, good. Thank you for joining us. So first, I'm going to just introduce just the sessions in general. So I'm going to show everybody the agenda real quick, and then we're going to start in only a few minutes with your session. So let me first share my screen so I can share this with everybody, so everybody could see exactly what it is that they can see in our. Let's see. Okay. All right. Just get out of this. Sorry, I gotta change my screen. Let's see right here. Okay. All right. So for everybody who is joining us right now, so we have so if you go back to the InfoSec Jupyterthon once again, and you click on the 2021 edition. So here's where you can see all the presentations again. So day 1 today and also Friday. And so today we finished with our workshops. We also had our keynote, and then now we're going to start with our first presentation from Expel. So if you have any questions, please put them in the Jupyterthon channel in the Discord server. And from there, we can just talk about every single session that we're going to go over today. Every session will have at least like a couple minutes. I would say that usually would be 5 minutes for a Q&A. But if the presenter goes over for some reason, which is fine, all the questions can still go to the Discord channel, and then the presenter can just respond to the questions in there. So we have a 30 minutes presentation, 5-minute break. That's kind of like the rule, but it's totally fine, right? If for some reason we go over. So, okay, well today, once again, so we're going to be talking with Elizabeth Weber. She comes from Expel, and she's also a data scientist for Expel. And something that was very interesting in your bio, Elizabeth, which I think is a really cool job, is trying to make a SOC more efficient. Like, trying to drive the efficiency of a SOC operation in general. It's like a fun job, to be honest, because, for example, I used to be a SOC analyst and I loved my job before, but it was, of course, like a little bit stressful trying to figure out the incidents, like going very deep into all these different things that were going on every day. And I believe that kind of sometimes is stress. Like if you put that aside for a little bit and then you focus on the process, it's like a very interesting process. Every company goes through different, I would say, challenges in general. So it's a very interesting type of job to have, I guess. So I just wanted to share that. Okay, so, well, I guess let me just give you presenting rights. So you should be okay sharing. And if you want to start now, so we can just go ahead.
We'll head start. Sure, yeah. Let me just check. Do you see like a notebook on the screen?
Yes, I can see your notebook now.
Okay, awesome. Thanks for the intro. Yeah, I'm going to go through a few different examples here, and the last two have a strong focus on that efficiency perspective. So definitely keep that in mind. If people have questions about that as I go through those in particular. But hi, everyone. My name is Elizabeth Weber. I am a data scientist at Expel. I have been with them for about 2.5 years now. And prior to that, I was a data scientist for a company called Nielsen, doing a lot of like market research type analysis. So kind of a different type of research at that company. So today I want to talk to you guys about how Expel uses notebooks to basically impact different parts within our organization and different organization levels. So I'll go through, like I kind of mentioned before, I'll go through 3 examples, and we're going to talk through how 3 different departments within Expel have been able to leverage notebooks to really drive impact within that part of the business. Before I dive into those 3 specific examples, I want to give you guys the 30-second super high level overview of what Expel does, just to kind of level set and paint the picture when I do dig into those 3 different departments. So again, super high level, Expel is a managed detection and response company. And so how it works is we ingest security signal from our customers' vendors. We turn those into Expel alerts. And then our analysts, our SOC, will triage those with the help of some automation and technology. And with the analysts are then ultimately looking for evil and malicious activity within our customers' environments. So super high level, but just to kind of like set the stage a little bit for the examples I'll talk through, and how the different parts of the business kind of all fit together. So again, I'll go through 3 examples, and the framework kind of looking at this from is how notebooks have helped us drive impact within each of those departments. Obviously, everyone in their day-to-day job wants to make sure the work they're doing has impact, whether that is research that they're working on gets implemented in your product, or as a management team, the decisions you make are having a good impact on the people that you manage and keeping people happy at their jobs, and making sure that they're not overwhelmed in the SOC and that type of thing. So all of this is going to be from the reference of how notebooks have helped us make sure we drive really positive impact within each of those kind of departments. So the first example I'll go through is how our customer success managers have used notebooks to drive really meaningful and data-driven conversations with our customers. And then as a result of those really great conversations and metrics-driven conversations, how that also impacted releases in our product and our Workbench platform that customers now have available, at the touch of a button as a result of that. Then we'll talk through how some of our SOC managers use notebooks to improve SOC management. So how they're able to look at data through these notebooks to kind of drive some of their decisions. And then finally, we'll close out with how researchers within the organization are able to use notebooks to really quickly iterate on that research, document that research. And then in the particular example, I'm going to share how that ultimately drove impact by implementing the research example that I'll go through in a way that allowed us to reprioritize the alert queue to make sure that the most likely to be malicious alerts are getting viewed by our analysts first. So looking at customer success team, some people on our management team, and then our researchers and how they're using it. So with that, I'll dive in to our first example. So we're going to talk through how our customer success team uses the notebooks. And the ultimate question that team is always trying to answer is, how do I talk about the value of the business to my customer? And as a subset of that, they might be asking questions like, how many alerts are we handling for the customer? How many became investigations and incidents? What time of day are alerts arriving? Lots of stuff just about like, what does the customer environment look like? And so the problem we were trying to solve here is the customer success managers want to be able to have that conversation, but we need to allow them or enable them to do it in such a way that scales really easily. So prior to the solution that I'm going to talk through that we implemented, that team would have to manually gather data, manually calculate metrics, and it was taking a large chunk of time to do that. And so prepping for every single customer conversation just became this very time-consuming task. And so the goal in using notebooks was, how do we take that really time-consuming task and create a solution for this team that makes them able to get those metrics at the touch of a button in a really scalable and easy way, so that they're not spending so much time having to prep for those conversations. And so ultimately for us, the answer to that question was, we use notebooks. And even more specifically, we use notebooks in this platform that you can see on my screen here, which I'm assuming a lot of people probably aren't familiar with, but this is notable. And what was great about this for us is, like, we are able to just share a link to a notebook with our customer success managers, and they can click on a link, go to this notebook we've built for them, click a few buttons, and have all their metrics delivered back to them. So the whole process of them gathering metrics is now very, very simplified and very easy. So let me dive into kind of what that looks like. We are heavy users of widgets to simplify the way notebooks look when we're providing them to other teams. So we kind of have tried to use widgets for this to create almost like a user interface type experience where someone who isn't used to writing Python code doesn't have to look at a bunch of code. They don't have to write a bunch of code. They literally open up a notebook and click a few buttons, and it populates what they want to see. So we're going to read in some dummy data here, and I've preloaded this because some of the cells take a little bit of time to run. So I just went ahead and preloaded, but we're going to load in our dummy data, and then we're going to set up the user interface that our customer success managers would see. So when they open this notebook, let me collapse this to show you kind of what their view looks like. They're going to come into a notebook that has some documentation at the top that says, hey, this is how you run the notebook. And then they're going to have their cells of code collapsed, and they literally just click this play button. So I'll uncollapse that just so you guys can see the code, but they'll click a play button and then they'll get these prompts. And so the way it works is they'll go in and they'll say, okay, I want to pull metrics for my customer for these dates. I just selected like a short time range here. And they'll confirm that. And then they have some options here that allows them to customize this report to specifically what they want to talk about with the customer or their needs. So we give them a couple of options of metrics to provide. A ton of metrics are standardized, but they can choose if they want to see these additional ones. They'll go in, they'll select their customer. So now we've got this report where we can run it for any of our customers. And then they can say, do I want to do a peer comparison or not? And if so, which customer or customers do I want to run it for? And they're just selecting that here. So they set all these fields, and then all they have to click is generate report. And once they click that, they're going to start to see these types of fields populated for them. So we provide a lot of metrics in the form of plotly plots. And these are nice because they're really interactive. Like you can hover over and provide extra information to the user. In this example, am just going to show 3 of the metrics populated from the sample report that I've included in this notebook. But in reality, we're providing them like 30 plus metrics that they can look at. And really the goal there is that each of these individual managers knows what their customer wants to talk about. They might know some pain points the customer is having. So we're providing this standardized set of 30 plus metrics. And then the customer success manager is now enabled to go in and say, I want to talk about these specific metrics with my customer. Those are the pieces, the subsets of the report that I'm going to pull and include in my presentation to them. And then even the ones that they don't include, it's good, right? It provides extra background information to help them answer questions that might come up or that type of thing. So I'll just talk through the 3 examples that I pulled here. Again, these are all going to be plotly plots that we've used. The first being customers might want to understand what time of day their alerts are arriving. So this is a heat map that shows on the vertical axis the day of the week, and on the horizontal axis, the time of day. And so unsurprisingly, alerts are kind of like the hot spots on this map are kind of in this middle portion, which is going to be your weekdays and your standard business hours. So nothing like too surprising there. We see one hotspot here, so you might be able to go in and ask questions of like, what caused that? You can tell the customer, hey, we saw this, we know what's going on. It's not anything to be concerned about, kind of enabling those types of conversations. But customers really liked being able to see what time of day their alerts are largely arriving at. And then we even see there's a little bit of heat here on off hours too, not during your typical business hours. The next one is showing how long an alert sits in our queue before someone has eyes on it. So we prioritize alerts based on severity from critical to low, basically, to tuning, basically. And so we can look at this and we can show on the horizontal axis the median time to action, and then on the vertical axis by severity. So critical alerts and high alerts we want to get to super fast because those are most likely to actually be malicious. So here we're showing, okay, for this customer, they had 150 high alerts and we actioned those alerts in less than a minute. So we're able to very transparently tell the customer and show the customer how quickly we're getting to their alerts, or how long their alerts are sitting in a queue before someone has eyes on them. And then just one more, this is just a Sankey diagram, again, using Plotly. And we're showing, oh, I got a little cut off here, but we're showing based on vendor type, are our alerts getting closed? Are they going to investigation? Are they going to incident? To help the customer understand, like, where are most of their investigations and incidents coming from, and that kind of thing. And then these aren't run from code. I just took a couple screenshots from past reports that were run, but like, just to give more idea, we can also, the customer success manager can also choose to compare their customer to peers. So here is a heat map that just shows for a customer versus their peers, what does alert volume look like when they share vendors? So if you see a hotspot like this yellow one here, you might be able to have a conversation of like, you've got a lot of alerts coming from here, your peers don't, could we do tuning or something like that? So the ultimate goal of this whole report is that we deliver metrics that enable the customer success manager to have a really meaningful conversation with the customer, but we're doing it in a way that they literally just have to select a couple of things, click a button, and the metrics get populated for them. So we're cutting down on that time that they were having to use to manually prep for these conversations before. And the really cool outcome of all this was that, you know, like I mentioned before, there's 30 plus metrics. The manager can go in and they can say, these are the ones I want to talk about with my customer. These are the ones that are going to be meaningful to them. And so across the customer base, we could start to see which metrics were getting used over and over again in these customer reviews, which ones were resonating really well with customers. And so what that turned into was being able to add some of these to our actual product. And so now within our Workbench platform, a customer can go into the platform and see within a dashboard what their heat map of arrival times are. So they can look, they don't have to wait for their customer conversation with Expel. They can go into the dashboard at any time and say, okay, what does my alert arrival time look like? Is it what I expect? And they can also go in and see, okay, typically how long are my alerts waiting before Expel is looking at them? And now they have that available to them at the touch of the buttons. So in this particular use case, not only did notebooks kind of speed up the time frame that people are spending on gathering metrics, but it became this place where we could quickly iterate and actually drive change within our product based on feedback we got from metrics that were provided in a notebook. So pretty cool to see that full cycle. And even as we continue to iterate on the notebook, we know the notebook is a place where we can quickly say, oh, your customer wants to see this metric. Let's quickly add it. Let's see how it resonates. And you can kind of test stuff out in notebooks then to potentially in the future add to the product. So very cool life cycle to see it go from this manual data pool process to something that's available in this almost user interface type space in a notebook, and now available in the actual product. All right, so that is the first use case. Let's jump into the second one. And like I said before, these last two we'll have some focus in on kind of like the SOC efficiency piece that was mentioned in my bio. But the second team that's really heavily using notebooks are SOC management. And ultimately, the question that managers are asking themselves is, how can I help my team? And they might, like as a subset of that, they might be asking questions like, are my people overloaded with work? What time of day do alerts arrive, and how should that impact how I choose to staff my SOC? Are we seeing consistent trends in when alerts arrive? those types of questions that they're wanting to answer for themselves. And so for this group, we were again able to use notebooks to kind of make some statistical analysis really accessible to these groups. So the example I'm going to go through today is how some of our SOC managers are using a tool called seasonal decomposition to understand alert arrivals and help answer questions of like, is my process in control? When are my alerts arriving? And how should that impact how I staff my SOC? And that kind of thing. As a side note, I have also included some links in here, like when this notebook gets shared out later, I've included some links for if you're interested in just like how SOC management thinks about metrics, to some past blog posts that were written by them, just in case you're interested. So before we dive into the actual code of it, let's do like a quick high level on what is seasonal decomposition. This is basically a way it's a way to basically look at time-based data and understand the overall trend, the seasonal or repeated patterns, and then whatever randomness is left behind. So we're breaking that overall, and in our case, we're looking at alert volume. So we're going to say, what does our alert volume by day look like, or our alert volume by hour look like? So we're going to aggregate counts of alerts by day or hour. And then we're going to break that down by trend, seasonal, and residual. So the trend, again, is just overall, once we take out seasonality, what are we trending up? Generally, for this piece, you're kind of thinking about like a rolling average type of calculation. Then the seasonality piece is that repeated pattern. So think of this as like in the SOC, what we're going to see is we have higher alert volume on weekdays as to be expected, and lower alert volume on weekends. So seasonality is like, what is that repeated pattern that we're able to pull out of the data that we see consistently over and over again? And then the last piece is the residual. This is kind of like, you can think of this as just like random noise once we've pulled out the trend and seasonality. This is what could not be explained or captured by the model that creates these other two pieces. So kind of like your random noise. And as you can see here, we expect a very random pattern. So I've gone ahead and loaded in the sample of the data. This is just dummy data, but basically all you need to run this type of analysis is some sort of data that can be aggregated by time. So in our case, we have an alert and the time that it came in. And all we're going to do with that is aggregate it by either daily or hourly type counts to run this analysis that I just showed previously. So how we make that available to managers and notebooks is, again, like heavy usage of widgets. So previously I kind of, I didn't go into a lot of the code detail of widgets, so I wanted to touch on that a little bit here. We first are going to say, we're going to provide an option for the manager to say when they want to pull their data for. So for that, we're just using a date picker, the widget date picker. You give the widget a description, so you can see we've called it a start date and an end date, and that's what shows up next to it to explain kind of like what the user needs to input. And then we're setting disabled to false. This just means it's not grayed out. Sometimes you can set these to like gray out so that they execute in order if you want to get more complicated. But we're setting it so the user can come in and they can select these things, right at the exact same time. And then we just tell it to display those. So then the user goes in, they select their dates. And then on my end, once they've selected their dates, I'm accessing those values with the dot value. So they've selected a start date. And for me to pull that value, I just have to use the start date widget dot value field. And that will return to me whatever number was selected here. So once they select their dates, we're going to return data to them. I've kind of mocked that here as just like a data subset of the dummy data. So that's what you'll see here. On our end, we're pulling the live data from like our Workbench platforms. But once they've selected their dates, now we want to give them the option to run whatever statistical tool they want to run, whatever ones we've made available to them. So let me jump down here real quick. The way this widget is going to look once it's all built is they have this drop down where they have three options. Do we want to run seasonal decomposition, which is what I just talked through? Do we want to run change point analysis? Or do we want to just look at a simple time series graph? So these are some of the options we might make available to them. So the user will come in and they'll select one of those, and then they are just going to hit display stats, and that executes to run one of these. So if we pop back and look at the code for that again, since I had skipped over widget code previously, let's talk through this a little bit. So the first one to get this drop down is just a widget drop down, and then we're telling it the options that we want to be available. So we put just like 3 examples in there. And then the description, this is what we're just saying tool, telling the user they're selecting their tool. And that's what you see right here. And then we just display it. And then,
Elizabeth,
yeah.
Sorry to interrupt you mid flow. Could you zoom in a little bit so that the font's a bit more readable?
Oh, good call. Sorry, I am zoomed out. Is that better?
That looks good to me.
Okay, cool.
Thank you.
Yeah, sorry about that. So yeah, so then that's our drop down one. And then we also wanted to implement a little button that says to execute. So we're writing this as a function that says when they click the button, run these tasks. So if they selected seasonal decomposition, we're going to run the decomposition. And then I just added change point in there as a dummy. I didn't actually provide the code for that. So if like you go back to use this notebook and select it, it'll just say, sorry, there's no code included for that. And then just a basic time series graph. So like, do we want to just plot the absolute raw data there? And then, so basically the way that works is it says once the user clicks the button and they've selected the value from the drop-down menu, it's going to run one of these tools. So in this case, I preloaded it with the user having selected seasonal decomposition, since that's what we're talking through. So in this case, the user is able to see, again, those 3 pieces: trend, seasonality, residual. With the trend, they might look at this and say, okay, we're trending up, probably something we want to keep an eye on. It's a pretty steep upward trend here. So you might ask questions like, did we onboard a new customer that is really noisy or something like that? Like, what's going on that's making that trend steeply up? We're seeing this repeated seasonality. And so we're seeing the spikes, these are weekdays, and then the drop-offs on the weekends. Obviously, no surprise there. If you did like an hourly analysis on this, it could start to help you understand even what time of day you might need heavy SOC staffage. Like if you're getting a lot of alerts, 8 a.m. when everyone logs into their computers, maybe you need heavier staffing at 8 a.m. This is all done daily, so we're not getting that level of granularity here. And then the last piece is residuals. So I mentioned before, this is kind of like the random noise that can't be explained. And so by like these 2 pieces, and so we expect this to be very random. And so how our management team will often use this piece is if we see big spikes, and I've shown a short time frame here, but let's say this is all really scrunched together and then you see a big spike, the management might ask themselves questions of like, is there an alert we need to tune? Did an alert run away at that time? Is there tuning we can do? Or what can we do to manage our queue to make sure when that does happen, the SOC isn't feeling like overwhelmed? So it's a good way to have really quick eyes on if the process is kind of out of control. If you see a huge spike in those residuals, something has happened that's outside the norm. And you want to ask yourself questions of like, what is going on that caused that? So that's kind of like I added notes here of like the questions a manager might ask themselves when they use this tool to figure out how to effectively staff the SOC. So ultimately, this is able to drive impact by the manager understanding, having a really clear understanding of what's going on in the SOC and using these tools to ask themselves questions of like, how do I improve how I'm staffing SOC based on what I know about when alerts are coming in and that kind of thing. And again, all done in such a way, like the heavy usage of widgets means that it's done in such a way that even if you don't want your user to have to look at code or anything, you can collapse all the code and just have them clicking buttons and they're able to see all this stuff, which is really cool. And then the last use case is for the research type team. So for me, this question is, how do I easily document and iterate on research? And heavy emphasis on document too, because as researchers, sometimes you are in the middle of working on a project and a higher priority, something comes up that you need to put this project on hold. You're going to come back to it later, but you've got to, you got to take a break on it to do something else. So I always think it's harder to come back when you've put something down for a few minutes, or a few days, or a few weeks, or a few months. So I love the ability in notebooks to kind of like keep all your documentation and assumptions and everything in one place. So you can answer like, where did I leave off? What was I planning to do next? What were the assumptions I made? How did I pull the raw data in case I need to pull new raw data because so much time has gone by? Those types of things are so easy to document, obviously, in notebooks. So I just included here like some things I might document, like where my raw data come from, what's included in it, what my test plan was, what models I want to test, what results I got for like if I made it very far through the research, and that kind of thing. So the project that I'll talk through here is we wanted to look at PowerShell alerts, and we wanted to see if we could predict how likely those alerts were to be malicious. And the test plan for that was, can we basically build out a classifier that will predict the probability of it being malicious? And ultimately how we used that was to reprioritize the queue. If a PowerShell alert comes in and it has a really high likelihood of being malicious, we're going to bump it up in the queue to make sure that we have analyst eyes on it sooner rather than later. So some of this code I'll like fly through because I don't know how much in the details you guys want to get into data science. It's all in the notebook if you want to see some of the steps. But we'll kind of quickly go through this and talk through kind of like how the notebook enabled documentation of this project in quick iteration. So again, loading in some dummy data here, you can see that we've got a feature set. So we've got some floating point numbers. We've got some indicator fields, and then we've got some just like integer count fields. And then we have our labels of was this malicious or not. So the first step in tackling a project like this is always going to be, okay, what do I see in my raw data? And so we're going to look at just basic things about our raw data to get a solid understanding of what's going on. So here, just some really simple ones. What's my split of labels, malicious versus not? What's my distribution of my variables? Do I see good variation in a variable? If not, maybe that's a feature I don't want to use. If so, that's good. Is it the distribution I would have expected? So this is great because all in one place, we're seeing what analysis we ran and we're saving the output of it. So when I come back to this later, I can understand exactly why I made the decisions that I made because all of these visualizations and stuff are right there. Then we're going to set up the model testing. So everything, all the libraries here, you can see most of what we're doing is from sklearn. And then we're testing a XGBoost classifier and LightGBM classifier. So we're going to do our basic train test split. And then ultimately what we're going to do is we're going to loop through and test each of those models. And we're going to grid search some parameters within each of those models too. So I might say, okay, what starting point do I want to use for my grid search parameters? And so I'm going to look at like one of the grid search parameters for tree-based algorithms is always your tree depth. So this is dummy data, so don't pay too much attention to what the graph looks like, but we could just run quickly, okay, what does XGBoost look like for recall at different tree depths, and test 5, 10, and 15, and that might help me narrow in what values I want to grid search on. Again, saving all this in one place, so I come back to it later and I say, why did I pick those values? It's very clear what analysis I did to come to that point. And then we're going to loop through. So in our case, in the real data that this was run on, we obviously have some data imbalance. There's way more examples of non-malicious than malicious. So we're going to score our models and optimize our models based on recall. It's important for us to catch the malicious ones. So we're going to optimize on recall. And these are the parameters that we're going to grid search through. So just some of the basic tree-based parameters. Number of trees, how deep the tree goes, that type of thing. And then you can see here, we're just setting up for LightGBM and XGBoost, what that grid search looks like. We're setting up and we're saying these are the grids we want to test. In reality, like we might be testing a lot more variations. So this is just a sample with 2. And then for each of those, we're going to fit a model. We're going to say, what were some of our metrics, precision, recall, F1 score, accuracy, all those things for both our train and our test. And we're going to print all that out and we're going to save all that so that when we come back to this later, we understand again why we made the decisions that we made. So you can see here, again, we just ran 2 models. This is showing us our training and test scores, for XGBoost. And it's telling us, like, of the grid search parameters, which parameter came back with the best results for recall. So all that saved here, so we know later. So our best model was this XGBoost one in this sample case. And then we can look, we can pull, we've saved it all. So, excuse me, we can pull, okay, what was the grid search we did? What are the parameters we tested? What was the best parameter selection that we found? We can save all that kind of stuff here. We can look at which features had the most impact on our model by printing out just basic feature importance. You could use a lot of other things here like SHAP, but basic feature importance is really easy to save here. We can dig into the details of the model. So we can say when we predicted malicious, how many actually were malicious, and see those details too. So a lot of things that we can look at and quickly be able to see and come back to later because it's all saved again in this one place, which is great. So I know I flew through that again. It has kind of like the basic steps you would go through in building a model, and a lot of the code for that as well. And always happy to answer questions on that too. But ultimately, the end result of this was we were able to, the results in real testing looked a little bit better than this. And we were able to use that model to then say, okay, when we have PowerShell alerts coming in, let's reprioritize them based on the predicted likelihood of it being malicious. So this is an example of how that might look to our analysts. We are transparently showing them, hey, we changed the severity so they know that a machine learning algorithm ran on it. We're saying we changed it from low to high due to likelihood of malicious arguments. So they know exactly what is going on and that kind of thing. So it was really cool to be able to, in this case, in research, use a notebook to quickly iterate, quickly test different models, document all of that, and then see the outcome of that actually get implemented into the product. Again, going back to notebooks have just been for Expel a great way to drive impact and see impact of the research, of the analysis, of the customer conversations actually get used in our product. So yeah, that is my presentation. If anyone has questions, happy to answer.
Yeah, so thank you very much, Elizabeth. That was amazing to see all the different use cases. I believe that Expel is one of the first companies in our last conference that we had last year. They also brought a lot of implementations of notebooks through the whole process of managing a SOC, going through the process also of investigations. It's amazing to see all the different use cases. Your guys are definitely taking Jupyter notebooks and just applying it everywhere. and it's just amazing. For example, I was talking to my brother a little bit while we were kind of working on the workshop material, and we were testing a couple of visualizations to see which one actually is easier to work with, the most information that we get just in one place by just hovering over. So we were going through several of them, like Matplotlib, Altair,
nice.
Everything. And then at the end, my brother said Plotly is the one that definitely makes more sense and it's easier to showcase. And it has a lot of features. So it's amazing to see you guys taking that to a use case that it's definitely at a business level, enterprise level, and how you use that, right, to interact with customers and managers, etc. So that's amazing. That's amazing.
Yeah, it's funny. I am Matplotlib was always my go-to. So it's transitioning is always more challenging because my default is Matplotlib. But yeah, Plotly, it's amazing all the data you can capture in a graph. And what's extra cool is like when you export your notebook as HTML or something like that, it captures all that. You can still hover, like if you've included hover tools in your plot, that's captured when you do an export as well. So, you export your results, you save them, you come back to them 6 months later, and you didn't lose any of the graph data, which is really cool.
That's amazing. Yes, one of the questions that I had, meanwhile we wait if see if there's any questions from the audience, but one of the questions that I had was what is the process to, I guess, train the managers or anybody who interacts with this? Do they see it as a pretty straightforward process, or it takes time to get them used to seeing code and also visualizations in certain areas, I guess?
Yeah, that's a great question. I think anytime we're implementing something like this, it's always a super iterative process, like a lot of feedback, right? So implementing, being really available and open to feedback, implementing feedback that we get. So I think that's like the main thing, is making sure that communication is really strong between the team that you're delivering it to and the team that's building it. But with that said, like we do the best we can with the use of widgets to hide as much code as possible when we're delivering a result to a team that doesn't use like Python on a regular basis. So we really try to hide as much as possible behind those widgets so that when they go in and use it, it feels more like I'm clicking buttons and then I'm getting the data I need without getting overwhelmed by code. Inevitably, bugs happen and you get error messages and stuff like that have to be worked through, that can be a little more challenging. But yeah, we just hiding as much as we can in widgets, and then collapsing cells and stuff like that really helps, I think, with the overwhelm that one might get by seeing a notebook of 1,000 lines of code otherwise.
Definitely, yes. It makes it so much so much easier just to iterate to the whole thing. I think that, for example, Ian Helen, right? He's part of the organizers. So Ian is the one that introduced me a lot to widgets. So
nice.
I was thinking about you, Ian, as she was going through all these widgets. Like, do you get any any ideas for Mystic Pi for your next release?
Well, we already try to do a lot of stuff wrapped in widgets because the notebook is kind of ugly. If you've got like lots of code, you can't really see the details, what the data that you're actually trying to deal with. So we try and wrap a lot of stuff in widgets, particularly stuff that's very reusable. You're like collecting date times, or you're selecting an item. You don't want to see how you do that. You just want to click on it and get onto the stuff you actually want to see. So I'm a big fan. It's a great presentation. I know you listed it as a beginner presentation, but for me it was fantastic. But maybe a little bit more advanced than beginner, I would say, some of the machine learning model construction. But it had everything in there. Great.
Yes, that was great. Thank you very much for everything, Elizabeth. Let me know how you would like to share the notebook, so maybe anybody can also take a look at it and maybe test some data as well. So
yeah, absolutely. I'll ping you with a downloaded IPy notebook version of it.
Awesome. Well, thank you very much again, Elizabeth, and I hope to see you next time.
Yeah, thank you guys.
Come back next year.
Bye. And I think we have now our next speakers, and that will be Pete introducing the speakers.
Hey everyone. So I'm excited to introduce our next set of speakers here. So we've got Neil Schenk, Sil Han, and Natanella Brod, all from Mystic, and they're going to be talking about how the Mystic Threat Intelligence team use notebooks to help them more effectively track the threat actors they look at a pretty impressive scale. So this is something I've seen before, and it's super interesting and is going to be super valuable for a lot of people. So I'm really happy that they could come and share it with the community today. So without any further introduction, over to you three.
I think that your microphone, maybe, Neil.
Yeah, I think you're still on mute. We can see you trying to talk.
Let's see. Maybe your microphone, Neil. It's in the wrong setting. Maybe.
Test.
Hey, there we go.
There you go.
Better? All right. Sorry, I'm a newbie Zoom user here. Nathaniela and Scylla, do you all want to say hi real quick? Introduce yourselves. Make sure your mic works.
Mic test 1, 2, 3.
Oh, Scylla's
Hello.
mic doesn't work, so that's a good start.
Hi, my name is
Nathaniela?
Scylla.
Yeah, I think I don't know. I think mine's working too.
Oh, yeah. See, we're a bunch of Microsofters here. We don't know how to use Zoom.
Well, I think it's Neil might not be
All
able to
right.
hear.
So on the microphone button, I had
Hear
to
any-
push. On the mute thing, there's like a button that you can push.
Nice. Oh, yes. yes.
Microphone.
All right. So we can hear you, Neil. We can hear
Yeah.
Nathaniela and Sil, right?
Okay, can you hear us?
Yes.
Okay, awesome. Cool.
Oh, maybe I can't hear. Try again.
Hello. 1, 2, 3.
I can hear now.
Okay. Awesome. Thank you, Neil. All right.
Holy crap.
Sorry, we're
See
very
why you're
newbie
audio.
to Zoom.
Yeah, we're very
See my audio
professional here,
communication.
guys.
That's good. All right.
All right. Well, that was embarrassing. Great start. All right. How do we share? Jeez Louise.
There's a button at the bottom where your microphone
it.
was to the middle. It says share. Yeah. There you go.
Not that one.
This is what happens when you ask Microsoft employees not to use Teams. Just
Oh,
forward-
Yeah, exactly. This is crazy. All right. Am I sharing?
Not yet. Let's see.
Are you serious?
Oh, so when you click share, you gotta pick the screen, maybe. There you go. I think we can see it now. Yeah.
Yeah, there we go.
Yay.
Holy smokes. All right.
Ready to rock.
All good? All right. I'm very sorry. I should have practiced this. Okay. So myself, Nathaniel, and Sil, we're going to be talking about how Mystic uses notebooks, specifically a notebook platform, to analyze threat signals. I'll just lay a quick introduction and give some background on why we kind of kicked this effort off in the first place, and then Sil and Nathaniela will jump in. So in Mystic, we have a unique challenge, which is we have a lot of data. And that data lives in a variety of different places. Some of it's in cold storage, some of it's in hot storage, some of it's behind internal APIs, some of it's behind external APIs. It's a good problem to have. As analysts, we're all addicted to the drug that is data. So it's a problem that's nice to have, but it is indeed a problem. And we found ourselves in a situation where we were frequently spending more time querying data and trying to remember how to query data, and where's my API key for this data set so I can query it, and what's the query syntax for this other data set, and how do I authenticate? We're spending a lot of time just trying to get the data into a place where we could perform analysis, and not as much time as we should spend actually doing the analysis. So from that position, from that starting point, we established two goals. The first was just to empower analysts to spend more time actually doing analysis and less time trying to query data. And then our second goal was, depending on how that went, just to scale it and make it a sustainable approach. So with that context set, I'll pass it over to Sil.
Hello. Yeah. So can you go to the next slide? So as the Neil kind of give a good introduction on the these different libraries that we have developed. So Bluehound is one of the Python libraries has been developed by Microsoft Threat Intelligence Center, has been used for threat intelligence hunting and investigations to drive collaboration across the cyber community within Microsoft. So this project was created in 2019, started with the Neil Shang's inspiration and Matt Richter's great vision for advanced data analytics. Shout out to their amazing contribution to this project. We probably could have done it without them. And the three of us got together and they started to develop this library and integrated a bunch of the different data sources, authentication modules, access to first-party, third-party data through RESTful API, all of that. So this project started as a small, small effort for Mystic TI team has been rapidly growing over the past 2 years. As of now, besides Mystic, quite a few other organizations within Microsoft has adapted this as part of their investigation hunting workflow. So as you can see in this slide, we have four primary sort of the objectives in mind. One is that ability to kind of easily query data from the multiple sources, as Neil talked about. And this is also kind of important for us because we have very wide variety of the data sources from the entire Microsoft Azure ecosystem, as well as internal systems and first party, third party. So easily being able to kind of query these data sets from multiple sources was very important. And secondly, the enrich the data using different TI techniques and metadata from these data sets. Also, this can support the sophisticated data analysis and visualization and machine learning. And also, lastly, closely integrate with our internal TI knowledge platform to kind of minimize any unnecessary steps that analysts need to take. So with that in mind, that library includes 4 primary modules and support both interactive and automation platform mode, so that either can be run on the analyst desktop and then run on a scheduled as a scheduled notebook in our internal automated platform. So Bluehound has 4 main modules. First is a query builder that has endpoint abstraction, normalized naming convention, and it comes with the data enrichment functions and some utility functions that can be used as a part of the pivoting process, and also leverage the async IO and sharding to support the big queries against large sets of data for longer period of time. So what if we want to go back 6 months? What if we want to go back a year? And it has that support so that users can pass those type of specific features as an argument for those functions. Secondly, the auth libraries, one of our key requirements for Bluehound was to be able to authenticate in a secure manner to a wide range of data sources. So Bluehound, we have implemented the support for Azure Key Vault and Azure Microsoft Security Authentication Layer called MSAL, and so that underlying structure that it can pass it on user authentication and authenticate over the wire, but user don't necessarily need to interact with this every single time, because often we have a lot of different notebooks running at the same time, and having user to authenticate every time could be very, very hard as part of the workflow. And the third is the high-level helpers. So because of this is primarily used for TI hunting, pivoting activity. So all of indicator types such as IP and domains can be tracked and enriched. And that process is codified as the classes where we can build high-order helper functions. Lastly, database access for first-party and third-party data. So Microsoft has a wide range of data sources, both first and third-party. We have built the libraries to tailor towards each data source, which then turn it into a source in the notebook. And through iterative process of TI hunting, any new research work from the hunting effort can be ingested directly into our internal TI knowledge platform, so the user don't have to manually ingest those in a separate step. Can we go to the next slide? So I just want to share a simple example of notebook that built in Bluehound that illustrates the query syntax in Bluehound and Jupyter. And this particular notebook uses the PDNS query builder, which connects to our third-party PDNS data source, then search for list of domains and the IP, then for the last 30 days, and to send the search requests using async execute with the sharding enabled. As you can see, this PDNS query builder is tailored to RESTful API access to different data sources, and the normalized function call, as you can see, where underscore that is kind of prefix all the filter functions that we can apply. So either it could be where domains in, where IPs in, where URLs in. It could be something that it's easily to memorize. So you don't have to remember every single different query per functions, per data sources. It can be applied to all different data sources as an abstract layer. And the lastly, the async, execute with a sharding enable as an argument. You can pass that, and the max stays up to 30. So you will chunk it up by 30-day window, and then sending the request. Output is, as you're familiar with, as Ian went over really in detail, that all of the Jupyter data frame functions can be applied here: query, lock, sort values, hide index, all of those. And once you apply that, then the output can be displayed in the Jupyter notebook. We literally copy paste this output into our TI, the knowledge platform, or we can extract the domain, in this case domain, and they extract it out and then feeding into our platform. Next slide, please. So I kind of wanted to share our experience, and I'm sure a lot of TI and IR teams out there looking for better solutions to spend less time on querying, more time doing analysis, right? So there's sort of three main things that we kind of wanted to share, what we're focusing on, which can really help us to drive what is the priority for development effort and where we need to put our resources on. And the first is the intuitive data queries for happier hunting experience. And for our TI team, we had a very wide range of spectrum of the skill sets and the different background, from the very junior that who just graduated high school that wanted to jump into cybersecurity, whereas a senior analyst or a researcher who's been in the industry for a long time and wanted to codify some more advanced data analytics. And how do we do that? And the tool and library needs people support both needs. And we are just trying to focusing on sort of that sort of wide spectrum of these, and then also but to make it easier so that anybody can use it with a very minimal sort of the onboarding process. And the second is abstraction layer of the underlying data, so that it may be data underlying structure may be very complex, but we kind of simplify and then in a normalized language so that people can just use it at their fingertip, don't have to remember a lot of different things. Third is the complex data analysis data set, especially teams with a very wide range of data sources and need to go back a longer time period of time. So tool needs to be able to efficiently load those kind of queues and being able to run it. And if the job fails, then being able to retry. So all of those job tolerance need to be built into the tool, which is very important. So those are the three main things we've been focusing on, and I would think that would be useful sort of tips for other teams out there wants to do something like this. So next slide. So now you kind of wonder, like, okay, so I know Mystic has built the Mystic Pi, and you're kind of showing this Bluehound as the internal tool. So both tools definitely libraries had built by Mystic, and both addresses try to address three central needs for security investigation and hunters. First is acquire and enrich data, and second, analyzing the data and visualizing data. Right, so Bluehound is definitely the only internal to Microsoft, and is ideal for threat hunting and adversary tracking, and built for automation. And it focuses on hunting and querying. And Mystic Pi is open source, so anybody be able to download. There's definitely that good benefit there, and it's ideal for hunting and investigation, especially useful for Azure Sentinel and data visualization. So both Mystic, the Bluehound team and the Mystic Pi team has been working closely, and our plan is to continue to integrate some of the good components of the Bluehound, and that can be integrated into Mystic Pi so that entire Jupyter community can benefit from our hunting tooling development effort. Next slide. I think that concludes my section, and thank you.
Right. Thanks, everyone.
Oh, no, we're sorry.
Sorry,
We're still
Neil.
going.
Still going.
Nathaniel, do you have control?
Let me see.
Yeah.
Yeah, okay. But how do I? Yes, okay. So thank you, Seal. So with Bluehound, Mystic analysts could easily write notebooks for their investigation. So obviously our next step was like, okay, how do we automate and scale it? That's when we built the Mystic Threats Activity Monitoring Platform. So John Lambert present these 4 key layers as the essence of repeatable investigation at scale. We took those key layers and translated them into engineering components. So going bottom up, at first we have pivoting library, which is Bluehound library that Sil presented earlier. For notebooks, we use Jupyter Notebooks that has easy authoring experience and enables straightforward capturing of investigation steps. For automation, we use Papermill, which is a Netflix open source Python library for notebook parameterization. It allows us to create multiple notebooks with same core logic, but with different execution parameters. Those notebooks are then executed on a cloud-based execution environment where they are triggered on scheduled basis. The notebook generate two types of outputs. First, curated signals with different confidence level that don't necessarily drive any concrete analyst action. And the second are alerts suggesting adding new entities to the TI signal store. Those alerts are available to the analyst in their threat tracking UI. So let's take a look of how this platform is observed from an analyst point of view. So analysts record threat indicators in the TI signal store, which is our internal TI knowledge management platform. They also write Jupyter notebooks for scheduled execution, which then in time using continuous deployment are deployed to the scheduled execution environment. Then notebooks are triggered on scheduled basis to utilize those indicators and record signals of threat activity into the curated signals log. Then different set of notebooks utilize those curated signals. They can be from different type and different confidence levels to generate alerts for analyst consideration for adding new indicators into the TI signal store. The analyst then can decide whether or not he wants to accept the alert and add a new indicator into the TI signal store. So if we take a look at this diagram, we can see it forms a loop. The platform was built in a way that it is self-feeding. Indicators added from platform alerts are then being utilized to create new alerts on linked entities, thus constantly expanding the knowledge graph network. It allows the analyst to start with a small seed, and then the platform will do the rest for them and expand their knowledge automatically.
All right, so so I'll just run through as an analyst what the experience kind of looks and feels like to use this platform that Nathaniela described, which again heavily utilizes the Bluehound library, which Sil described. So so as an example, there are a bunch of different ways in which we use the platform, but the primary way in which Nathaniela described is we attempt to codify analytical techniques into Jupyter notebooks, which run and collect signals for us. So as an example, back in 2017, Mark Parsons presented and wrote about an analytical technique regarding tracking TLS certificates. And so, that's available out there on Medium if anybody hasn't seen it. But the notebook on the right is what it would look like, what it has looked like for us to codify this technique into a Jupyter notebook, and which is onboarded to the platform that Nathaniela described to collect this specific type of signal. So in the top, we're using Bluehound to again query a specific data set in an abstracted, scalable way. And then, the notebook is truncated, but there's obviously your standard printing and debugging type of stuff. We're counting things, we're merging with another data set in order to enrich and further filter the results. And at the end of the notebook records one or more signals. And this is an example of what a signal could look like. This one's obviously not real, but you can get a feel for the schema of these. And so in this case, the signal is an edge between two nodes, between a specific certificate and a specific IP address and that edge has unique properties, the most important of which is the timestamp at which that relationship was observed. So again, Notebook runs and records one or more of these as a result, and it's doing that in an ongoing, perpetual way. With that signal flowing, it gives us the opportunity to do a lot of interesting things. We can write queries to abstract and ask complex questions of the signals that are flowing in at any given point in time. And we can also define a set of logic, like Nataniela highlighted. We can define logic which can read the signals as they're coming in and tell us when certain signals represent new information. And it can do that in a very contextualized way, which lends itself well to alerting, and these alerts can be really easily actionable. So I know this is a redacted image and is somewhat kludgy, but you can sort of get the idea that we're able to use an interface where we can these alerts can be presented back to us as analysts, and we're able to easily make decisions based on them, such as creating link, i.e. adding a piece of knowledge to our knowledge store, which, as Nataniela highlighted, further feeds the machine and triggers additional collection. So the benefits of this approach, there's several, and they're all very similar to the benefits of Jupyter as a whole. We have scalability and sustainability. Scalability, again, as Sil highlighted, we're able to query very, very large data sets in very efficient ways without overloading the compute power that we have available to us. It's sustainable as folks go on vacation, investigators take breaks. Like all security teams, crises happen and everybody kind of has to drop everything and respond to certain events. In those instances, part of the beauty of this platform is it is perpetually running regardless of what we're doing at any given point in time. And we found that very beneficial. Secondly, it enables us to codify our analytical expertise. And so in these instances, the entire team is able to benefit from any individual analyst's unique expertise. So as most of us are familiar, there's oftentimes, in any team environment, there's the guy or girl who's really good at this, and then the person who's really good at that. And what we're able to do is when those persons codify that expertise, that analytical expertise, into one of these notebooks and contribute it to the platform, the entire team benefits as a whole rather than just that individual analyst. It also helps us, it's also helping us to grow in performing objective assessments of threats as they're occurring versus being perhaps susceptible to human bias. So in our team, and like many folks can probably relate to us, there's a lot of us have been doing this work for a while, and there's a tendency to, I recognize this from 8 years ago, or this feels similar to something I've seen before, which is both a strength and a weakness. And by taking this approach where we're codifying and taking a data-driven approach to what we're doing here, we're able to add a lot of objectivity to our findings versus just depending on some long-standing expertise, which is obviously valuable, but we need both. And then we're also able to use it to work more effectively in the gray areas. So we spend a lot of time working on events that are gray, where the answer is not clear as far as what exactly occurred. And so this is something where we're realizing that as we grow in our ability to collect weak signals, when we stack and aggregate and group those weak signals together, we're oftentimes able to raise our level of confidence regarding what actually occurred and making a decision on it. So just in conclusion, just wanted to provide a few references to the things that we referenced in our talk. So again, Mystic Pi, that's a great place to get started if your team is spending too much time querying and not enough time performing analysis. we wanted to highlight this blog. Nathaniela mentioned it a little bit, but if you've never read it, the Netflix blog about how they created a platform for their own scenario on which multiple types of users can query and study data in a scheduled way using notebooks. This is a great introduction to that topic. It was written back in 2018, and it still rings fairly true, reading it 3 years later. Paper Mill, Nathaniela mentioned that. That's a great resource for parameterization of notebooks in order to run them in a scheduled way. And then if you don't have a platform upon which you can run scheduled notebooks other than your local device, there's a lot out there. I think every major cloud provider probably offers one, but Jupyter Hub is probably a great place to start if you need somewhere to get started with. So with that, I think we're done. Yeah, we'll stop. And that's the end of our presentation. Thank you.
Great, thanks all. It was a super interesting talk. I really like the way you described the benefits to the team of this, the fact that you effectively have this like expert analyst who never takes a break working away whilst everyone else might have to get kind of pulled off or, take a weekend. So I think that's a really interesting way of looking at the benefits to the team. We've had a few questions in the Discord, so I'll pose a few of them while we've got a few minutes still. One of the questions that came up was about the fact that you kind of present this kind of common higher level query interface to analysts, which is one of the great features, I think, of Bluehound, and definitely one we need to bring into Mystic Pi. But the fact that you're querying across multiple data sets, did you require any standardization model behind it for those data sets? And kind of like, how did you tackle that?
Neil, do you want to answer that one?
Nope.
Yes, so that's a really great question. And I think that that is one of the key main things that we're focusing on, as I kind of covered earlier. And a lot of our time gets spent on that standardization and normalization of the data set, especially specific to fields. Believe it or not, within Microsoft, because a lot of data sets, the owner is not the single unit. So same fields IP could be used in many different ways. You'd be surprised, upper lowercase along with the numbers. And so we are trying to build that normalization as a code on the line so the users don't have to remember those. But normalization definitely is one of the key challenges across when it comes to data science. And we often are trying to put more focus at the beginning as part of the code review. We're trying to enforce that sort of standardization, even though we have very big the community to support Bluehound library within Microsoft. So two key things. One is that strict about the normalization naming schema. Second, the PR process a bit more rigorous when it comes to the bring code in, so that anybody who's actually contributing to code aware of that sort of the standard and protocols.
Yeah, it always amazes me in Microsoft how many ways someone can come up with to write IP address. Seems to be like a unique one each time somehow.
Yeah.
One of the other questions that someone asked was whether you considered using Apache Spark when you kind of kicked off the whole notebook platform process.
Nathaniela, do you or Sil?
Okay. So Apache's, yeah, it was part of the consideration, but first Bluehound wasn't written for Apache Spark. And also, I think Apache Spark is more for large data sets that that require in-house processing rather than querying a small data set as a large data set, but retrieving a small portion with very very specific filters. And then once you have a very specific set in-house, then you kind of work on it. So I'm not sure that we weren't sure that Apache Spark will be the right fit, as well as it would needed to refactor the whole Bluehound package to fit it.
Makes sense, yeah. Particularly when you've got something as like useful as Bluehound already there, you want to kind of make sure that you can leverage it. Cool. One final question for me before we let people have a break is, you talked about how widely this is now adopted and used by not just Mystic, but other teams in Microsoft. But when notebooks started being used and things like Bluehound were being developed, was there kind of a lot of work to convince other analysts to spend the effort to develop these notebooks? Or was it kind of a case of once you just showed them the value, people were kind of got on board pretty quick?
It was both. We had a few champions, and it's similar to, it's exactly what John described in his talk, but a few like early adopters, i.e. champions, who were able to articulate the value of using Jupyter for analysis. And oftentimes that was just like shoulder surfing. I know for me, the first time I ever saw it was over somebody's shoulder. And when they were saying, hey, here's how I figured this thing out, it was just sort of a light bulb moment of wow, yeah, that makes sense. So for some folks, that was it. And then with a couple of early adopters, we were generally able to kind of create a culture where folks were able to realize and benefit and kind of learn how to use it. But it was a process, and it still is. I don't know, Sil, anything you want to add to that?
Yeah, I think that's a really good way to put it, because I think it definitely was a journey, and it's a team culture change in a way. So instead of you explaining how you come to this sort of the assessment based on all the threat huntings that people have done, now you can just give you that sort of the visual representation, codified view in Notebook instead of going through all this. So once people realize the power of it, then they're in. But that initial sort of the PR mode, it took a little bit, 3 to 6 months. And I think, as Neil pointed out, having some people on the team, just for other teams out there who wants to adopt this, that having somebody champion it and showcase it, continue to work with the rest of the team so that it can be part of the toolbox that everybody can use. So
yeah, I think everyone has that notebook light bulb moment at some point, right? Once they get on board. And well, here's hoping some people on the stream are having that with this conference today. But again, thanks so much, all three of you, for coming in, kind of showing us how notebooks can be really kind of used at a pretty impressive scale. I've really enjoyed it. I'm sure everyone else has. There's some great feedback in the Discord. And with that,
stick around for a couple minutes. That would be nice to. I think there is 2 or 3 in the Discord channel.
Yeah. Thanks, Roberto. We're going into a break now for, I think, just a short one till 1/4 the hour. So you've got what, 7 minutes to go grab a coffee before the next session. But yeah, let's keep the conversation going in Discord in the meantime.
Sounds good.
Thank you.
Thanks all.
Thank you, guys.
thank you.
Thank you.
Hey, Roberto, if you haven't gone for a coffee yet.
Hey, what's up? I was finishing my lunch. Lunch dinner.
Yeah, that was the previous break. Yeah, there's a question in Discord about the availability of the recorded stream after the event.
Oh, yeah. So, yes, good question. So oh, sorry, my camera is off and you guys cannot see my plate, so that's great. So the live stream links, they are public links, which means that they are going to be available even under the OTR conferences playlist. So it's not an unlisted link, right? Those links are the ones that only those that get the link can actually access it. So yeah, links are going to be available right after the live stream ends. And what I'm doing also is I'm recording all the sessions. So also, hopefully this year we have more time to split them and then make them all their own video. So yeah, so talks are going to be available after the conference. Yeah.
Thank you.
Yep.
Enjoy your lunch.
Yeah, thank you. Yeah. Oh, so in the previous talk, well, I mean, people can go on break. It's fine. I mean, if you guys want to go too, it's fine. But I was thinking that there is a lot of things that come to my mind when it comes down to trying to run scheduled notebooks, especially working with Azure Functions now and like logic apps. And for me also, I was doing some testing with Airflow. So there is a lot of things that one could use to schedule the execution. And then when someone talked about Spark, so I remember when I was working in AWS before, so we would use glue jobs to write the notebook through whatever interface they had. And so it was a whole integration, right, with glue jobs running Spark jobs. Yeah, glue jobs is technically Spark jobs. And so it was very interesting to see the whole integration as well. And now also like looking at stuff in Azure as well with Synapse, right, notebooks, actually, when you're more familiar with that. So I think that it's very interesting that those integrations are becoming more normal, I guess, for security people to start thinking about, because of the amount of data, right, that we generate, even at the Intel level, right? How much data did they have to go through? It's crazy. So
yeah. I think it's critical as well for like mass adoption of notebooks. I think both Elizabeth and John Lambert earlier on talked about, you don't really want all your SOC analysts to be like picking up notebooks and starting from cell 1 and going through. You want to start already at like cell 7 when all of that kind of stuff has been, and having the ability to like have a notebook triggered.
yeah,
And then you start with already the first 10 queries you would have run is kind of critical. And Pete Bryan has a session tomorrow on automating notebooks using Papermill.
yes, that's awesome. That's awesome. All right, we have 3 minutes, I guess, and yeah, we can just wait, I guess. It's not time to go do something.
Might be. It's a short thing.
Can you guys hear me fine?
Yep. I hear you. How are you doing, Ashwin?
Good.
Good.
Just finished lunch.
Nice.
Hey, is that the Xiao Gui Shu? If I'm pronouncing correctly.
Yes, he's here. There you go. How's it going, man?
Are you on mute?
Oh, it seems that your microphone, maybe you sound a little bit far away from your microphone.
Is it?
Cool.
Kind of. Can you repeat, say a couple of words? So maybe it seems that it comes and goes, the sound.
Okay. I think the Zoom may automatically reduce the sound. Let me see if I can change the setting to fix it.
Yeah, it sounds good. Just a little bit. Sometimes I guess it goes away, but overall, I think it sounds good right now. So, yeah.
How about now? How about now? Could you hear me?
Yeah, right, Ashwin? Can you hear?
Maybe I can get a little bit louder if you want. Does this work?
Yeah, that works.
Hello. Okay.
Sounds good.
Yeah, that's good. Yep.
Okay, so I will use these settings and I will not allow Zoom to automatically adjust the volume. Okay. Hopefully, all you guys have a very wonderful day. I know it will be a long day.
Yeah, no, definitely. But it's time has just been flying, man, with all the great content so far. I mean, it's already 5 p.m. my time, and it's like, well, I don't even feel like it's 5 p.m. right now. That's what I'm eating lunch, thinking it's like 1, 2 p.m. So yeah, it's been great. Yeah.
Yeah.
Hey, sorry, how do you pronounce your name?
Xiao Kui.
Yeah, Xiao Kui. Okay.
I think you pronounce it perfect.
Okay. Yeah, cool.
And nice to meet you, Ashwin.
Hey, same here. Yeah, I think I talked with believe Jason or someone like in the Slack channel. Yeah.
I think you two reach out to Jason, I think, right?
Right. Yeah. Yeah, it's great to have you. Like I watched the talk. So
thank you for the invitation.
Do you have a Twitter handle by any chance?
Nope.
No? Okay. Yeah, because I was looking for you in Twitter and I was like, man, I don't know if this is the Twitter handle, so I didn't want to add something that was not you. Yeah, I could have tagged somebody else and be like, oh, this is.
Xiaokui, can you do anything to boost your mic volume? It's gotten very quiet compared to everybody.
Okay, sure. Let me boost it more. So, hello. Could you hear me better?
That's much better. Yeah.
Okay. Let me know if I need to get it a little bit louder. I can still boost it more if you want. Do we need?
I think this is coming.
Sounds good to me.
Okay. Then maybe I'll just put it at this level. Okay.
So you want to introduce, I guess, Ashwin? I think that we are ready. Yep. So we're good in time, right? Right now. 2 minutes. Yeah. All right. We're good.
All right. Hey, hello everyone. Welcome back from the break. So we have like Xiaokui Xu now to talk about their library, IBM Kestrel. I actually watched the SANS talk where they walk through and then give a demo about the library and then the Jupyter notebooks. So yeah, it was interesting, like with the modular interface and the whole ecosystem around it. So I thought to reach out to a Slack channel, and then it's great to have them here. So I'll let Xiaokui to start with this talk.
Thank you, Ashwin, and it's my pleasure to have to talk to all you guys here. And good afternoon, good evening, and good morning, everyone. And I'm Xiaokui Xu from IBM Research. And today, in the next 30 minutes, we are going to discuss cyber reasoning. And I will demonstrate how can we reason about a cyber attack campaign that we reproduced at our Red Lab. So if you haven't watched our SANS talk, it's online now that you are free to watch it. We also have a RSA talk earlier this year in May that you can watch, so that will get you a little bit better understanding besides what we are going to go through today, which is basically a demo. Yeah. So in a nutshell, cyber reasoning is a step-by-step procedure to find answers to a cyber problem, such as how to detect an APT campaign. And the reason why we need this step-by-step reasoning kind of procedure is because we don't know the attack from the beginning. So we need this procedure to expand what we know until we discover the entire campaign. And some of the main points I'd like to kind of give you a little bit idea before we dive into the reasoning today is 4 points. First, usually we know very little about attacks from the beginning. That's true. Second, usually we discover the attack little by little. That is how humans reason about the unknown. And the third, in each of the reasoning steps that we discover part of the attack, we decide which data we are going to retrieve and which domain knowledge or threat intel we want to apply, and which information we want to extract or visualize, so to help us understand what the next step are going to be. And the final point, the fourth point is we need to compose the entire reasoning procedure from the small reasoning steps so that we can create entire reasoning. Okay, that's a basic idea about the cyber reasoning. You will find that this aligns very well with cyber threat hunting, yes. And cyber reasoning to me is a systematic way of doing cyber threat hunting. And it goes beyond that so that you can apply the idea of cyber reasoning in security software development. When you try to do a new detection model, or you want to try to invent a new intrusion detection system and to involve some of the threat intel in the detection strategy, that you can apply a similar idea here. Today, let's go to the attack we are going to reason. Okay, let me see. Let me share the screen. Okay. Could you see my screen now? Just want to confirm.
Yes.
Okay.
Good.
Perfect. So before we dive into the attack we are going to reason about, I will first give an idea, some background of attack. This is an attack campaign happened in a company called StarX. And StarX is a software development company that's the topology, network topology is shown on the top left. So the company has multiple servers in Cloud P, including its production server, accounting server, backup, and dog food servers. And it has another kind of a network storage service in Cloud S. So this service, this server, the network, the cloud network storage contains the sensitive information, commercial secret of the company. Most of the employees of the company are working from home nowadays, and they connect through VPN to the company. And the company used GitHub Enterprise to manage the source code before it was pushed to the production server through their CI/CD procedure. So they have a CI/CD procedure there. And on the bottom part, left bottom, is what we see about the attack. As I mentioned from the beginning, we know very little about the attack. So we only see all the things we can see. For example, the production server monitored by Sysflow, which is another open source project from IBM Research. And the data from Sysflow is pushed, streamed to Elasticsearch, and which can be queried by StickShifter and Kestrel that we can use. Okay, so the tool we are going to use today to do cyber threat hunting or the cyber reasoning is Kestrel threat hunting language. So Kestrel implements cyber reasoning for threat hunting so that you can write each hunt step as a reasoning step, and you can chain them together as a larger reasoning procedure, or we call it a hunt flow. So you can fork a hunt flow if you want to verify different hypotheses, threat hypotheses. If you can merge hunt flows, if you find there are steps that can be shared for the following hunt steps you want to apply to different branches of the hunt flow. Today, we will try to write different HS hunt steps and try to chain them into hunt flow to step-by-step reason the campaign that's in the company, in the StarX company, okay? And luckily, we have Jupyter notebook here that provides us an interactive way of doing that. So to begin with, we can create a Jupyter kernel, the Jupyter notebook. We call it a hunt book with the Jupyter kernel, with a Kestrel kernel, sorry. And the first warm-up step that we can think about reasoning is a TTP pattern matching. So now we know nothing about attack at all. So for threat hunters, many of them has a very common startup step, that is to search for instances of TTPs that they have in mind across different servers at different time. So that we can try to think about one of the TTP, we can try to search it. In the production server, we know there is a Node.js service there. Is there any exploit of the Node.js service? We can just search that. So we create the first Kestrel variable exploits, and we get process from StickShifter, which is how we reach the data source, and we can go that from Linux server certif run, which is this one, and then we can describe the TTP here shown in the figure. Like we can describe the process, the exploited process, which has a parent process, Node.js, and it has a binary or executable associated with it that is not Node.js. So basically, Node.js is a master process that it will fork a worker process when it handles network traffic. However, if the worker process is exported, it will no longer execute the Node.js executable, but another executable that is not Node.js. And we can search it, give it a time range. We do not want to boil the ocean, of course, so that we don't want to match all the things. So let's just match it the day's data on the production server, all the logs within the day, to see if we get any instances of this TTP pattern that we can get. So Kestrel use entity-based model so that all the Kestrel variables are entities like processes, files, network traffic, users, registry keys, things and so on. And this one, the Kestrel variable exploits returns 5 processes, and we can show them. We can show the exploits, the PIDs of the processes. So those are the 5 processes that we get instances of this TTP matched into the Kestrel variable exploit. Of course, we can show more. Let's do command line and the process names, so that we get an idea that this process with the PID, same PID, first is the Node.js worker process and when forked, and then execute into netcat with the sh. So the netcat specify there is a batch to be executed at the end. So it's maybe finally turned into a batch here. So you can see this is actually the same process, but with multiple execute system calls that Linux has. Okay. This is the first kind of reasoning step we can have when we match all the things on the server. What's the next we can think about to uncover the campaign? So after we get some of the exploits, what activities the attacker did after he comes in, especially he may already get the bash executed, and he may want to execute some of the commands that within the bash. So what we can do is, how about we find child processes of the bash so that we can create a second Kestrel variable, exploratory spawn, that we find processes created by exploits. And remember, exploits is all the exploit processes that we matched here. And then we can display exploits spawn, their PID, name, and the command line to get an idea what activities that the character did when he get in. Okay, so it may take a little bit while. Okay, we get that. And at the beginning, we see a lot of bash, and then we see the real commands. The reason for that is because this is forked from a bash. All the child processes are forked from bash, and then Linux handles this in 2 system calls, a system call fork and system call execute. So that's a little bit annoying that we see so many different processes. How about we only display the ones that's not named as bash? And also we may want to sort all the processes to display them in the canonical order so that we get the idea how the attack happened, what steps the attacker execute, and what's the logic that the attacker want to have. So what we can do is we can create a new Kestrel variable, explore its activities, and we actually put it as a subset of explore spawn that does not have bash in it. And then we sort it by their created time, and then we print out their results that this is created time and this is the command. Now we can see clearly what the attacker did on the server after he's exploited. So he did some of the reconnaissance, like get all the usernames and versions of the operating system, and test the network, and maybe download some of the payloads as a prop. And then this may do some further reconnaissance around the network, and then download something called a test. This may try to gather information what he can do about the attack. And after several rounds of this test, he finally downloads something called a program tweet. So this is looks like a payload that's really did something bad, because after he download and execute and remove it from the server, the attack ends. So it looks like this is the final step after he get all the information, attacker get all the information about the servers, and he did this as a final attack step. Okay, now after these 3 simple reasoning steps, TTP pattern matching, find these connected entities, and then to list the entity in the way that for us to understand them, we know that we uncover part of the attack compound, that there is a CNC channel, and but what else the attacker did? For example, what a tweet does. So this is something that the name reminds us, maybe this is something related to Twitter, right? Can we drill down more just on the tweet process that the attacker did as a final step? Sure. We can do something like create a Castro variable tweet, and from all the activities, and we only get the ones with the name tweet. And then we find network traffic that's created by all the tweet processes, and then display the network traffic to see whether the attacker did something that connect to the network, or maybe even reach out to Twitter, since the name of the process indicates this, maybe something related to Twitter. Okay, let's wait for a second for it to complete. And now we see those are the source IP, source port, destination IP, and the ports connecting to DNS, HTTP, and DPS. Okay. So now, until now, we are still retrieving data from the data lake, the Elasticsearch that we are using. That contains all the data of the logs of the production server recorded by Sysflow. However, as I mentioned, for any reasoning step, we may want to apply some domain knowledge. We may want to do some visualization about this to get us better understand what's happening. So for IP addresses, a popular next reasoning step that comes to a lot of people's mind is, can we find their geolocations and pin them on a map for us to better understand them? Yeah, but this cannot be done by a pattern matching, right? This should be done by something else. So in Castro threat hunting language, we have a hunt step or reasoning step that can help us do that. It's called analytics. So analytics in Castro is a foreign language interface that allow you to execute any logic in your foreign language, like C++, Java, other than Python or Python. And we can do that simply wrap it into a Docker container and make sure that it aligns with the input and output rules of Castro, basically takes in Castro variables and output Castro variable. That's a very basic requirement. And then we want to run that in the Castro variable tweet NT. That's a Twitter network traffic, and see what happened. So this is an analytics step, reasoning step that we open source at our Castro Antics repo. There are many more you can explore there. And this one will find the geolocations of IP addresses and then pin them on a map. And thanks to the powerful Jupyter environment, it's very easy for us to do so. And we can find that all the IP addresses are coming from US and Canada. Okay, that's not very useful for us to find something that's, we like to find something surprising, but actually not. Okay, this is not very useful reasoning step, and let's try something else. So the next thing that we can think about when we are given these IP addresses is, can we find their domain names and their domain organizations for us to better understand, for example, whether they are coming from Twitter or not. So the second analytics step we're going to have here is to enrich all the IP addresses with their domain name and domain organization. And then the enriched result will be given in the additional attributes of the entity tweet NT, so that we can show tweet NT now with 2 additional attributes. That this is also available at Castro Antics repo that you can download, and they'll use whoislookup to do the enrichment. Okay, so as you can see, actually there's an IP address that's going into Twitter. So that's maybe explains why the attacker named the process as tweet. And also you can see that there is the IP address Cloudflare, that is Cloud S actually, that goes into the sensitive data storage the company has. Could this be a data exfiltration? The attacker tried to exfiltrate data from the sensitive data storage through Twitter to something else? That could be possible. And we can further reason about this threat hypothesis and maybe apply some machine learning analytics that you can download from here as well to confirm whether this is data exfiltration, and you can further drill down to the network traffic to get some more information. Of course, you can do that. But now I'm more interested in another direction that we may want to reason about. So up to now, we only think about the impact of the attack once the server is exploited. We know that there are activities that attacker did, there are maybe data exfiltration at the end of it. But why this happened? You may simply think this just happened because the attacker penetrated into the server, but where the vulnerability come from? Is it because the vulnerability is introduced by a software developer by mistake, or he didn't know that, or if this is a supply chain attack? That's possible, right? So we want to get an idea why this vulnerability is there, and we can reason about this. So the first thing we can do is ask our penetration testing to give us some clues about what the vulnerability is. So that's a good thing is the pen test team get us back pretty quick, and they found a very obvious vulnerability in the production server. This is the library in the Node.js application called NoSerialize at version 004, and there is an arbitrary code execution vulnerability in the library. That is a very obvious thing that they found that can be used by a lot of attackers. Since the company is using GitHub to manage the code, can we simply go to GitHub to find the version of the library and to attribute which developer put this vulnerable version in it? That's very obvious. That's very straightforward, I would say, about the next reasoning steps, right? Surprisingly, when we check the configuration file in the GitHub server, we find the configuration file of the dependent library NoSerialize is latest. That is not the 004 version, which is vulnerable. Okay, this is a little bit surprising, which means actually the attacker has some other channels into the production server other than using the CI/CD channel, or maybe it rule out that a developer carelessly introduced the vulnerable version. And by the way, nowadays GitHub is pretty advanced. And if a developer or the attacker try to do a supply chain attack and introduce the vulnerable version like this, GitHub will warn all the developers. So maybe the attacker knows GitHub has this advanced feature and don't want to make everyone know that he introduces the vulnerable version, so that he did something else to make it happen. Okay, so let's summarize what we see. We see a vulnerable version of a dependent library, NoSerialize 004 in the production server. But when we check the GitHub, the source code of the application, we don't see that vulnerable version in the source code. Okay, that's interesting. That means the attacker did some very stealthy attacks that he used some other channels to go into the production server and then do the attack. Can we reason about what happened? Yeah. So we know that the version of the vulnerable service is in the file called package.json, which is the configuration file of most Node.js services. And then we can find all the package.json file in the production server on that day. And then maybe further, we can check which process read and write the file so that we get an idea how this file has been compromised other than it was pulled from GitHub. Okay. So we get back about 3,000 lines of logs about all the about a file that may contain some activity of the file, maybe something else. Okay, so that's configure file. this Castro variable contains this almost 3,000 line of logs about the files, and with only one entity, which is a file. This is a little bit a lot. So let's see if we can further refine the results. That we can first show which attributes we have for the Castro variable configuration file. We have these attributes we can go, and one of them is the directory of the configuration file. So that how about we display the configuration files with the directory information? Oh, actually we have the same file name, but in a lot of directories, as you can see here, there are lots of directories that has the same package.json file name. And the one that we are interested is actually the one in the source code. This is the source code about the application. Since this is the Black Hat demo that we did a month ago, this directory that I created. So how about we only get all the files, the package.json file from this directory as a refinement reasoning step before we try to reason about which processes touch a file. Okay, that's something that we can use a simple pattern matching step to do that. So basically, we just create a new Castro variable, project conf, as a subset of configuration files, which satisfy the path that equals to this directory. Okay. Hopefully we get, we get a lot of less. We get only 10 times less line of logs that's associated with the file. And then the exciting moment that the next reasoning step that we want to do it for a long time is to find which process touch the file. Read the file, write the file, that we can see that how this file is manipulated and compromised by something. Okay, so basically we create a Castro variable that contains all the process that touched the file that is listed here. And then we sort all the processes by their creation time so that we can check the result chronically so that we understand how the attack happens if the file is compromised by someone at some point. It's a little bit slow because there are a lot of files. I think there are thousands of records that the Castro needs to check, and there are multiple queries that Castro issues at the backend to the Elasticsearch. Okay, so we see a lot of CI/CD periodic running that touch the file, which is normal. So this lists all the processes that touch the file. The configuration file in the directory that we are interested in. So a lot of CI/CD procedure, which is normal, they run periodically to check it. Oh, this is SCP. This shouldn't happen, right? This looks like very suspicious activity here. Can we drill down about the SCP activity here? Yeah, that's for sure we can. So how about we just get all the SCP processes? I think only 2 of them. SAC or SCP process here, and then get its parent process, which is the master process that handles all the network traffic, and then to find out who is connecting with the SCP command, where it is connecting from. We need to know the origin of the attack. Okay, so we can see that when we find the network traffic of the SCP, it points out to employee's laptop 141. Looks like an insider attack, right? Or maybe the Windows laptop is also compromised. We don't know. But we know what we know is this is a very good clue we don't want to break. So can we go across the network from the Cloud P into the Windows laptop of the employee? Sure, because we also have Sysmon here that provide us information that Castro can query. Then luckily, we also have another Elasticsearch server that contains the logs from Sysmon that we can query. So let's do that. Okay. What we can do is this time we query the Windows laptop 141, which Sysmon is running there, and we want to get network traffic from the Windows laptop that is the second half of the narrow traffic. The first half of the narrow traffic is from the server side, and this is narrow traffic from the Windows laptop perspective, the same narrow traffic actually. And we specify the source port so that we know that this is the same narrow traffic, but from the Windows perspective. And the Kestrel will kind of make a concrete query. This is not the final query we issue to Elasticsearch, of course. So Kestrel will derive the time range for the query so that it will uniquely identify the narrow traffic. So do not worry that we get false positive here. So we see this is a source information which is correct, but the destination information is not that matched well, maybe because this is the container in the cloud. So can we check whether this is really the laptop that we are, the narrow traffic we are looking at? We want to check more? Sure. So what we can do for the next reasoning step or hunt step is we can get the process that creates this narrow traffic on the Windows machine to see the command line. So the command line is here, which match perfectly to what we concern as here. So, okay, now we confirmed this is actually the attack that is happening on the Windows laptop that do the SCP into the production server. That's SCP, the compromised configuration file. Okay, and what's next we can think about? So is this because this is the insider threat, or this is because this is maybe a compromised laptop? How do we find it out? We can find it out by working the process tree on the Windows laptop, the process tree that contains SSH, that calls SSH, so that we can, this is SSH, process A. We can find the parent process, which creates process A. We can find the grandparent process, which creates process B, and the grandparents, so that we get an idea about how this happens. The SCP process creates this SSH process, which is reasonable. And then the cmd.exe creates SCP. So this looks something suspicious. And then the cmd was created or forked from wemail.exe. Okay, this is the email client that the StarX employees use as their email client. Okay, now the threat hypothesis is shaped more into, this may not be an insider threat. This may be something that the Windows laptop is compromised through maybe a phishing email or something. Do we see more reconnaissance or other type of operations that the attacker did on the Windows machine? Yeah, we can maybe check all the child processes of cmd.exe so that we can get a better idea what the attacker did besides SCP, the malicious or the compromised file. So that's basically we have perc as the cmd.exe, and then we can find all the processes created by perc, which are child processes. So note here, this is created by, which means parent process and child process of something. That we can show them the results. You can see there is a lot of reconnaissance step on the Windows machine, followed by a PowerShell that replaces the version of no serialized with a vulnerable version before it is pushed to the vulnerable server, to a production server. Okay. Wow. Okay. Now we have a nearly complete understanding of the attack as shown here. Okay. So okay, and at the end of the reasoning or the hunt, let's just draw the entire picture of it, and we can move it away so we can see the entire picture of the reasoning. We can save the handbook and we can share the handbook with our colleagues to run that. We can use part of the handbook in another hunt if we want. And if we want to know how to install Kestrel, just search Kestrel language, and then you will go to the main repository of Kestrel, and then you will get all the information about, for example, the blogs about the Antics repositories and any other demos about it. Okay. Thank you for watching, and any questions?
Hey, yeah, thank you for covering. I think we have a few questions, but we are just at time. Are you going to be in Discord for a while, like, to answer like a couple of questions?
Yeah. Yeah, I will be answering the question on Discord as well, but I can answer questions here now. Yeah.
Okay, so maybe we can take like a quick couple of questions. So I think so from the demo that we realized that the handbook requires like a separate kernel, right, and then the Kestrel language. Is there a way like to take output from the query and then use it as a data frame, or like use with the Python tools and all those things?
Very good question, and we can. So let me show you basic, very simple thing that you can do. Let me share screen again. And so if you go to documentation, there is a runtime API of Kestrel. And there is a Kestrel session so that you can invoke Kestrel session directly in Python very easily. If you have a handful written in text and you can get that, this is something like a pandas data frame you can get after you execute the Kestrel session. So we have 3 ways of running Kestrel. The first way is, let me see. So here, I think here we have the figure here. So the first way is a Jupyter notebook, which I showed today. You can run it through command line. You can run it through Python API as well. Yeah.
Okay. Maybe we can take like one more. So I think from the documentation, I read more about like stick shifter, and then it has like multiple connector supports. Could you talk more about like from the demo that I saw, like you connected to host primarily, right? How does it works like connecting to other data sources and like maybe like a SIM provider, that sort of things?
Yeah, sure. So Kestrel utilizes stick shifter to connect to multiple data sources, and also stick shifter provides a standardized data model so that we can use easily. So that it will normalize, stick shifter will normalize all the logs so that we do not need to worry from the Kestrel perspective. And to get more ideas about stick shifter and Kestrel, you can go to the thread hunting tutorial. There is a section called, let me see, counting on real world data. So here is a section that will guide you how to set up stick shifter, for example, from Elasticsearch, Carbon Black, and other data sources. And what you need to do is simply put some of the environment variables so that that will tell stick shifter how to connect. And besides this documentation, if you go to our blogs, so currently we have 4 different blogs that gives the basic ideas about how to set up Kestrel, for example, for a sysmon data source, and there is a details how to set it up. And we also have how to set up Kestrel for our kind of a sysflow data source. And this is the stack that we use in our Black Hat demo that you can further read about how to set it up. Yep.
Awesome. Yeah, I think there are a lot of resources to go through and then learn more about it. Yeah, maybe I think there are like a couple of questions related to like how does it work with the large data sets, and is there a limit on the results that you retrieve? Maybe you can answer in this Discord.
Sure. Yeah.
All right. Hey, yeah, thank you very much. I think this was really informative. There are like a lot of new resources, at least for me, to learn more about like the library and then language and all the ecosystem. So thank you.
Yeah, amazing presentation. Thank you, Xiaokui.
Thank you.
Well, so next we have, let me use the Spanish version of your name, Luis Francisco Monge, right? He's gonna share with us incident response notebooks, right? Log analysis. Luis Francisco is a digital forensics and incident handler at Telefónica, right? So I'll let you, Francisco, to introduce yourself and share what you have for us today.
Thanks, Jose. I don't like to much speak about myself. I think this is enough. I'm doing in my daily job incident response for medium and big size companies. And I will talk about how notebooks can automatize daily tasks that are sometimes annoying or maybe difficult. And one of them is the log analysis. In incident response, is very common to have gigabytes of data. And it's very common that each client has a different format or different brands in his infrastructure. And in my experience, notebooks can help you a lot in your daily incidents. In this case, I will talk about firewall logs because, in my opinion, is maybe the most valuable source of logs, because it's easy to find exfiltrations paths or command and controls connections in those logs. And let me share with you, it's a notebook, like a personal notebook to do these tasks. And in this case, I will talk about Fortinet logs. Is maybe the most, or one of the most common firewalls that you find in the companies. And the log format is not very useful and not very comfortable to work with. For example, I can share with you, this is a sample log. You have a key and the value separated with equal symbol, and it's sometimes are quoted and sometimes not. It's very annoying. But before go, let me a second. Okay. Before go with the analysis, it's important to explain the three biggest problems when you're working with logs. Are one, it's the log format. It's the log formats, and this is one example, but there are a lot of samples that doesn't have a CSV-like format, and it's very difficult. The second big problem is when you are working in a big company incident, the quantity of data. The quantity of data is common to find gigabytes or maybe 1 terabyte of logs, and it's a very big problem. And the third problem is that you need to analyze it fast, because you need to know where is the command and control, or how the exfiltration was done. In this part, I think it's better to start with the notebook. The code is in this section, you know, but I create some menus. In this part, you have to select the input folder where the files are located, and you have to select the format, and you execute the button. And it's very common also to have dozens of log files. And I did it with multiprocessing, but it's in Python is not a problem, but in Jupyter it's a problem to execute multiprocessing, because there are an issue. And a little trick is to create a file with the functions that you want to execute with multiprocessing. And in this example, the key of the process is maybe this regex. This regex extract for each line the key and the value, and after that you can separate the header and the values in the CSV format. Okay, this function create a new CSV file for each log file. And it's a big problem when you are working with key value log files, is that it's common the result files, the CSV result files, it doesn't have the same number of columns between them. And it's a problem when you want to work with Pandas or Python. And I used this library that analyzes the CSV files and creates new files with the same columns, and it's very, very useful. First of all, I forgot to explain that this part is a little bit slow. I don't show it because you need a few minutes to parser. This database is 400,000 logs, and maybe it's necessary 4 or 5 minutes to convert it to CSV, and I have those logs parsed. The third part, when you have appropriate CSV files, is filter data. Because when you have millions of logs, it's not possible. It's better when you have a log in this log. It's very common that there are a lot of columns, and a lot of them are not so useful. And it's nice to filter this data. In this menu, you have to select where you have logs, and create three windows. And you can select the columns that you want to work with. In this case, I will select action, destination country, destination IP, source IP, source country, service, and time. And the number columns, for example, is duration, received bytes, packets, and bytes and packets, and data format with date. All of these windows are done with Jupyter widgets, and it's very useful. For example, when I share this notebook with some workmates, it's easier to work with this notebook without have to deal with a lot of code that sometimes is annoying or maybe difficult. When you select the columns, if you see it was done fastly, and this is because it's not a real data frame where the result is kept. It's a task data frame. If you don't know, this library is a very powerful library that allows you to work with data in disk. When you work with a big quantity of data, you can't use pandas because you don't have enough memory. For example, you have 200 gigabytes of logs. It's impossible to work with pandas without have mixed functions. And the other possibility is to keep this data in the database, but it's slower than work with Dask in my experience. And when you need to have results in minutes or maybe in a few hours, Dask is a very good solution. For example, you can see here that the types that we selected in this part, it's good because Dask works faster when you select the type of each column. And for example, you will see that when you do a heat for a Dask data frame, it's slower, but it's also good. For me, it's good enough, and it's fine. You can see here that maybe less than 3 seconds to do a len for 400,000 data frame. That pandas is quite faster. The next part that is necessary is to filter in data. We have data filtered from columns, but it's also necessary to perform a filter about values of each column. In this part, to example, I will select those columns. And this function will be, each columns will be summarized, and you can select which of those values you want to exclude. This is very useful a lot of times because in those logs you have a lot of deny connections or timeouts. In this case, it's also useful when you're searching for command and control connections or exfiltration. You have reserved in the destination country. That means that the destination IP address is a private IP address, and you can exclude these results. In this example, I will select those. And you can filter it. After that, we will have less values. This is just an example because here are 400,000 logs, and it's for maybe 5 or 6 hours, I think. And in the real case, you will have millions of logs, and have more sense when you filter data. You see the results are reduced in better. And the last part is the biggest part also, is the data analysis. This is important, of course, because it's where you have the results. And I have here two kinds of analysis. One of them is Maltrails EOSys. Maltrails is a project. It's a public project that have a lot of open source for EOSys, and you can create easily a report or a list of EOSys. I have one here. I am sorry. This is an example. It's more than 400,000 EOSys. And one of them are very interested. I don't know. For example, in this list, you have Tor nodes, generic malware, and it's not very sophisticated. But in my experience, a lot of times you have a first result from this kind of list, and you can find maybe connections from a Tor node or connections to a IP address that has the label for generic malware, and sometimes it's a Cobalt Strike command and control. It's not very sophisticated, but it's very useful in a lot of cases. In this case, we have 300,000 logs and 400,000 EOSys, and it's quite fast because you have to select which columns you want to search for. And when you realize it, all the EOSys is kept in a set structure in Python, and is fast to search in this structure. And I don't know, it's in 17 seconds you have the result in a data frame, pandas data frame, and you can search. This is the log filtered, and you can search for a source IP address hit or destination IP address hit. And while this doesn't have too much sense, because this IP address was changed for anonymize the logs, and maybe it's not so trustable, but like an example is fine. You can also create geolocate the IP address. When you select the IP address that you want to search for, you can select those options, and using the maximize databases, another column. In this case, is not useful because those logs are geolocated, but in some cases, it's very useful for search for connection from suspicious countries or countries that the company are not used to receive these connections. And another analysis is the graph analysis. I like this analysis because it's necessary to select the source IP and the destination IP address, because in each logs the column names change, and it's better to select it. And in this case, the code are working doing something like modeling data. The result is DF model, and in this part, the head of it is, this is the result. The result is each destination, the unique destination IP address with some mathematics results. For example, the number of connections, numbers of unique source IP address, the duration sum, minimum, maximum, mean, variance, and mode. And this creates something like a model, something like a profile for each IP. And in my experience, it's very useful because we will see it in the next part better. This part, when you have this model or this profile, is useful for search using graphs. In one of the examples is when you search for connections and a number of source IPs, see it in a graph. You can filter also the data, because I had problems when I have a big quantity of data. Maybe you have 200,000 unique destination IP address. And when you try to draw a graph with 200,000 points, maybe it's a problem. And for this, I create these filters that you can filter the highest 1,000 IP address with more connections. When you generate a graph, this filter is useful, for example, searching for Cobalt Strike command controls. You can see in this part, you have IP address with was connected from a lot of IP address. It's not suspicious at all. The more suspicious is the opposite, is this line. In this line, you can see IP address that was connected just for 1, 2, or 3 source IP address and has a lot of connections. And this is maybe more suspicious. Another useful search is, for example, a summatory of sent bytes between a number of connections. This is useful because you can search here for exfiltration. When you have this part of the graph is, for example, to be honest, I've never seen exfiltration about DNS or in the real life, but it will be in this part because a lot of connections and a lot of data sent, but it's more common to see to this kind of connections. Just one connection that sent 2 gigabytes of data. When you search for these IPs in a real incident, you can see a mega IP address or drive or this kind of services that was used for exfiltration. And the last sample is also interesting. Is duration zoom between a number of connections. This is also useful searching for TeamViewer or any desk connections. You see in this part just 2 connections, and the duration for both connections is more than 1 million seconds, and this is very suspicious. There are a lot of possibilities because you have a lot of fields to search for, and it's fun to searching and trying to view some patterns. I like this part. I think okay. This part is the results, and the last part is for. I was playing, to be honest, with PCA. PCA is maybe the most simple function in machine learning, and it's very useful. For example, when you have something like this, you have 33 columns. You have to select 2 or 3 to draw a graph. And PCA allows you to reduce these dimensions just for 2, for example, that I was doing this part. And the result is something like this. You can create only 2 values, and it's easy to generate a graph with it. So you can search, you can see fast that there are some points separated to the rest, and it's a good point to start researching when you don't have any other clue to research. In this example, I will select the first one. The first one is that you can see that there are not so much connections. And was connected only from 2 IP address. I like to try to create. I'm trying to create like a profile for call strike connections, and this is one example. You can see how the duration minimum is just 1 second. And the maximum is a very big connection, and it's the same with the packets, the bytes sent. I'm sorry, duration mode. Well, you can see that the mode is also the minimum, and this is because a lot of the majority of the connections are beacons. It's not a real connection, it's just a beacon that are connected to the command and control. And it's the same when you are searching for receiving packets or send packets. And for example, I saw that all call strike that I was searching, the minimum packets is 8, and the received packets are 9. It's quite interesting. And when you search for those connections in the Dask data frame, you can see that the connections was done between 30 seconds, more or less, with a small jitter, I think. And you can see that this is very suspicious, and this is a call strike command and control, and the computers was infected to it. And to finish, you can see that the directions, you can see in this graph that in these points, the attacker was interacting with those machines. And it's a good point to search also in the machines, in the event logs for those moments. And that's all. Thanks for watching. I hope that this is really interesting.
So well, we actually have some people asking for how can they have access to your notebook. So yeah, please let us know whenever we can share that notebook with
yes,
people that
I can share this copy link because I uploaded it to my GitHub, and also is available the data set and the maximum databases, and you can do all these functions easily.
Awesome. Yeah, thank you. Yeah, Luis Francisco just share the link through Discord, so all the people that were asking for a notebook, they have access there. Thank you very much for that presentation. Really interesting topic, and really good example of how can we start applying data analysis techniques using pandas, and also complementing that with other libraries, right? Especially the use of widgets. I really like how you use widgets to simplify the filtering and selecting operations, right? Which is sometimes is kind of difficult when using any type of library, not only pandas.
Yes, it's not like that the technical people don't want or don't like create something like widgets. I prefer to create functions or algorithms, but not widgets or graphs also.
Yeah, no, actually, I would say like in most of our talks today, we have seen the application of widgets. So I think that's something that I need to start learning how to use those. Share that with other people from the community. Well, thank you, Luis Francisco, again.
Thank you for the opportunity.
Stay with us in Discord if someone has another question about all the techniques that you just shared with us. Thank you very much again for your presentation.
Thank you. Bye.
Well, we have, I think, a break, right, Roberto? Yeah, we have a break until, what is the 3:40 PST time and 6:40 in Eastern time, right? Are we good with that? Okay, we will be back at 6:40 Eastern time at 3:40 PST time. See you guys later. We'll be back with Ian introducing Neil, I think, is our next presenter. See you guys at 6:20 and 3:20.
Hey, so welcome back, everyone. Before I introduce the next session, I just wanted to point out that we do have something we meant to publicize a little bit more widely, but we would like the community that's got together around here around notebooks and InfoSec to kind of stay together if possible. So we have set up a channel in the Discord in the Open Threat Research under OTR initiatives called Jupyter. We'll try and make sure that we post a link to the invite on the Jupyterthon website. But if people are interested in kind of carrying on in a more connected way than perhaps in Twitter, after this, kind of discussing, sharing ideas, tools, whatever, we'd certainly love people to join that. Anyway, back on schedule. So delighted to have Neil Desai here with us. He's a principal security architect at Elastic. We've heard several references to Elastic so far, so it's kind of cool to have somebody from the place itself. One of the things, Neil's had a lot of experience in architecting, building SOCs, and is one of the elite group of people who've won Capture the Flag at DEF CON, not just once, but twice. So a legend indeed. Okay, with that, I will hand over to Neil.
Hey, thank you for that, Neil. Let me go ahead and share my screen here. Full screen. All right, here we go. So what we're going to be talking about today is Windows Analytics. And so if you're used to Elastic, this is probably the interface you're used to seeing, which is Kibana. And the only reason I'm showing this before we go into our notebook is so that we all understand exactly the lab environment we're dealing with, the events and things of that nature. So you can see I'm looking at, about a year's worth of data. It's a lab, so there's not a ton in here. And I have about 44, 45 million events in here, right? And so when we're looking at that, one of the things I wanted to find out is how do I know what my event, my audit policy is set to? Because often when I run into customers, they'll say things like, hey, I've got Windows logging. And I'm like, well, great. What exactly does that mean? And so a lot of times I'm seeing that there's a big disconnect between the SOC and the engineers or whoever is building the policy. So I thought about what can we do? Can we kind of go backwards here, right? Can we start out with the events that we have, look at that over a long enough period of time, and then from there derive what we believe an audit policy would be. So with that, let's go ahead and do my notebook. So I definitely learned a lot about notebooks watching other people, so I have a lot of work to do here, but this is what I have right now. So here I'm just loading up a little helper script that I've written, and I'll show you the contents of that. And then I'm just auto reloading it because as I write things in my Python notebook and I like the content and everything else there, I move it over into this here. That's how I end up with all of these various functions that are doing more of the detailed work for me there. But making it very easy. So using the cloud environment, I'm just using the cloud ID here. And then I'm entering the credentials. One of the things I loved about, we talked in some of this Discord there about different modules is the get pass module, because this way I'm not having my credentials stored in a Python notebook that anyone can get. It will ask me for my password and it'll pop up a little place here for me to enter in my password. And then I'll go ahead and connect in. Once I've connected in, I've set some global variables here. There's better ways to do it. I've heard from other people. I haven't found one that I like a lot that really works for me. So this is kind of how I'm doing it. So I've got, again, that start time, which we saw here in 2020, the end time here a little over a year later in 2021. And we're going to specifically look at Windows logs here. And this is something that is, yes, sir.
Sorry, can I just interrupt you? Could you zoom into your text a little bit so it's a bit more visible to folks at home that don't have massive monitors? So just like Control Plus probably will be its code.
It's not doing that. I tried that earlier. Oh, there we go.
Yeah.
It just takes a little bit.
Interesting delay.
Yeah.
Zoomed in 15 times before you know.
Exactly. So, all right. So I'm not going to touch zoom. If it zooms out one more time, we'll know. All right. So here I have my, I'll start over just so we can see it better, right? So I'm just doing a reload of what I have in this script because I do all my development in this script here. And so I'm just saying reload it every 2 seconds and then auto save my work every 30 seconds. And then here's where I'm kind of importing everything. And this is the get pass, which allows me to enter in my password so I don't have to save it in the script itself. Have the cloud ID right here, which we enter in to connect to the Elastic Cloud instance here. And here's where I get to enter in my credentials. Again, that way I don't store it anywhere, no one can steal it. And then a simple connect ES, right? So this is a function that I built. And again, I'll be sharing this script out later so that you could use this and just make it very easy for you to connect to a cloud instance. So from there, I've set up these variables. And again, there's other ways to pass this information along. I didn't find ways that I like, so I'm just doing it this kind of hacky way here. But we've got the start date, the end date, and the data that I'm looking at. And then I'm setting up a filter here. So with Elasticsearch, if you run a query, it's a little bit different than writing a filter. A filter is just a yes or no answer of does this exist or does this not. The neat thing about filters is they will generally be faster than a query, especially when you're doing it at scale. And filters are cacheable, the results are. So especially in a SOC environment where people are going to be asking the same question or similar questions over and over and over, you can take advantage of that to increase the speed even more. So when I look at data, the first thing I want to think of is I don't want to make any assumptions about the data that I'm looking at. I want to take a fresh set of eyes to look at the data to really get a feel of what is in the data and answer the questions with the definitive, yes, that type of data exists or that data doesn't exist. So I created a little function helper here that is the first search, great name for a function, that goes and runs some logic underneath, and I can share that later here. And essentially the output of that is going to be a list of two things. So the first is going to be a pandas data frame that tells me what are all the event providers that I have in my logs, again, across all 44, 45 million events. This is what you can see. These are all the various event providers. We also talked somewhat in some of the other channels there on Discord where something I've seen is a lot of people will ask questions of Elastic, and what they ask is, hey, can you give me a million lines of, or a million events, and then I will do all my analytics afterwards. If you think about it, I asked questions a little over a year's worth of data, about 44, 45 million events, and my results came back in 0.2 seconds because I asked a question to Elasticsearch, allowed it to answer, and then only provide me the answer. I'm not saying, hey, go give me all 45 million events and then let me crunch through it myself. So this is the first part. And then the second part of that list is a little Python dictionary that gives me similar information. But here the difference is it's giving me a count, right? So I can see from my security auditing events, I have a majority of my events come from there. Then I have PowerShell events, Sysmon events, so on and so forth. And so this is giving me a high level idea of what type of data am I actually collecting in my environment today. Again, I'm trying to be honest about what I see here. I'm trying to go not make any assumptions about what I thought was in there, just taking at face value. So from there, right, I can look more into it. So if I look at this first event, which is a list, and I'm saying look at the second item in the list. Remember, Python is zero-based indexing. So even though I'm specifying the number 1, it's really the second item in the list. And I'm looking at the event provider here. It's giving me the same information. However, it's only looking at this top piece of information right here. You can see that I've got an event provider dictionary in there, and I've also got an event module dictionary in there. And so here I'm looking at the event provider information specifically, looking at those numbers. And here, if I want, I can change to the event module and then look at those numbers specifically for there. If I want to do a high level aggregation of things, if I want to say, hey, can you tell me the unique usernames and the count of things that you see for that username? I'm setting up a little list right here where I'm saying, hey, I want to do this on the username field. And I've created the sample aggregations, which does all the dirty work underneath. And again, it's going to give me back 2 things in this data. It's going to give me a pandas data frame, and it's also going to give me a list of counts of things. So when I run this, again, 45 million events, it only took 1.7 seconds to run an aggregation of the username field. And so when I look at that, I can see that these are the various usernames that are in my environment. And I can see the count of how many events are related to each username. So it makes it very nice just to get a feel of exactly what we're seeing in there, what type of data is available, and things there. And let's look at some of the logic underneath here. So before I get onto the last part, which is I guess the coolest part there. So the highest part here is just the basic connecting to the cloud and giving you that connection back. From there, we're doing things. So our first search here, there's a couple of things I want to take advantage of. So one thing that we've done at Elastic is we've come out with a naming convention called the Elastic Common Schema. And the things I really want to pull out of there are the event module, the event data set, and the event provider, because this is going to give me a high level information of what type of data am I looking at. And while it doesn't make as much difference here when we know we're looking specifically at Windows operating system logs, if I were to run this on like Microsoft 365 logs, I could see things like Teams logs, Office 365, OneDrive, all the various different products that are a part of the Office 3 or Microsoft 365 data set, Azure and things like that as well. And so here I'm kind of cheating. So I've created this set of fields that I want to pull out, and then I'm going to the sample aggregations. So in the sample aggregations, we're trying to take some of the pain away of having to know a lower level query functionality. And so here I've created a template of what I will look like. So I'm going through, and for each one of these items here, I'm creating a little template that will get added to a larger query. And then I'm looking to see is what was passed an actual data frame or a list. And based on that, I'm going to get all the columns, or I'm just going to go ahead and create a list of what I have from the list that I was given. And then this is the part where it actually creates the final query here, template. And then here it substitutes out information, and the start time and end time that we kind of passed as global variables are passed here. So it'll run, and then it returns our data down here, which is the data frame and a dictionary of information that has the list. And so this is a kind of a powerful little function that I've made here for sample aggregation. So you get a lot of information very quickly. Again, I'm asking Elasticsearch to do all the work for me, so I don't have to do it myself here, including writing documentation. So I have this one here where it'll take my pinned as data frame and it just writes it to an HTML file, which is very nice and neat. So that way I don't have to sit there and go, oh, that data frame looks good. How do I get it? What do I do? Makes it very easy here. I can also have it automatically build a data frame for me if I give it some type of data. Data frames, as you've seen here, are very, very useful. It takes a little bit of time to kind of get used to them and understand them, but they're very powerful in being able to build a data set with data frames, be able to ask more questions and things like that. But again, the data frames I'm building are not necessarily from raw data. I'm actually bringing in high level information and putting it together there. So with that, what do I want to start with? So if I look at Windows events, so we know we can get the event codes from an event, which is great. And then later I saw this post from Ben 10 over at TrustedSec, and he had given a really neat Excel spreadsheet right here that has all of the event IDs in it. And it tells you what part of the category, what's the setting, the message description, everything. And this thing is fairly exhaustive here. I can't say that it has everything, but I haven't found anything yet that it really didn't have. And so we've got roughly, we've got 415-ish event IDs here. And so what I want to do is take this information here and then essentially just map to say, okay, based on all the event IDs that you have in your system today, can I take that and then go and map it against the spreadsheet here and then output what I believe your audit policy would be. Some things we need to take into consideration, right? This is going to be close to accurate, but it's not going to be 100% because there's some things we need to consider. First thing is the audit policy can be different based on the GPO assigned to the OU. So that can definitely have a impact on what gets logged or what doesn't get logged or anything along those lines. The length of time that we're looking might not be enough. So if we just look at a 24-hour period or a couple of hour window, we might not have got a good enough sampling to understand what we really have going on. And last but not least, the event just may not have triggered yet, right? Just because auditing is turned on doesn't mean a specific activity has actually crossed that threshold to be able to trigger. So those are things we just want to keep in mind, but it's still, we want to be able to get a high level idea of what we have to see here. So I've wrapped up a lot of the things underneath into a really easy function just called Winvestigate. And so it's, it's Windows Investigate essentially. And I'm going to be passing it the Elasticsearch information here. I'm passing it the name of the file that it's going to save as an HTML file. And then I'm going to pass it the global variables. And so it goes and it runs and it does all this mashing of things here, right? So if we go to see it, here we're opening up the CSV file and we're reading it directly into a pandas data frame. Then we're adding two more things. So if we notice in the spreadsheet that was given to us, it gives us some nice stuff up top. Let's get to see what our columns are. So it gives me category, settings, event ID, and message, but it doesn't give me any idea of success or failure. So essentially that's what I did here is I built a new column for success, a new one for failure, and I had it filled with just kind of nothing, just kind of as a placeholder. Then when we do the query here, it goes and gets all that information. And then as it's looping through all the data in here, it's looking to see, hey, does that piece of information, that event ID, does it have a success? If it is, go ahead and add a yes to the success column for that event ID in that data frame. If not, add a failure to it. And then if there's nothing, of course, nothing else happens here. They'll just have the NA. And so the outcome of that is a document that looks like this. So it's essentially the same thing as what we had over here, but in this HTML file, we've got the success and failure. So I can see that in my lab, I've got account logon turned on for both success and failure. For this one over here, I've got it turned on for success. Now, something I've noticed is not all events have a success and failure. So I'm in the process of going through the Microsoft documentation to figure out which ones don't have a failure as an option for that event ID. So I can make this a little bit more accurate. But right now, it gives you a high level idea of what your audit policy is set. And so with that, now you can go look at your content, look at your dashboards, you can look at your rules, you can look at whatever else you've created to understand, do I have the right information that would actually allow that content to trigger should something bad happen here, right? So if I'm looking for curb roasting and I'm like, okay, do I have the right event IDs that could tell me about curb roasting? Well, I might, but there's also some things that I'm not getting for curb roasting in my environment. Possibly, again, I may not have the events themselves, I may not have a big enough time, but it's a good, just high level information, about what I have or what I don't have. So that's pretty much it. This definitely was a lot quicker than I thought, but it's a very just basic idea of kind of walking through Windows event IDs and then just kind of walking backwards to see, can we look at the audit policy based on the events we have and kind of figure out what does that look like. If there are any questions on the Discord, I'm more than happy to answer them.
I should come back. I haven't seen any specific ones yet. I do have a question.
Yes.
Of my own though. So Elastic has its own kind of like Python library published on PyPI, and
yes.
So some of this stuff that strikes me might be useful inside that library, like some of these functions that you have. Have you considered that or putting them in a package?
So I'm looking at doing something very similar to what you've done with the Mystic Pi. But then when I looked at, you have additional things you've done in there. You've also added things like Splunk interfaces. So one thing I'm going to do is after watching the talks tomorrow about the Mystic Pi to see, should I add this to that data set and just have this a part of the universal data set, right? To where we have a more data agnostic way of viewing data and we keep the underneath portion, right? Kind of people don't have to worry about it. So they can connect to Azure Sentinel, they can connect to Splunk, they can connect to Elastic. It doesn't really matter, but the front end, right? The analytics side should be same. So that is one thing I want to investigate that I kind of learned.
Yeah, we've had an Elastic provider on our to-do list for like a year and a half, I think, for Mystic Pi. So it's just,
Yeah, so Elastic does some cool things. The other thing that they've done recently, it's currently experimental, is they have another module called Elan that you can actually write pandas queries against Elasticsearch, and it'll do all the underlying technical stuff to make the query happen and return the results back in a pandas data frame.
Oh, nice.
And so that's something I'm working with the developers on, waiting for it to get a little bit more feature friendly there, and then I can see about doing that, because right now I'm doing like a lot of pretty much the way, right? You're using the raw Elasticsearch, and then I'm going down here and doing DSL, which is our domain specific language on Elasticsearch. Think about it like assembly is, right? So regardless of what programming language you write on a Windows machine, it comes down to x86 assembly. That's essentially what this is here. And so it's something, I don't want people to have to learn because it's not necessarily very user friendly. So just trying to, abstract that from people, but give them functionality of how to get things easily.
Cool.
Looking forward to your talks tomorrow, so I can see, what can I do? Where can I take this? Because I don't want it to be another side project that people have to think about.
Yeah, it's great. Great. We'd certainly love to do something. Also, with the Kestrel stuff as well, we'd love to. I've got a better integration. So this would be great. I don't know. Roberto keeps kind of popping in and popping out. I don't know if he's trying to say something or just.
I think my camera is being weird right now, so trying to figure it out.
Oh no, we're not going to see you.
This is something we're also trying to give out, just so, as we have various customers out there, right? Someone could just look at it very quickly and get an idea of, hey, what do I have logging? So the next stage of this is, because all of our detections, we've open sourced them, is to take your Windows events and match it to rules that we have on our GitHub repository, and say, based on what you have logging, these are the rules that could actually possibly work in your environment, right? So if you don't have like sysmon process running, or if you don't have 4688s, 89s, there's a lot of things you're not going to get around process execution and things like that. So just helping people understand, right? Because to me, one of the things that's frustrating is people don't understand what they have in their environment, and then they kind of have a false sense of reality of their abilities because they write all this content without validating that would actually find something in the data that they have.
Yeah.
And so this is kind of helping you say, hey, this is what you really have, like it or not. This is just the truth. Right? Based on this, you figure out what can you do with it.
Yeah, that's cool. Because you may have a correctly set audit policy, but the collector isn't collecting the kind of events you need or something like that. So.
Because there's so many different things, right? From the audit policy, then what's collecting it, right? Because you could then filter it, even in like WEF, you could filter what goes on, what stays back. And there's so many different things that can drop an event before it finally gets into your analytics platform. And so it's good to understand, right? Based on what maybe you have the event policy and you know exactly what it looks like, but when you run this, you find out I'm missing a lot of things. Why am I missing all these things that they swear are turned on? Right. And to your point, you might find out they got filtered somewhere in the stream.
Yeah. We've certainly experienced that internally, like in Microsoft. It's like we thought we had command lines for something and we don't.
Yeah. That's a big thing here, is I just want people to be, I guess, more aware of what they have. Right. Have a realistic idea. And it's not neither good nor bad. It just gives you a great starting point of reality that you can work back to the left, say, okay, I need to get more data, right? As opposed to say, I need to get more data. You say, well, because of this limited data set I have, I can only look at these small little number of items that align to the MITRE ATT&CK framework. Right. So if you go back to the post that Roberto had a few years ago on how hot is your hunt team, right? You can then map that to say, okay, I've only got 20% coverage of the MITRE ATT&CK framework because I only have these specific events turned on. Right. And it gives you a real justification of why do I need more events? Of course, that's going to turn into other architectural things.
Yeah.
Help drive conversation.
Cool. I'm just checking. I don't see anything.
Definitely a lot to learn on the Python side, the notebook side.
There is a question, I guess, from Block, right?
Yes.
Your early comment about offloading to Elastic makes a lot more sense now.
Yeah, and that's one of the reasons I want to show, right, how long it takes to run a query and kind of show how much data we're dealing with, is to, hey, let's go ask Elastic to do it. If you think about any database, anything that does storage, you ask it a question, and it's really good at crunching that data and giving you back results, not, can you give me 44 million lines of events so that I could crunch the data? Right. But unfortunately, I see people do that a lot, right? They're like, oh, I need to get just raw data, bring it all back to my Excel spreadsheet or bring it back into Python, and then I'll do something with it. It's like, that's going to take you forever to pull back 45 million events from any type of data storage, right? Unless that's what its purpose was to shift data to you.
Yeah, and you need a workstation with 128 gigabytes of RAM just to load it into the memory, and unless you're using Dask or something. Yeah, so the more intelligently you can frame your queries and have a backend do all the stuff, then
it's a bigger server, it has more power, just let it crunch the numbers, give me back the answers, and then I can work with the answers and kind of go from there.
Cool. Well, thanks very much. I don't, oh, there's another question. Any plans to incorporate the MITRE heat map into your notebook?
Yeah, so that is the third part. So the second part is just going to be getting all of the rules that we have on our detections mapped to that. And then after that, bring out a MITRE heat map kind of based on what Roberto had to show. Here's what rules would cover with that.
Yeah, that opens up some cool possibilities as well, because then you can use the heat map to potentially link to Sigma rules that you could use.
Yeah,
kind of query invoke the kind of detections.
When I was a consultant going into a lot of SOCs, it was amazing how many people were very happy and really satisfied with their content. But when as a consultant, you go in there and start doing analytics on it and find out a lot of your content's broken, a lot of your content doesn't work, right? There's things that are just missing. And the humbling reality that maybe you showed me 400 rules and I find out that only 25 of them work. Right. And so this is just to your point, right? Let's get to reality. If you don't have this data, you need to know you don't have it and that all of these detections are no longer possible. If I have processes, but I don't have command line stuff, well, I'm limited in what I can see.
Absolutely.
A quick question, Neil, how do you, so how do you feel with, because it seems that when you are running queries, you're using, what is the syntax of that query? Where it's pretty much like a lot of JSON objects when you query data?
Yes,
that's not
Elastic's DSL.
Elastic DSL, right? Okay.
So with Elastic, right, we have various languages. We have EQL, we have a generic SQL-like thing on top. At the end of the day, all of those will get transformed into Elastic DSL to run against the backend.
Got it. Okay.
Here I'm just going, well, let me just go with the raw data because I know I have a lot more power here. So here I was able to say, hey, I want you to go ahead and aggregate every event ID and essentially create a bucket. And the bucket name is the event ID. And then in that bucket is the success and failure, right? Did it have a success? Did it have a failure? And the count for each success and failure.
Got it.
Very high level aggregation that I just ask it to run for me to give me back the information.
Very nice, man. Yeah, it's kind of hard to, I guess, write. It's that you have to get used to that, right? To write in that format, right?
It does take time. So one of the things I'd like to do is to be able to make some of this easier for people, right? And so get these high level functions to where instead of having to learn how to do this, you could just do this, right? Understand that the sample aggregations is doing all of the work for you. You just have to say, what field do you want to aggregate on?
Right.
After that, then I'll tell you here, you aggregated on it, and this is the count of events for that specific user ID, right? For that field, so on and so forth. Because I think, when you're doing high level analytics, you're just trying to get a feel of what's going on. You have probably very similar questions. So just trying to get, what their similar questions would be like and just putting some functions around it to make it easy for people to access.
Hey, so one quick question since we have a couple more minutes. Have you played with the ES Hadoop library from Elastic, which I believe allows you to I guess run queries against an Elastic deployment that distributed its data like across different servers? Have you used that for clients before, or?
I haven't personally used it. I believe the ES Hadoop connector loads the data from Hadoop into Elastic to then run the query.
Mm-hmm. No, I think that it. So as far as I know, it can connect to a Hadoop, right? Kind of like environment, because the whole ecosystem. But I think that it could actually use Elasticsearch as if it was, well, treating it as a distributed data repository, pretty much.
Yeah.
So yeah, that's what ES Hadoop is for as well, right? Because it does connections to Hadoop ecosystems, but then also directly to Elasticsearch. It's just that it handles all the paging of queries. For example, like if you run a query, you only have like certain amount of results, and then you have to go through every single page to get all the data. So ES Hadoop kind of like works and handles, I guess, all the stuff for you as well. But I was thinking, like some clients might ask what you are describing, like to be done in their environments, but then, what if they have their data across a couple of clusters? How do you do that, right?
So as long as it's in Elastic, across a couple of clusters is easy. We can do cross-cluster search. That's a configuration item that they can do in their environment.
Ah, nice.
So
okay.
You query one cluster, and then that cluster, because Elastic is just distributed, will then ask the question of all the other clusters that it's configured for to just get the answers back again. You don't go, hey, all 10 clusters, can you give me back 45 million events from everyone, right? That's not what you do. You go, hey, all 10 clusters, can you do me a favor and tally up the event code for all your things, and then just pass me back the answers to that? Right? So you'll ask that one cluster, and then it'll go and essentially federate the search out to everything else, get the results back, put the results together for you, and then give you a single answer back.
Got it. Okay. I didn't know about that config, so thank you, man.
Yeah, if anyone has Elastic questions, you can hit me up here on the Discord, or I've got my Twitter handle, which I believe is out on the webpage. You can DM me there, and I can help kind of answer stuff around that.
Yeah. Awesome, man.
Cool.
Hey, thank you so much, Neil.
Thank you guys very much for having me on here. Definitely a very big learning experience.
Yeah, that was awesome. Actually, there was one question. I know we just kind of said goodbye, but it was about the performance, like what kind of cluster spec you set up to get like half-second performance. I mean, I guess that's kind of how big is the data question.
Yeah, well, let me see here. Give me a second, and I'll actually show you what I have.
Okay, you're no longer sharing your...
Yep, I'm gonna, after I log in, I'll share what I have.
Okay.
All right, so...
We don't mind seeing your password, that's fine.
Okay, that's what I don't want to show. All right, so here, I'm again in our cloud environment. And so I've only got 3 nodes here with, this one has 15 gigs of RAM. This one has, so I pretty much have 15 gigs of RAM on there, 1 gig of RAM for the tiebreaker. And because our detection engine is now a stateful app in Kibana, I'm running 2 of them as opposed to 1. But when I do a query, it's just going back to the Elasticsearch instances here itself. It's not actually going to Kibana at all. So if we look at it from a, right, so I've got 450 gigs of storage. So this is pretty much what I have set up. So it's a very minimal cluster. This is not a big thing, right? To be able to get kind of those answers back.
Yep. Many people's laptops are that big.
Yeah, it's distributed, but yeah, it's definitely not something that's insane. But again, this is the speed of Elasticsearch. If you know how to ask the questions, it could do a lot more for you and return the answers again, as opposed to give me 45 million events so I can put it in an Excel spreadsheet.
Cool. Okay, we've got a couple of minutes before the next thing, but thank you very much for coming on and spending time with us.
Thank you very much.
Yeah, it's great.
Thank you, man. All right. So we are 2 minutes away. I think I can start by introducing our next speaker, Ashwin Patel. Sorry, my camera somehow is not working, so I can't show up in the camera. Ashwin Patel also works for the Microsoft Threat Intelligence Center, the R&D division. Nice to meet you, Ashwin. Just treating you like if I don't know you. And so Ashwin, so when I also met Ashwin, I think it was the first couple of times that I saw his research was related to a lot of different techniques, specifically for time series the application of time series analysis. And that was pretty cool to see it with different data sources. And I think that that's pretty much what kind of normally translates into, okay, how can we do now this at scale, right? And that's something that I've been seeing as Ashwin, keeps doing research, is to understand now how we can take these techniques to the next level, and not just in one, right, like basic, I would say, lab environment, but how can we use other technologies that could help us do some type of analysis at scale. So Ashwin, take it away, thread hunting at scale with Spark notebooks.
Awesome, thank you. I hope you can hear me fine.
Yeah, I can hear you fine. I don't know if you, yeah, so we will see what the Discord says, but I can hear you.
All right, yep. All right, so sharing my slides here. Okay, all right. Thank you, Roberto, for introducing. I think, yeah, that was quite a good intro. So yeah, my name is Ashwin Patil. I work for the Mystic R&D team, the same team that Ian, Pete, Roberto, and we are part of. So today, I picked up a topic, thread hunting at scale with the Spark notebooks. So I got introduced to the Spark like a year or a couple of years back due to part of some of the work-related things. I definitely was questioning, like, why do I have to learn another language and another analytics platform and that sort of things. But we had scale-related issues where we wanted to query some large portions of the data, and then Spark seems to be the only solution that we have to do. So I basically, this talk is kind of like compilation of me, like how I learned the Spark and various features, and then all of the things related to that. So little bit about me. I've been like doing the blue teaming for over 10-12 years now, for couple of companies like Cisco and National Stock Exchange in India. So most of the times, like, I started with the SOC analyst and then doing all related roles related to IR, DFR, etc. Last year, like due to COVID, like I got a chance to submit CFPs for multiple conferences. So including Jupyterthon, Grey Hat, and Purple Team Summit. The only one, the Security World, was I think before COVID. So that was like in person. And then as part of the work, I also like publish regularly blogs on the Microsoft Sentinel threat hunting and involving some Jupyter notebooks. So this is the agenda for today. So I've organized this talk into like kind of like introduction to Spark, and then some of the what does the Spark distributed processing looks like, a couple of things related to that. And then we'll be looking at like what are the sample use cases for threat hunting looks like that can leverage the Spark, right? So we have seen like during today only, like we have seen like multiple questions like do we have to like load millions of data into the data frame to do the analysis and all those things. So we'll be looking at specific use cases that does require similar type of analysis, and then that's why we had to choose like a big data analytics solution such as Spark, right? Lastly, like I recently blogged about like this specific use case, C2 network beaconing. We also have a talk tomorrow about the same C2 network beaconing. I think Mehmet is going to talk a little bit more on the statistical side and then how he's using that with the sample data set. So that's also like interesting talk. And then we'll conclude the talk. Right. All right. So if you have not knew about like Spark or like what does it does. So basically the Apache Spark is like a parallel processing frameworks. So it supports like in-memory processing. That's definitely faster than the disk-based, like traditional disk-based processing, right? So you can get the results much faster. So your memory is kind of distributed across like multiple worker node and master node. We don't have to go into the architecture and the complex stuffs. So basically, you can think of like your, if you have like a very large data set, like 100 of gigs of data, you can basically distribute the data set into multiple nodes so that each one have their dedicated memory. And then you can manipulate that data sets like a local correction, right? So Apache Spark also supports like multiple languages. We are going to talk about like PySpark, but there are like other languages support is also there, like C#, Scala, Spark SQL, right? So primarily, like typical use cases of Spark is like generally ETL workflows, right? So if you have like kind of any data engineering or like complex data preparation type of task, you can use like Spark for that thing. Machine learning is another like very kind of objective that most of the data science team has, for which they have to load like large set of data, and then for that purpose they can use Spark. Right? There are also like other features like Spark offers like graph processing or like streamings. This really depends upon your specific use cases and how you want to handle that. So yeah, so this is like one of the questions that I also asked, like when we had to pick up these big data solutions, right? So typically, if you have seen like all of the modern SIEM solution that handles like pretty good amount of data. I don't want to quantify that, but like it does do most of the complex threat hunting on like probably weekly or like even monthly type of data sets, right? So most of the SIEM provider also has like powerful query languages. So it's not like you can only run like very simple SQL type of queries. Nowadays, like you can run like a lot of similar to like Python, pandas type of data analysis through native query languages, right? So the query language is also not an issue, like to bring it data to the Spark, right? So the issue arises when like these queries, like let's say like even if you have like a complex processing on large volumes of data, they do not scale well against like large historical data sets, right? So sometimes you also have like a chain complex processing. So let's say like you want to serialize very large data sets, and then you want to do like some kind of windowing and some kind of aggregation on partitioning data by let's say some kind of like unique key, right? So that time it becomes like a chain complex processing, where your traditional SIEM providers probably may not work that well, right? So that time it makes sense to basically load the data sets into some kind of like a data lake or like specialized data storage solutions, so that that can be used for that type of operations, right? So also like most of the time you have like less retentions on the historical data. So typically maybe your SIEM may have like probably 6 months or probably a year of data, but if for any reason, if you want to query like more than that, you have to fall back to like some kind of archive storage solutions, right? Now, so Spark came in like during 2010. So it kind of addresses the scale and performance issues of the data. But like afterwards, there were also like kind of native Python libraries that also came, such as Dask, Rapids, Wix, and then there are a couple more libraries which kind of does the distributed processing of data frame with your local computer or like native computer, right? So that arises a new questions like if we can do that through these kind of native Python libraries, why do we need like Apache Spark? So there was also a talk like I came across like at PyData conference like a couple of years back, addressing like the same topic, like is Spark still relevant when there are like other libraries that does this work, right? So right now the state is currently these libraries are like still new. They do not have like a kind of good native features like in terms of data processing, and then the lack of adoption and enterprise support is less, right? So for these reasons, at this moment, like Apache Spark is still preferred in enterprises, like to perform like complex data processing or like big data analytics type of operations, right? So also like these libraries currently supports only Python, right? So if you want to work for some reason, if you want to work with like other languages or like other features, you have to fall back to the Apache Spark. And then with the Apache Spark, you also can integrate with the whole Apache ecosystem. There are like other Apache tools also there that you can work with those things. Right. So these are like a kind of example Spark notebook solutions that you may have heard. Apache Zeppelin is like the project from the Apache only that offers like Spark related notebooks. Databricks, so these are all like vendor-based solutions. Databricks was probably the first one who actually was like one of the Spark creator as well. He came up with that company, and then it offered like a pretty good interface and some of the good job scheduling and all those experiences within the product, right? And then each cloud provider has their own implementation, such as like Azure has like Azure Synapse, Amazon EMR, and Cloud Data Proc. They kind of does like similar type of Spark type of solutions, right? So for some reason, if you have like data into like one of these cloud data storage, you may want to probably check within that cloud, within that same cloud, if the Spark solution exists, and then move to that solution. Now, so we talked about like the Spark distributed processing, like, and then how does it handle like a faster results on the large data sets, right? So this is kind of one of the example that I took just to get an idea about like what does the data processing looks like in the Spark world, right? So within the PySpark, like we have a function called broadcast. So what it does what it allows is basically you can have like a kind of smaller data frame, right? That data frame can be broadcasted to like multiple nodes, multiple Spark worker nodes, and then that will basically join with that huge data frame, right? So the results, so the reason for this is like these type of operations will be like much faster, because let's say like you have like a typical use case where you have like very relatively tiny data frame, such as like lookup table or something, that sort of things, and then you have very huge kind of a humongous data set that you want to join it against, right? So in these cases, like if your data is distributed, if you have to do like a normal join, like there may be like shuffles and all those things. So it kind of avoids reshuffling both data frames and then joining, right? So this is like native Spark features. If you do join in this way, like the results will be much more faster. Now, so yeah, these are like some of the use cases that you can think of, like why or like where you will have to come back to the Spark solution, right? So a couple of examples from here is like, let's say, I want to take like few examples here. Like if you want to calculate like entity prevalence, right? Or rarity for certain entities. For example, let's say like you want to calculate like how common that particular executable is across all of your environment on like probably large historical data. So some of these type of details may also be provided by your EDR solutions sometimes. But if you do not have those EDR solutions and you want to basically customize and then populate that type of metrics, then you have to basically load the entire data set and then calculate the prevalence and then provide that contextual information to the analyst, so that can be helpful in the investigations. A few other things that you can think of is like, especially the network logs or Windows event logs can be very voluminous, right? So if you have worked with like any larger enterprise solutions, you may have like hundreds of thousands of endpoints, right? If you just enable logging for like 4688 process creation events, the data volume is very huge, right? So for, let's say, like if you want to calculate the prevalence and all those things, your data becomes like pretty huge, like the input data set becomes very huge. So you can run into like scale issues, right? C2 beaconing is something that we will basically going to look into. Other example is like, let's say DGA domains. If you want to basically perform like, or like probably extract like multiple features from URL, such as like entropy, how many character it has, like if there's any special characters, such as more statistical features from like very large historical data sets. At that time, you cannot do that from your native SIEM solution. That's why you want to basically offload that processing into Spark, right? So I hope like these use cases make sense. That's where like we have to come back to the big data analytics solutions. Right. So the use case that we are going to take a look into is like C2 network beaconing, right? So this is something that we recently blogged about it. This is based on the previous work done by the threat hunting project. Like this is where I read more about it. Like, yeah, you can do like detect like network beaconing via inter-request time deltas. So what it means is like between the each connection for each source IP and destination IP port pair, you can basically find the time delta. And then if that time delta is basically repeating for over a day period of time, as compared to the overall total events, then you can conclude that that can be like beaconing type of activities, right? There also like can be so the if you know about like C2 frameworks, they also provide capability to add jitter, like when you can initiate the beaconing traffic. So at that time, these the intra-request time delta may not give like useful results, but you can still like process some additional processing that we will look into to detect like jitter type of activities as well, right? So this was like original blog that we did where we kind of used like Microsoft Sentinel's native query language to perform the same analysis, like basically adding some filtering so that it filters for internal to external traffic, do the serialization, sort, reordering, then basically calculate the time delta between like previous to next event. We also did like windowing and all those things. And then also applied some certain global threshold parameters. But these query is probably one of the complex query that we have. And then it does not scale well with the native like SIEM solution, right? Unless until we really reduce this input data set with some kind of like additional logic, which will basically remove like large set of public IP addresses, which can be like potentially benign, right? So if your data is already huge, then these type of complex operations may not scale well on a larger enterprise. So for that reason, we decided to basically implement this same use case within the Spark. Right. So for us, like we have like data source as network firewall connection logs, and then basically the goal for us is like identify the regular time delta patterns, which can indicate the potential network beaconing. Okay. So this is like how the architecture looks like. Again, some of the in your cases, like only the data storage solutions may change. But then like the whole notebook is still applicable. You can still apply the same notebook, same methodologies once you load the data set, because Traditionally, if you have seen like firewall logs, it has like kind of same field that you can see like source IP, source port, destination IP, destination port, number of bytes sent and received, and then timestamp, right? So these are like pretty common field that you will find in almost all of the data, all of the SIEM solutions with this particular data provider, right? So once you load the data sets and then have the same type of schema, then basically you can pretty much follow the same notebook to perform the similar type of analysis, right? So in this case, like as you can see, like since the SIEM solution was not scalable, we have to offload the data like by adding like a continuous export to some kind of data lake, and then these data lake can be used via the Spark solution to load the data into the notebook, and then perform your processing and whatever the analytics that you want to perform. And then if you feel that you have like some kind of like actionable results, then you can also send those results back to the SIEM solution, right? So that way, like analysts don't have to perform or like use computer resources of the SIEM solution. They can directly get those as alerts, and then basically only perform investigations on the entities that are flagged from this particular node, right? So here you can see like example of kind of beginning, like you can see like the for each between each connection, there's like 30-second type of time delta between these things. So now we'll quickly go and probably look into like how does this looks into the notebook solution. So before that, like we are basically loading all of the raw traffic connection blocks. We are not performing any kind of like filtering and all those things, because that's what like we will do within the Spark, and then Spark is capable of that thing. So we don't have to worry about the scale and all those things. And then once we load the data, you can basically apply some kind of like event-based thresholds so that you can remove some kind of high cardinality type of events. So sometimes your data may be hugely skewed. So you may have like a kind of long tail of IP addresses that are kind of like going in and out, and then only initiating a single connection, and probably not like a relevant protocol such as like ICMP or other things. So that may not be eligible for your data analysis. So you may want to basically filter out those type of data events. And then one other thing that you can also do is like basically populate or like filter the destinations which are having a high degree of source IPs. So what I mean is like, let's say there are certain IP addresses, let's say Microsoft Windows Update, right? So it is expected that most of the Windows endpoints will connect to the same type of destination, like IP ranges. So those destinations will have like very high degree of source IPs. So that's kind of going to be likely benign in many scenarios, unless until there is like high level compromise of the bigger organizations. But you can basically filter out those type of destinations as well within the notebook, right? And then once we reduce that input data set to the data set which is like eligible for analysis, then you can perform the actual data wrangling, right? So if you have been doing the data wrangling through notebooks, Python, those data analysis libraries, you will find like similar type of capabilities also present within the PySpark. The only thing is like the API, like your data frame may be distributed across worker nodes, and then once you perform all of these operations, the Spark will take care of those, optimizing the operations and then creating a plan of executions, and then giving you results back, right? So this is like one of kind of like windowing that you can do also, like once you calculate the time delta. Let's say like attacker has added like some kind of jittering. So what you can do is like you can do further windowing of the time delta thresholds, and then basically find out the cumulative sum versus the total events, So that way you can basically find out, like, let's say there is a jitter type of pattern is available. All right, so let me quickly go back to the section. Okay, so I've zoomed in the notebook, so hopefully it is visible well, right? So this is the one notebook that we have published into the Sentinel gallery. And again, as I was saying, like if you do not have the similar SIM solution provider, you can still follow the same notebooks. The only thing that you have to basically change through is like reading the input data from whatever the SIM solution that you have. And then once you load the data, then you can basically perform the similar type of analysis.
Ashwin, you're still sharing the PowerPoint rather than the notebook?
Oh, sorry.
Is that a plan? Okay.
Yeah. So I think I've shared the window and then. Good. Okay. This is visible now.
Yep, that's great.
Okay. All right, so this is the notebook that is published into the Sentinel gallery. So for the first thing is like you basically want to authenticate to your whatever the data provider or like data lake that you have. Once you authenticated and then basically start the Spark clusters and all those things, you can then connect to your data lakes with whatever the details that you have. And then you can specify, like, let's say, historical data sets like end date, look back days, and then load all of the historical data set into the PySpark data frame, right? We have not done any operations yet on the PySpark data frame, but the loading, so Spark is kind of like lazy type of operations. It will only perform the, it will only start the processing only when there is an actual kind of operation such as like show or display, that type of things, right? So here, I think we can probably skip these portions. This is mostly like some kind of custom code that we have written so that, let's say, like if we provide start end date and then we provide like a kind of like 21 days look back, it will basically create an array of these date formats so that you can load, or like you can load sequentially that data set into the PySpark data frame, right? One other thing that we have done here is basically we are loading the data like per day. So we are not directly loading data for like entire 27 days. And then we are basically adding and appending that to the Spark data set, right? So this is how like you can basically do like Spark read options. And then the recursive file look is basically some kind of option that will allow you to, let's say, if you have a kind of nested architecture. So let's say in this case, we have added like a continuous export of data, and then it will have like a file structure such as like year, month, date, and then probably hour, and then maybe minute. So you have like kind of this nested data structures, right? So in this case, like we basically just created the directory based on the date format. So whatever directories inside of this parent directory, that will basically load with this type of option. Right? Then we are basically doing selecting like very specific fields so that it will load that type of schema that we saw in the presentation. Right? So some of these operations that you may be familiar or like you may have seen from the existing Python workshops, like select, filter. There's like different type of syntax that you may recognize, but then it's pretty much the same. Right? So I think let's probably quickly go back to the, quickly move to the next solution. So this is like a first step where we are basically filtering out internal to external traffic. So in this case, I have basically used like a regex operations. There can be like other methods that you can also implement, such as like IP address library and then basically identify IP addresses public and other type of operations to filter traffic from going from private IP to public IP. So once we filter those things, we have applied certain thresholds, as I was saying here. Then we have so we are basically looking for any destinations which are having less than 25 source IP, degree of source IP. That means let's say you have probably 100,000 workstations, and then for certain destinations, only 25 hosts are connecting. We are interested in those type of destination addresses. Right? Again, this is kind of static logic. You can make it dynamic by taking a mean or average of historical count, and then basically populate this threshold as a dynamic. Here, we are basically aggregating and performing the same type of things, where we are basically populating these values for each destination. And then for source IP, we have basically applied a count for each source IP, and then added the thresholds greater than this event count. Okay. And now we remove those input data sets. This is what the baseline data set that looks like. That will be our input data frame. And then this is where we will perform all the data wrangling that the Spark offers. This particular will basically calculate the time delta between previous and next event. These are type of functions that are available within the Spark, such as windowing and partitioning data set by certain fields. Yeah, and then we are also populating some additional columns where we are basically aggregating what is the aggregated bytes observed for that source IP destination IP pair. So I think we have 5 minutes left. So yeah, so few other things that basically we are doing here is that additional calculation, where we are basically, even if we have calculated, let's say time delta and then count associated with each time delta, what you can do is again apply windowing on that time delta to make it a time delta list, and then calculate the count for that array, right? And then you can perform kind of this percentage beginning, where you will have a time delta list count, and then you will calculate the overall total events that are observed for that source IP pair, and then divided by 100. That will basically give you percentage beginning. Right? Again, this is not very solid methodologies, but it does reduce your input data sets very drastically, and then gives you very minimal set of events. Now, once you receive these events, you can enrich with other type of operations, such as threat intel or GeoIP, and then probably reduce the data set even further more, and then make it actionable alerts for an animal. Right? So once it's all is done, you can basically send all those results back to the Sentinel as in terms of a report, or you can also visualize that within the node. So I'll quickly go back and then cover this conclusion section. So basically, the Spark will provide new type of detection idea, which may not be scalable due to your SIM solutions, to basically transforming that ideas into a Spark notebooks. And then once you perform the analysis, you can get the results back to the SIM solutions. You can also provide, Spark also provide capability to hunt on the historical data sets to perform complex analysis through which analysts can get insightful or contextual results. Right? So this is a link to the notebook and the blog that we have done. I'll share these links into the Discord. But yeah, that's pretty much I want to cover today. Yeah. Do we have any questions or comments?
Awesome, man. Thank you very much. I don't think we have questions in the Discord channel. Let's see. Well, somebody's typing, but so meanwhile that happens, have you so it seems that you're using with your notebooks, you're using Synapse, right? Because of the Spark capabilities.
Correct.
Are those, methods that you're using, those also are available just with regular PySpark, right? Because you're using also just regular PySpark on your notebooks, correct? Like the windowing and all the stuff, right?
Right. So that's basically a PySpark API. There is you can use it with any solutions. Like the only thing that will change is like basically load the data from, let's say, Synapse storage, or like maybe in Databricks that may be like Delta table or some other solution. But like once you load the data set as a data frame, you can perform like same type of API operations, because that's like available within PySpark.
Yep. So we have one last question, and it's our next speaker. What scale does the Spark start making sense at? Any idea?
Yeah, I think so. I don't think so. Basically, the Spark solution provider gives capability to scale pretty high memory clusters. The only thing is like you will run into cost issues at certain point of time. But I think it may not be, I guess, like intelligent to do like very large, complex, large operations just because like you have processing power available. You still want to make it intelligence and then optimize it as much as we can, like such as like you have seen, like we have applied like certain thresholds, certain benign patterns, so that we wanted to reduce the input data set as much as possible, and then you can do the processing later on.
Got it. Yeah, I remember there was so something that I've seen implementation wise of Spark is like running queries like every hour or every 30 minutes across large data sets in order to take the meaningful data that we're going to use later, either for an investigation or for some additional exploration of the data. Like, for example, why would I query data that maybe has like 1 or 2 events that I'm interested on only? So why not split it over time and then keep only relevant data? So for that use case, I guess that sounds kind of simple. Spark was used because of the flexibility to query tons of data to do some filtering initially. So that was pretty cool to see that, but I'm pretty sure there is other, of course, more complex use cases that actually call for Spark and why it should be used, I guess. But yeah, awesome, man. Hey, thank you very much, Ashwin. Are you going to share that notebook, at least a link, because you said that that's in the
yes,
right, Jupyter Gallery, right? Oh,
yeah. I'll share the notebook. Both are like public, so I can share that into Discord.
Yep. So we only have, well, we don't have any more time, but you still have a question in Discord. So would you mind just jumping on the Discord channel and then please share some ideas? Yeah.
Will do.
All right. Thank you very much, Ashwin. And I think we have Pete. You're going to introduce our next and last speaker.
Yeah, thanks, Roberto. So yeah, I get the honor of introducing our final presenter for today. So Leo Merovich, who's the CEO and founder of Graphistry. And it's a special session now because it's actually a 2-in-1. Leo's going to take us through graphing some honeypot data to get some value and insight using that graphing. And then a second session looking at how we can use GPU acceleration to go from the kind of relatively small data sets that we've been using today up to, well, it's telling me hundreds of gigabytes a second. So it's pretty large scale. So I'm looking forward to seeing how big we can go with that. So yeah, without any further ado, over to you, Leo.
Awesome. Thanks, Pete. So yeah, and I've actually been enjoying the sessions I've been able to attend so far. So all right, let me turn on a screen share here. And so folks should be able to see some notebooks we'll be looking at, and then, but let's start with some introductory stuff. So yeah, I'm going to be talking about today's a 2-for-1. First is we're going to look at one honeypot data set, but we're going to use maybe actually, I forgot how many we ended up, like somewhere between 5 or 10 different visualizations of the same data. So just kind of different ways of getting value from that same data set, different perspectives. And then after we'll do kind of a deeper dive on kind of GPU wrangling tricks where what you could do with a single node to kind of get some impressive performance. And then if you want to do some multi-GPU or many GPU, a bit about that. There's after the talk, actually I'll do this, right? Oh yeah, I'll do it after the talk. I'll post and I think actually on the website for the InfoSec Jupyterthon, if you go to the agenda for this session, there's a RSVP link. If you fill that out, we can actually get you some free GPU credits at, I don't have their logo here, but Paperspace. So you can actually do all this stuff for free with a bunch of GPUs, depending how you want to spend your credit. So even if you don't have GPUs, you could try this stuff. Yeah, so just go to the agenda. And actually something I didn't see when I was trying to figure this out, I didn't find the Discord link on the main website, but if you go to the Open Threat Research Discord, if you Google for that, that's where a lot of this chat is happening. So yeah, let's jump in here. So just as a quick, basically about us or disclaimer, either way you want to read it. So Graphistry is a startup that kind of looks at connections and data. We'll go anywhere from like threat hunting and threat research to account takeovers, payments frauds, behavior analytics. Like we'll kind of look at all that, kind of connect the dots types of questions on event data. And our approach, and you're going to be seeing this in some of the techniques I'll be going over today, is visual graph intelligence. We think about it in 2 ways, and you'll be kind of seeing that here. One way is the advanced visual analytics, where we just want to have different ways of looking at really wide data. And the other, increasingly, is AI methods, and touching a bit about how to start thinking in those ways. So yeah, like as I mentioned, for first, overall, we're interested in the problem of when you have really wide data, how to look at it. And what I mean by that is if you look at like a regular like endpoint or network or whatever, any kind of alert, we just have lots and lots of metadata. So if I look at it, I could have it as a bunch of text, but if I looked at it in Splunk or Elastic, I just have like I'd have like a really long horizontal go through all the columns of data. So that's what I mean by wide data. And that's a little different from a lot of other analytic problems, but increasingly as we're getting more fidelity in our sensors, it's getting wider. Likewise, as we're getting more data sources, we just have lots of kind of data. So that's in a math sense, that's a high dimensional analytics problem. And so we'll be getting into that. So yeah, let's jump in. So for the first section, I'm gonna be talking a bit about, for one data set, just different ways of looking at that data. And these notebooks will be all in the PyGraphistry GitHub repo. So I'm gonna be looking at it from a graph perspective, and then more kind of more modern machine learning perspective, and I'll actually be combining the 2 methodologies at the very end. So I'm gonna be looking at honeypot data on sec repo. And I don't actually remember which one we're doing here. It'll be in the notebook, but from the perspective of the approach I'm going to be showing you here, like you could basically do any of these. Like if it's like Zeek network logs, if it's, I think I'll be showing some like malware threat intel data, and then imagine like any host like win logs we'll be talking about as well. So just really wide data. And also a big thank you to Mike Sconzo, who's been kind of collecting this stuff over the years. So he's doing a really, really good job. So yeah, so let's start. We're going to be using, I'm using something called cuDF. We're going to be talking about that a bit later. For now, just pretend we're using pandas like most of the other talks are doing here. So just think pandas, just think data frames. So in this case, we're going to start off with just loading some honeypot logs. These were, I think these were network logs. And so if, we did a little bit of cleanup just as normal. But what we were interested in, like given these normal, I guess it's like so we have regular IDS data, and we just wanted to see it. So and kind of understand what is going on with this network system. So I'm going to kind of look at some different ways of doing it. So the first way is given, let's say we have, source and dest IPs. And so, we have external IPs and hitting our various internal IPs. And then maybe it's already pre-aggregated a little bit. So we kind of have, for different flows, kind of the beginning and the end. So in Zeek, you might have something similar. And then a bit of like labeling for the IDS. And so we have accounts. So maybe some like pre-aggregation. The first thing we're going to do is like one of the most simplest views of it is like, could I just see my network? So this is a network perspective. So I have IP addresses. Can I just connect these two columns? And so I'll just plot that on the fly. We just take that data frame, and then that's enough that we can start kind of getting some perspectives on it. And so I want to, and also the history. So if you wanted to play at home, whatever, free tier, all that stuff. So this is already pretty interesting. So I can kind of see a little bit about what's going on. So we have one internal, 172 range computer here. We have another dominant computer, 172 range here. And then we have some kind of external IPs in the middle that are hitting both of them. And so I can already see from the topology, like what's going on there. And also like this computer and that computer, we also have a ring of other computers. And again, if I kind of go through, I can see that they're mostly external. If I really want to verify that, I can, click and start like scrolling through the, if I look at the edges, I guess we'd be looking at the sources that we see that these are all kind of external. So that's kind of interesting already from the perspective of, if I'm looking at a log dump and you just gave me, I'm not really sure what this means, but at least like if you show me this, I could sort of kind of start like doing that reasoning process I told you. So, and this is one of the most simplest graphs. It's just basically you're not really trying to do anything clever. You're just trying to directly model the physical data. These are physical entities, like this lives in your data center, lives in your cloud. This is like real, maybe real people, real things like that. But again, this is coming from an IDS perspective. So now might starting want to kind of get a bit more insight out of it. Actually, I'm gonna show one more example here that's just sticking at the physical level of like why this is interesting. And here we're going to take that same data. So this is one of our like older data sets we've played with, but I think it just kind of illustrates the point pretty well. In a more realistic scenario, like let's say I'm kind of like in an enterprise scenario, I might have something like, I don't know, like 2,000 devices or like 10,000 devices, or in this case, 64,000 devices that for some snapshot of time, I'm getting sensor alerts on. And so if I want to look at the IDS data for that, and I just kind of want to play with it, oops, let me load this one more time. If I want to load that in, that's all of a sudden, like I really can't kind of just like look at the pure logs for that. So of course our demo gods are not with me on this. So one sec, let me change one thing. We'll give it one more go. Let's see. I love doing live demos, but this is also the rough side of doing live demos.
One question, meanwhile you go through that. So
the
image that you show with all the dots when you cannot even see, that was something like that, like a relationship. Is that what you usually see like in big real environments, I guess?
Yeah.
Like,
yeah,
right?
I can't name the company, but this is actually, I'll just stop the clustering here. This is actually a real company that I'm actually showing you. This is like a real enterprise network. And these three computers, like imagine if there's like a vulnerability scanner or a port scanner, like maybe it's probably is like, maybe is a security device, but maybe it was not a device, but like that, this is actually this is probably like a real scan where this guy is kind of like going all the way through. And like, we're actually seeing that, right? And like going back to actually what Ashwin was presenting on the Databricks side, seeing cases where like a security or fraud, they'll just have a big transaction dump and they just want to look at it. Like you just, digital data is basically infinite. And so being able to take like a bigger chunk of it, like you kind of get these things. This one's actually particularly interesting because what's kind of fun is that you start seeing these like dominant correlations where it's like, okay, maybe this computer is very dominant. This computer is very dominant. And then maybe this computer is very dominant. And so I'm just kind of knocking these out one by one. But even at this perspective, without doing any complicated modeling, so I just knocked out those really dominant, oh, didn't get that guy. But then once I recluster without those, yeah, so we just kind of got rid of that thing here. All of a sudden now, instead of just being focused on that thing over here, actually, yeah, this thing's still kind of taken over. Let's get rid of this guy too. Okay, now if I recluster, now all of a sudden I have like another level of correlations going on, because like those port scanners were just so heavy on the data. It's just like the top correlation for all those events. But now once I kind of got rid of those, now when I'm kind of correlating what sort of activities are left, I now start getting kind of richer structure. I might do something like, for example, on the maybe color it based off of the type of the device or the vendor that's doing the alert. And now I can kind of see a bit more structure. So let's just let that kind of load in. So here where we're seeing it's mostly this firewall data, of OS logs and a little bit of IDS logs. I could filter down even further just to those. But anyway, yeah, but going back to your point, like the reason I want to kind of bring that up about like what real data looks like when you're actually starting to really look at it. I really like this thing called the streetlight effect, where this policeman sees this guy stumbling under like the street lamp at night, and he asks like, this is where you lost your wallet. And then the guy's like, no, I lost my wallet in the park, but this is where the light is. And what that's kind of getting at is like, when we're looking at data, like maybe we're comfortable with like maybe Splunk or Elk, and that's where because even if that doesn't have the insight, or the tool can't get us the insight that we're looking for, that's what we're comfortable with. And so that's the only way we know how to kind of get there in a reasonable amount of time. So even if we suspect we're not going to get it there, we don't really have any confidence in our ability to get that insight anywhere else. And so either we don't at all, or if we need to feel busy, we'll still go back to those tools that we know don't. And so kind of when I'm showing those kind of bigger graphs, like that kind of an interesting thing is just being able to see it, and then being able to kind of get like, basically it lets us shine the light somewhere else. And then if we can do it on these bigger data, I was kind of showing you there, it kind of lets us have even a bigger spotlight. And especially when it gets into real data or enterprise data, it gets really hairy really fast. Jump back here. So that without even really thinking, like that's just a physical rep, like using event connect our physical data, like events basically are connecting them. So, but the same, remember this is like IDS data, right? Kind of alerts associated with it. And so what we might next do is like, okay, remember it's a honeypot looking at it, like maybe we want to see what the different attackers are doing. I can imagine doing it in two ways. If I was just going to work on this simple view, remember we have some kind of vulnerabilities. I might do like color based off of the vulnerability and try to see which events are kind of which vulnerability. So for this honeypot node is mostly by this net API vulnerability by all these attackers, but I'm also seeing some yellow and green over there. I'm not really sure what those are, but like this my doom, of course, and some IIS stuff. And so from a direct graph, I know that it's going on, and I can make like I'm on a 1-by-1 case, I can kind of see those correlations. But if I want to see that general correlation between maybe the attacker and the vulnerability, I can actually just directly connect them and let the visualization do the work for me. And so again, now we're going to do the same graph, except for we're going to have the attacker as the source column, but now we're going to switch to the vulnerability as the destination column. That's all I really changed. Just for aesthetic reasons, I did this thing. And so now what we have is, for example, that same MS net API alert, we're seeing a bunch of attackers are using this. But what's actually kind of interesting is that these are not using anything else. They're just using, it's like they're going to try one thing and leave. Well, if I kind of look over here, we're seeing this like MaxDB vulnerability, and these attackers here are using both that and that IIS vulnerability. And so now all of a sudden I'm starting to find a kind of a correlation, different kinds of patterns between the vulnerabilities and the attackers and how they're doing it. And like, for example, what's also kind of fun is we're seeing my doom, and at least for the tools we're using, only these two attackers my doom, but this one actually used all three. And so let's say we have overlapping campaigns using kind of like maybe there's some vulnerability that came out and everybody's trying to use it. There might be multiple campaigns or waves, or maybe one campaign is evolving. All of a sudden, I can actually kind of start seeing those correlations just by, again, pretty simple graph, just just taking 2 columns and trying to see those correlations. Now, I can kind of keep doing that trick. Like maybe I don't care about, maybe I'm a defender and I just want to see which of my assets are getting targeted in different ways, for example. Maybe I'm like, I'm going to skip this one, but like any 2 dimensions, you could probably come up with some sort of story. Now, the next level is like, well, if I'm just interested in correlations in some data set, maybe I could just look at a bunch at the same time. And so why am I doing this one by one by one? I'm just kind of making all these small graphs. And that actually is a pretty deep concept. And so that's something we call a hypergraph. This is all of a sudden going to be a different kind of graph. And the idea is in the weird math world, which they make it sound really complicated. And it's a little mind-bending how they describe the edges can connect multiple nodes. Normally an edge is between a source and a dest, but what if an edge can actually connect or correlate multiple things? And while that sounds weird, when you think about event data, it's actually one of the most natural things you can do. And what I mean by that is, like, let's say we have one alert or one event, and it mentions multiple pieces like names, IP addresses, different like account IDs. That one event should correlate or connect multiple of those entities. And that's actually a hypergraph. It's just fancy math for that. So we can try taking a look at that. And again, we're going to take that same honeypot log, but now what we're going to have on screen all at the same time are, the attacker, the defender, the name of the vulnerability alert, and then actually the port being used. And I'm going to actually color based on the type of data, because now all of a sudden we have multiple types of things, so it's getting a little confusing. So let's do that. I'm also going to go full screen. Okay, so what's going on here is in red, we have each of our IDS alerts. And then all the other colors are other kinds of data. So in green, we have the attacker IPs. And in purple, we have like the victim port. In orange, the vulnerability name. And then yellow, the victim IP. So all of a sudden, what I see here is like, they're kind of all attacking this one computer. They're basically mostly doing it on port 445 and mostly doing it on this vulnerability. Looks like they're actually that's kind of neat. We do also, somehow these attackers here are also using this other vulnerability, but they're not using that vulnerability when they're attacking this guy. They're actually the only time they use that vulnerability is when they went to actually attacking this guy over here. But now all of a sudden I'm starting to see like a richer view of correlations inside of that data, where I'm like, okay, there's kind of like a dominant activity, characterize it in terms of like common dominant themes are like this port, but occasionally that port. The other kind of dominant attack is over on this guy, and then I keep kind of like enumerating what are the top correlations. And so this ends up being kind of a pretty cool and organic way to just do all the correlation analysis. And it's also, as an analyst, it's kind of neat having all of the events here. Do I have? And if I want to drill further, like I could inspect attributes like one at a time. So for example, I can click on one of the events and I can put it on it. But I could also, for example, for time, I just want to see if there's like any temporal patterns. And so, for example, I'm going to color on the attribute. So again, I'm going to get back to why that's so important in a bit. But I'm going to color on the time attribute, let's say cold to hot, if the demo gods are with me. All right. Maybe we'll get to that. But basically, what I am seeing here is based on the identifiers. I could see the correlations, but then using things like coloring and sizing, maybe I could size on it. I don't know if that'll work. Okay, I should probably tested this before the talk. But it basically, like when there are attributes in the data, I might be curious. I think I could do it this way, maybe. I can kind of see as I hover over time, like different, like over time where different parts of my graph are sort of activating. And I could start kind of getting a bit of a time analysis. In the beginning, ooh, maybe that was a bad idea. Anyway, so what all I was getting at is there's stuff that was inside the graph, but there's also attributes. Now I want to give one more view of that same data, just to kind of show even this notion of a hypergraph that actually play around with it. And so what I'm doing here is fairly similar, but I'm doing one change. Let's color the data based off the kind of the column that it came from again. And so here, when we're looking at that same honeypot, now like we have those 2 victim IPs. We have in red all of those attackers. So these guys are attacking those guys. And then for the IDS alerts, or actually the port numbers are in green and the alert names are in purple. The thing that we don't have anymore is we don't have those event nodes. That's actually an option whether we want to kind of show them, be kind of bipartite on the event node or not. And what that now means is if I want to get the event data, I have to kind of click on one of the edges. So if I know, for example, this computer and this port, these are all the events that we're sort of linking those together. This is kind of nicer when I'm kind of more zoomed out, basically. Like I don't have to have a dot on screen for every log line. So sometimes it's not, I'm kind of summarizing it a little bit. I'm gonna, so this is all from like a honeypot perspective. We did a fun demo where like sometimes when we're using, that's kind of from a defender perspective, sometimes we're working with researchers and they might be looking at campaign data, or maybe they're taking a bunch of malware and they shredded it to pull out a lot of metadata. Actually, good job on Elastic through, I guess, their Endgame acquisition, that they actually have a cool like open source repo of a lot of kind of data sets you can play with on this. But basically, if you're trying to figure out, like, for a piece of malware or like a phishing thing, like which campaign it was part of, you might pull out a lot of that metadata. And so this is from Barncat, which actually I'm blanking. I think it was Fidelis who released this data. This was a bunch of the Barncat data, and we're doing that same hypergraph trick here, where in this case, let's color based off of node type. And in this case, you see that we have a lot more types of data, like just lots more metadata that from the malware shredding. And so we're gonna have a bigger of colors active here. And so now when we're looking at these ones, so we have like, I don't know, 36,000 relationships on screen. So kind of like a fun example when I was playing with this data that I saw, that's kind of interesting to understand. I think it was, let's see, we're seeing like the domains, the compile dates. Yeah. So pink is the compile date. So when they're looking at like sections of the files, they're curious about when was stuff compiled. And that ended up being kind of, when I'm looking at, think of like campaigns of malware or campaigns of phishing. Again, these were from the executables. Like this was a really funny one. I'm like, why is 1992 like showing up in, from like malware from the last 10 years? This is like I don't know, 30 years from now. Like this is literally like 30 years ago almost. And so that ended up being kind of like an interesting thing of like when we're looking at the compile dates to realize that when the people are kind of building these things or reassembling them, or part of their tool chain will kind of here. And like if we look like down here, for example, if you kind of look at this region here, kind of here, actually this is a good way to do it. So we'll make like a row for the compile date, and then we'll kind of take a look at this region here, and you'll see that I was hoping it would light up, but I guess not. As we kind of look around, we'll see different compile dates are sort of dominant. And again, like if we look in that bottom left area, we're seeing a few spikes show up. And so if we're separating campaigns, that ends up being pretty cool. So one more thing that again, the whole point here is like one data set, lots of kind of perspectives on that data, just like how much insight can we get. One more thing is like as soon as we have that graph, we can actually have the algorithms do a little bit of thinking for us. So here we're using something called crew graph. Again, we're going to talk about that in a little bit. But what we're going to just do, and what we find in practice, it's nice, is just given one of our pygraphistry objects, we'll just kind of enrich the node or the edge table with a bunch of different statistics on it, because once they're all there, we could just look at all of them at the same time. And so we just kind of ran a bunch of these, and now once it's there, I can kind of take that. We're going back to that honeypot from before. And now when I go full screen on this guy, I guess we're doing that last hypergraph without the event nodes here. The difference now is if I click on one of these nodes, we'll have stuff like the page rank or the betweenness centrality. The betweenness centrality might be a fun one to talk about. So for example, we'll color points based off of the betweenness centrality, and then kind of see why that is interesting. He's saying in the Discord that it's how cool is the name hypergraph. Yeah, I'm in a love-hate relationship with hypergraphs. I kind of love saying the word hypergraph, but then also that kind of freaks some people out, and so not always a good idea. Okay, so here we're coloring the metadata that we pulled out from those logs, like all those different entities, by something called the betweenness centrality. And the idea of something that has a high betweenness centrality, like this guy, is a sense that to get from like one cluster to another, it ends up being sort of like a bridging piece of metadata. And why that's interesting, this data set's not super interesting, but if you go back to, for example, when we're looking at the malware campaigns, there might be, as we go from, let's say somebody has a malware campaign or like a phishing campaign, and then all of a sudden they tweak it a little bit, or maybe it's part of like being like one person makes it and then they sell it to a bunch of people to actually do the campaigns. There might be certain things that are sort of common across the campaigns that as it's evolving, like not everything changes. And this betweenness centrality actually is a nice way to kind of algorithmically pull out the fact that there's a bridging going on. Nowadays, I might do it a little different, which we'll talk about, but just visually, the betweenness centrality is an example. And for each one of these graph like statistics, there's kind of you kind of learn little use cases like that end up being pretty handy. Before we go to the clustering, I do want to kind of take a pause. So let's say as a team, we've come out with a bunch of these different visuals. So like maybe you're in like an incident team and you have firewall data, or you're like an incident response team and you have like, host data, or you're looking at Windows logins or something, like whatever that, or maybe you have Splunk and you're doing the daily notables. It's cool to do this stuff from Jupyter, but what we found is that's a great way to start and kind of rapidly experiment. But what we found is that's not really great for the team. Like you just become that one person and like nobody else could really use it. So we've been kind of observing tricks over the years of ways to make that a little more accessible. For everyone who thinks this is cool, other people that just want to get through the end of the day and they have other things on fire. And so I think two of the ways that I've been kind of excited about and kind of observing how our users do it. One is something called Streamlit. And so what it does is it basically lets you copy your notebook code, and then you could just jump into Streamlit, you paste it in, and then it's with a little bit more work, you get some UI format. In particular, you get a few input controls. And why that matters is like if you think about from your teammates' perspective, like if you did something cool and they want to use it, they really generally don't want to see this. They don't really know how to get in. They don't know how to change the parameters. It's just a headache. But with the Streamlit, you might just put in a few like input controls, like, oh, put in the IP address, put in the hash, or like put in a time range. You just make a few kind of like obvious input controls. Then it runs through the notebook code that you copy pasted in. And then you get all this UI stuff that I was kind of showing you. You don't really have to do that much else. And so just for kind of quickly creating internal tools without having to worry about JavaScript, or with a lot of Python tools, it ends up feeling like you're writing JavaScript and HTML inside of Python, which is like even worse than having to do it at all. Well, with Streamlit, it kind of goes away. And the other one is, I think Ashwin was great to point out Databricks, actually. So we have an example of actually working with Databricks for this thing. And what I love about how they did it is you'd write your notebook, let's say like this as usual, maybe you put in your input controls, and then these cells actually become dashboard cells. And so you're actually really not having to write any of that JavaScript in Python. So like you're that stuff is cool, but like that's not really where you want your time going. And so I think Databricks did a really good job of the transition from notebooks to dashboard. But if you're not using Spark, because Databricks sort of forces you, like everything has to be Spark. By Streamlit, what I like is that you could do anything in the PyData ecosystem, which is much bigger than just Spark, right? So like, but both, I think they did a good job on the UI versus a lot of other tools. So let's jump to clustering. So an issue, like let's say we're doing the malware campaign or we're doing the honeypot, things like time matter a lot. Like, like one thing leads to another, or like, let's say we're looking at multiple users getting phished. There's a good chance like that each fish size, like maybe it's like a plus or minus a few bytes. It's like, that's polymorphic, right? And so like when we're doing the graph stuff, we can't just like correlate based off of like the file size or like the time, because it's these fuzzy parameters. And like we can kind of try to approximate it with the graph stuff. And so actually what's a little funny is the Databricks notebook we did actually has an example where we were looking at big IoT networks. And so we were looking at like some power generators. There, what we had for each sensor was a longitude and latitude. And what we did was we just sort of quantized it. So as long as like we kind of rounded the locations. And so as long as the sensors are kind of coming from roughly the same sensor from the same location, we'd be able to kind of connect them into a network. But like that's like really a hack. And so the question is like, could we do better? And so that's what I want to talk about next. So we're going to jump into clustering. So we're going to be using QML with a GPU library, but we're also, I'll be showing UMAP, which you could do with or without GPUs. So you can run it either way. And then again, we'll plot it with Graphistry. And again, we're going to be using that same honeypot data. So we want to kind of understand correlations in the data. Kind of like what I showed, the first thing we're going to have to do is sort of turn it from data into numbers. And kind of like what I was showing with the power sensor data, where we sort of quantized it and turned it from like, longitude at latitude with decimals into kind of more nice numbers. We're going to do something similar here, except what we're going to do is ultimately we're going to get it into a bunch of zeros and one, like values between 0 and 1, and we're going to do it in 2 steps. This is something called vectorization or featureization, where basically like modern machine learning, whether it's like normal or AI, it's basically matrix math stuff. And so we need to make it look like vectors to kind of feed it in. That's a kind of like a simplified explanation, but at least like mechanically that's kind of just to make the types match what we have to do. There's a bit of an art to it, and it's kind of a fun thing to play with if you have time. But like, so for example, when we have like the attacker IP address, I could take each each subnet or value and start turning it into individual numbers, for example. That doesn't exactly make sense. Maybe for a subnet it does, but like, for different values it might not. So what may make more sense is like if I'm tracking a specific like IP address, could actually make that a column to itself. And it just becomes like a 0 or 1, like, was this event log value that number, that IP address or not? And I could do that both for the attacker and for the victim. Likewise, if I'm looking at different vulnerabilities, even though it looks like a string inside of the event log, I could just make it another, like a bunch of 0 or 1 columns. Like, was this event my doom? Was this event MaxDB? And I can keep doing that. Historically, this was a bad idea for something like security data because it's just the dimensionality is so high and that you just get like thousands of columns. And historically, CPU kinds of tools would sort of die on that. But nowadays, especially with GPUs, it's great. Like high dimension, great. And so, we'll actually do like genomics with like 20,000 columns. It's fine. Like it takes a little bit of work, but like that's what a lot of the modern stuff has been built to actually scale to kind of modern data. And then the last thing we're going to do is once we like, instead of having like an IP value of like 0 to 255, we're going to want to normalize it between 0 or 1. You can think of it one way you can think about it is just making it sort of like a probability. So it's just kind of like a fuzzy thing, like where it is. Another way to think about it is kind of more of a hacker mindset. If you want one column to matter more than another, maybe the one that matters a lot more, instead of being between 0 to 1, you can make it between like 0 and 10. And so you can kind of start playing games with these encodings here. But once we do that, we can start doing all sorts of cool things. So I'm going to show 3 methods. One is really old, but still pretty important, and is called singular value decomposition. Is made in 1873, but it actually still does a pretty cool job. So we're going to run on that data there. Let's see. Let's color all of those events off of the vulnerability type. And so if I had that big bag of events, I don't know why it's not triggering. But what should have been happening, maybe I could do it this way. Yeah, this is kind of showing is like, if I kind of look along this cluster here, these are all this net API alerts. I'm seeing kind of like that's what's getting highlighted here. And so that singular decomposition was able to kind of separate that data out pretty well. PCA made in a few decades later, it's kind of the same thing. So let's run that. And again, if you just had a big bag of logs, the question is, could we just separate it out and kind of start having explanations of them? Actually, I'm going to open that. Can I open it in a new window? Try this again. So one thing, the funny thing that comes with Graphistry is we use WebSockets for each visualization. Your browser we actually exhaust the number of WebSockets we have of just the more visualizations you have open. So sometimes you'll see a blank screen. But yeah, okay, cool. So we're in. Let's color again based off of the vulnerability type. Hopefully it works this time. Great. And so as before, we had this nice separation of our events. And again, you're seeing these are all just like a few lines of code. So you'll have the notebooks. It's not a big deal. Once we separated out our events, we can kind of see like, oh, like let's say we're looking at today's notable events, or we're looking at some firewall stuff. We have this nice separation. Sometimes the separation isn't that great. So like if I'm looking at this cluster here, I don't really know, is this part of like one group? Is this not part of one group? It's not like very intuitive what's going on. Like I can start trying to like dig into individual alerts and see what's going on. But even though it sounds like the partition was great, and in reality, it's kind of a mess. And we have not as bad here, but in this one, what's harder is to understand what's going on within one of the clusters. So, but for 100 years ago, that's pretty good, so I'm not going to fault people from for what they're doing. UMAP is cool. So this was made in 2018. And pretty funny is actually the researchers who made it actually made it for cybersecurity data, but ends up being very popular in the genomics community. So it's pretty cool. So something called UMAP. I'm going to color based off of it, and let's kind of see how it's doing. And so here again, we have that nice separation, but it's actually a lot clearer now that each one of these is sort of distinct. And so that actually ends up being nice. And also within one of them, it's actually, we've got a bit more space. And so as an example, we might guess that time might be a dominant dimension within one of the clusters. So I can try coloring by time to just kind of sanity check. We'll do cold to hot. Yeah, and where we're seeing within this cluster of events, it's all this, all of these that it's like, cold to hot. And so I'm starting to kind of understand it a bit. It's still unclear, like, why is this one over here? Why is that one over there? Kind of like why are these closer to that one? And so I'll explain how this one came about in a second, but we have one more view of that same data. So we're just going to add basically these two lines here where there's a graph sitting beside this dimension, this algorithm. So now we have a bunch of these edges. So let's go full screen. And these edges give us what we call a similarity graph. So between any two of our events in our log data, we're based off of all those like 0 and 1 tables, where we kind of have a calculation of whether those two events were similar or not. And then if I cared about it, I can actually click on the edge and kind of get some more information about it. In this case, actually, we didn't populate the data, but if we did a better job, like we would have had more of an explanation of like which factors were correlated between these two events. Blame the person making the demo, which would be me. But like if I was doing a real world version, I'd have an explanation for this link. But this ends up pretty cool. So because like now, for example, now that we actually have the similarity graph for our events, I could switch from the UMAP layout to just a regular graph layout. And it didn't really change too much. Like, you know, what was top and on the bottom changed a bit. But in the reality, the interesting thing is really just that similarity graph that we got out of it. And now I could reuse those kind of filtering and coloring and slicing and dicing stuff that I was doing before because we have that similarity graph. Like, for example, when we were talking about that betweenness of how maybe one campaign might be related to another, we're actually seeing, for example, this event actually had similarities with particular events in the other cluster. And I can actually like ask, like, I could filter down to like ones where the destination is just this guy. So let's just filter on that. And here we go. Yeah, okay. And so when we're looking at that bridging event, here's actually from the different areas, like which ones are. And that was something that when we did traditional kind of clustering that we wouldn't have been able to do. But once we combine the kind of machine learning perspective with the graph perspective, we actually start getting things like a bit closer to like explanation for how to look at these. And I want to show one example of the type of place where we kind of use this in anger. So this approach of taking a lot of events and then finding the similar ones has actually become one of our hammers where, again, if we're doing, you know, if we're looking for trafficking victims, we're looking for identity fraud, we're looking for payments fraud, we're looking for bots, being able to have a bunch of these entities, and then for any entity kind of having them connected, if the algorithms believe that there's similarity, and then making that something we can play with and just make it interactive. This has become just one of our big hammers. So a group I'm involved with, Project Domino, we look for medical misinformation, and this has just become one of our hammers. So in this case, we're looking at a bunch of misinformation accounts on Twitter. We connected them when we thought, based on content, that they're doing not so great stuff. And then now we could do things like, for example, color based off of which ones are kind of most involved in something like QAnon. Actually, yeah, there we go. Let's also make those nodes bigger too. And so now, like when we did that dimensionality reduction using UMAP, we saw these nice clusters separated. We saw these accounts over here are explicitly talking about QAnon. So it's probably why they got linked together. What's kind of cool is based off of those other metadata columns, we saw that there's actually other accounts. They did talk about QAnon a little bit, but like not as heavy as these guys, or who might mention it a bunch more. But we still were able to catch that connection and do that investigation. So this has become one of our favorite hammers for investigations. Imagine like a board or something where you just dump a bunch of events and get this. So looking at time, we're actually, okay. So I'm gonna share one more kind of parting thought on that stuff. Where are we? All that correlation, like I kind of show two ways. Like one is we connect the entities together using a graph, and the other is we're kind of using numeric values using kind of more traditional machine learning. You can kind of go really deep on graph, or if you go deep in machine learning, you might get into something like neural nets. Over the last about like year, let's say year and a half, something called graph neural networks have arisen as a practical way to do both. Like they've been an idea for a while, but nowadays, recently it's actually become practical. And so as an example, like I was just talking about the Twitter data, but again, it could be any event data. We can have that event graph with the different entities there. Like maybe we have some good user, bad users. Maybe they're mentioning the same URLs. Using the graph structure, we could do a bit of that clustering, but the neural network could then, a graph neural network could use both that graph structure, but also the meta, like kind of like the numeric metadata, like, you know, timestamps, maybe scores you got from other tools. It can actually learn over them at the same time. And so we're seeing company by company, including some of the vendors who are presenting here today, their top fraud or security teams are starting to adopt this stuff. Yeah, like Amazon, Microsoft, Airbnb, depending on where you look and which team, they're starting to replace their traditional neural networks, or maybe they might go from an RNN to a GNN, things like that. So if you're into that stuff, we should chat. That's kind of a new area for us, but it's one where we've been investing in big. And one of the examples of how that changes things is all of a sudden, for example, something like Databricks or Elasticsearch is cool for text search, but increasingly how we're working as an analyst is actually vector search, which is just like a different, like once we have those 1 and 0 vectors, underneath, that's a bit how they think about it, but because we're doing our own models, we actually do our own kind of vector search. So it's just kind of changing how we think about it. So once we're trying to get these summaries. Actually, Roberto, how are we doing on time here?
So I think that we are 9 minutes, I think, over, but I just wanted to, this was very nice. So I was like just looking at all the stuff that you were sharing. So yeah, but we're over already. But if you want to finish,
yeah. So I thought I was going to do 2 for 1, but I guess you just get 1 for 1. But you will get in the whatchamacallit, the Jupyter notebooks. You're going to get one other thing. Where we're going to show you kind of will see how to do 2 things actually in it. One is if you want to do single GPU computing. So let me just jump to the example. You can do something like load a gigabyte of logs, and like, I don't know, like a PCI card could do something like, I don't know, 5 gigabytes per second nowadays. So, in less than a second, you could tear through a gigabyte of logs. And you don't even have to get a Spark cluster or anything. Like you're just there. That's just same node. And then without much, and that's just the same pandas code everyone's doing. And then a little crazier is we show how to do something where you can go from pandas to Dask, which is sort of like kind of a generalization of what Spark does. Spark does distributed data frames. Dask is sort of a more Pythonic and more loose, like you don't have to worry about just being in the SQL box, basically. It's a little more generic, but it's that same distributed data frame idea. And what's cool with the Dask QDF is it's actually running on GPUs. And where it gets a little, the notebook will kind of show you an example of doing it. But the thing that is kind of crazier, and I would encourage you to reach out if you're in this bucket, that same paradigm that will get you to like, maybe doing a terabyte of computation or like, gigabytes and make that kind of practical without going too crazy. You can actually do that per second, which is insane. The reason's actually less about the software and more about hardware and using that model to use the hardware correctly. And basically, so I think the Elastic folks had a good example of doing a disk drive where they had a bunch of storage on disk, and then they had some like Elastic query that go to a node and do something on disk. But the problem is if you have something like an SSD drive, which is kind of how they're driving down those costs, a expensive SSD drive is about 5 gigabytes per second, and a cheap SSD drive is maybe 1 gigabyte per second. That means that's how fast Elastic can go, right? Like on that node you got, like that you just can't go faster because the hardware won't let you. But GPU systems are built for bandwidth. And so what that means is nowadays, like let's say if I was in an enterprise scenario, instead of having one big SSD, I'd have a bunch of smaller SSDs on that rig. And now I can actually have cheaper SSDs. And just because I have them parallel, I can actually, and this is where we work with folks like with Pavilion. We're also starting to see this on AWS, where you just might spin up a bunch of wimpy GPU nodes. I can actually, for cheaper, get like 90 gigabytes per second just by chaining up a bunch of these. And so if I'm dealing with terabytes per second or 100 gigabyte per second for one config, that's actually now for bang for buck becomes practical. And what's kind of wild is you still write that same data frame style compute tree that you'll see in those notebooks, except for if you actually do that idea end to end, we'll actually go all the way from your disk through the memory. So that stuff's pretty, that one is not exactly in the notebook. I just encourage you to reach out because you're kind of seeing where the edge is with that stuff. But in terms of like, performance per dollar, like that, you have to do that kind of trick. Otherwise you're just overpaying. So in summary, hopefully you got like, if you have events, you really have wide data. If you have wide data, you really have sparse data. If you have sparse data, that means you have graphs. Nowadays, the easy mode is something called UMAP, which is very automatic. The hard mode, but more effective, is something called graph neural networks. So again, reach out for that side. But in the notebooks, you'll see the kind of the short code for doing UMAP. GPUs let you go bigger. I just talked about single GPU, which is a starting point. Like for T4 GPUs, they're pretty cheap. But if you want to do many GPU or multi GPU, like it's getting interesting. I think Ashwin actually was right when he kind of called out the Spark ecosystem. Like that started like 15 years ago or something like that. Like that's pretty mature, or maybe 10 years ago. But the GPU ecosystem, it started about maybe 5 years ago, and it's only now getting mature. So like it's starting to pick up and actually going cross language, like Python, R, things like that. Practically speaking, I do want to underscore, I think notebooks are awesome as individuals, but in team environments, we generally see them to kind of fail pretty hard, pretty fast. And so I really do encourage you to pair your notebook solution with a dashboard solution. Just think about building easy to use mini tools. We're finding that I do like Databricks, how they do it. I do like Streamlit, great too, but they really minimize the amount of code you have to write. I do want to say we're hiring. So if you like this stuff, send us a note. And nice. I think that's it. Awesome. Hopefully that's useful. I don't know.
No, definitely. I mean, I like the way how, one of my issues, I guess, when I was, looking at, different solutions, even like looking at stuff like Neo4j, for example, right? Just something as simple as using it, I don't know, to look into like Active Directory data, right? Sometimes it just gets, really hard to understand how you can cluster all that data. Especially an environment that is so big with so many different AD objects and other nodes. So it's great to see some type of clusterization with the colors and the different shades, and it makes it so much easier just to get to see what's going on, I guess. So yeah, that was pretty cool. For that thing, I guess you're just how do you know like which things, or how does the graph know exactly like what are the different clusters when the data is, for example, dynamic? Yeah, how does it happen, I guess?
Yeah, and actually, even going back a little bit, like I think other people are also experimenting with that stuff. Something that's not obvious and the vendors won't really like to tell you is like modern data architecture, you separate the storage tier from the compute tier. And so if you're doing like graph analytics or graph intelligence, that does not mean the same thing as a graph database. Like graph databases do help you, but from an architecture perspective, that's actually an extra piece of state you have to synchronize. And so you kind of saw how the Elastic and the Spark folks were like, it's always like, do I want to add another database? And so what's kind of interesting is with the modern compute stacks, sometimes you want to persist that stuff, but very often it's easier just to kind of on the fly transform it, work with it, whatever. And we're kind of seeing that ecosystem. And so I do like Neo4j for the usability. So it's a nice starting point, but like long-term, it's interesting to evaluate what part of it you want. So your question about like how to make it look good. I think for us, it came to a few things. One thing is we just try to make it out of the box where there's certain patterns that are common. So as long as you give us the source and desc, we try to automate coloring, we try to automate sizing, and everything else make it kind of point and click tweaking. There are certain things, so that means there are patterns we have observed that we try to bake in.
Right.
Well, if you have like a column type, like, is this an IP or was this the user column? That's actually very powerful. So you might just want to start by coloring based on the type of the data. Likewise, the time ends up being very important for causality. So if you're looking at edges linking entities, that's actually a great coloring. So just a few rules of thumbs like that actually get you really far.
Okay. So Ian, do you have a question? Anybody?
Yeah, I did kind of. I don't want to kind of be undermining your business model with graph history, but I kind of wonder whether you anticipate there being like a graph history light that's like a kind of anybody can load, maybe just with some GPU on their local desktop or laptop and do some of this kind of analysis to like take them into it with like smaller data sets. Obviously,
yeah,
very big things.
Yes. Yeah. So from our side, one thing I should mention is like free tier. So like, if you just want to go light and you don't want to install anything, you just want to go directly from a notebook or dashboard, you could just do that. And so that's the first thing. Then for lighter versions, there is Gephi, which is like a free thing that you can run locally. It's kind of like a Java desktop app.
Yeah.
But if you remember those.
Yeah. You click on something and it says, you need to install Java to get this working.
Yeah. D3, people do try D3, but Gephi, I think, does a good job of being sort of kitchen sink, where your job is not really like a JavaScript UI, a Canvas, SVG, whatever developer. And so that ends up being a lot of work. So I normally, what you saw a lot of what I was doing was actually having features work together. I wouldn't really encourage you to do that as a side project. It's just, there's like a graveyard of those.
Yeah.
But I think Gephi does maybe Cytoscape. They also have a good kitchen sink.
Okay.
All right. So one question that I had, sorry, because I know we have to go, but can you also do graph queries on the top of graph history representations? Because you talked about dashboards, right, to improve the interaction with the data, right, that is being displayed. But yeah, what about queries? Queries.
Yeah, and so this is, I think today, just like as an artifact, the different graph query languages. Okay, let's step up for the people listening. Graph query languages make certain types of questions a lot easier. Like, I want to know all connections between these two accounts, like, because maybe I have two pieces of metadata and I want to see if there's other like accounts in this ring based off of that metadata. That's a really hard thing to write in Splunk or Elastic or SQL. Like, I don't even really know how to write that. But with graphs, that becomes a lot more natural. Graph databases have to implement a query language. So there are a few different there. Neo4j and a few others have Cypher, which is very accessible. Others have more complicated ones, but they have a bit more performance because of it. But you don't need a graph database to run a graph query. It was sort of like the claim I made. There are vendors who do it purely at the compute tier here. So for example, for horizontally scalable, Travaris, one of our partners, they do like one of the more horizontally scalable CPU solutions. I haven't seen a horizontally scalable GPU solution. I think Katana might be on it. But the question is, what could you do for free? So there is Sparkle, which is, I'd say, a not the most friendly graph query language, but it is a free graph query language that you could do on a data frame. So that's an interesting option. I think it'd be really exciting to see an open source compute tier Cypher. There's no reason you can't do it. Neo4j experimented with Spark to do that, and they open sourced it, but I think the Spark people refused the PR, and so it just kind of languished. But my guess is within a year or two there should be something.
Yeah, I believe that now is part of something called Prometheus, I think, from Neo4j. I think that there's like a new project that
interesting.
Some of that. Yeah, I think they uses some of that as far as I remember, but that's so I think you have to pay for to get to that.
Yeah.
But yeah. Anyways, but well, thank you very much, Leo. Man, always a pleasure, and it's always nice to see your presentation. Man, it's so soothing. It's nice to see all these colors.
Definitely a prize for the prettiest presentation of the day. It's absorbing graphics.
It's funny as a performance person, so I'll take it. All right. Well, thanks everyone.
Yeah, thank you, man.
Enjoy.
Thank you very much.
Yeah, thank you.
And I think that's it. Ian, do you want to share something before we finish? I mean,
I don't think so. Something we seem not to have done is shared like the links to the Discord stuff on the Jupyterthon website. So I've just submitted a PR to add those.
Oh, the link for the Discord. Yep. Okay.
Yeah, just because some people have said I didn't. I couldn't find it. I didn't know it was there.
Sounds good.
Yeah,
sounds
so
good.
It should be there for tomorrow.
All right. Yeah. So tomorrow we start again at 8:30 a.m. PST Pacific time. Let's see, just making sure. Yep, 8:30, and then we start with Jupyter Notebooks Advanced at 8:35. So PST, yeah, Pacific time. I gotta keep thinking about that. Otherwise, I'll wake up at 8 a.m. already, and it's not gonna be my time yet. All right. Well, thank you very much, everybody, and I'll see you tomorrow. Thank you. Thank you, Leo. All right. Bye, everybody.
Bye.
Bye.